Hello everyone, welcome to Scalers YouTube channel. Today we are going to look into System Design Complete course. So before we move on with this session, make sure to subscribe to Scalers YouTube channel and also hit the bell icon so that you don't miss our upcoming videos. And also if you want to learn frameworks and technologies from industry leading experts, check out Scalar events, the link is in the description below. Now let's look at the topics that are going to be covered in this particular session. We'll be starting off with software architecture design, and then we'll be looking into relational data modeling. After that, we'll look into horizontal scaling versus vertical scaling. Then we'll look into various other concepts, starting off with load balancing, stateless versus stateful systems, and also load balancing in stateful systems. And then we'll look into one of the important concepts, that is consistent hashing. Moving on, we'll look into the concept of caching. After that, we'll look into one of the most important concepts, that is CAP theorem. And then we'll start off with the important things which are required for you in an interview. One is interview questions, and the final one is the mock interview. Both will show you how interview questions are asked in system design rounds. So that's all for the topics. Let's get started.
Taking more than 200 interviews, I've come to a realization that most people lack one common trait, which is to design a good relational database. Now, why this problem arises? The root cause of this problem can be attributed to that many people come from a NoSQL background, and hence they try to denormalize everything and put all the attributes in a single entity. Therefore, it becomes very critical to understand the basic fundamentals of schema design. This will not only help you in clearing the interviews, but it will also help you in building a repo and having technical discussion amongst your peer group. If you are someone who often finds it difficult to convert the real world requirements into the entity and relationship diagrams, then this video is for you. In this video, we are going to discuss about relational schema design using LinkedIn as an example. We are going to discuss about one-to-many relationship, many-to-many relationship. Apart from that, we'll also see when it makes sense to separate two entities even though the columns in both the entities are same. After this video, you will be able to convert high-level requirements into relational database schema with ease. Now, to design any relational data store schema, all you need to do is list down all the features. Then where you need to identify all the entities and relationship that will support your feature list. To do that, underline all the nouns and verbs. All the nouns will then correspond to either entities or it will be an attribute in one of the entities that you have already listed. The verbs will translate into either the status changes or the relationship between two entities. Now let's see this trick in action and design schema for LinkedIn. So let's go ahead and see how to apply those tricks in action. The first feature is that user should be able to view and edit his profile, which contains the following information. This gives us a hint that there should be a user entity table. So let's add user entity. It can be a user profile as well. Let's keep it user profile for now. Every entity that you create will have one attribute, which is ID. This will basically be used to uniquely identify a user profile. The other attributes would be coming from the next set of requirements. On top left, a user should have profile photo. On the right side of profile pic, we should also show name and contact information. So let's add these attributes inside a user profile entity. So we'll have a profile pic. Profile pic can be stored in two places. One is in the database itself. If you store the profile pic in the database, the amount of storage that is required to store all the information of the users will be very large. So it's wise to store all the images and video links that are associated with a particular profile into a file store like S3, or we can also store them in a CDN. Right? So instead of storing the profile pic, I'll store the URI, which will either correspond to S3 or CDN or maybe any other file store as well. The next information that I would have to store is the name and contact information in form of an email or phone number or both. A user can have multiple skills. So there are two options of adding the skills. The first option is add that as a list object in the same user profile table. So if I am adding this in the form of a list, how that will come up is sample values will be Java, JavaScript, and so on. Right? This poses one major problem. The major problem is that if I want to find out all the users who have Java in their skills mentioned, so the problem would be that I would have to write something like a select star from user profile where skills like Java star, which means that this is going to be a scan operation. So if I have multiple rows in my database, then I will end up scanning all the rows. If I have 1 billion rows, I will scan 1 billion rows. So this approach will not scale. The other downside of this particular approach is that I will not be able to auto suggest skills to the user, because that will be again a scan on all the rows that are present in the database. So what we'll do is we'll add one more entity called skills. Now this skill, there are two ways of adding skill, right? Either we can have the skill ID, name and user ID stored directly here. If I do something like this, then again autocomplete will be slow because there will be multiple users and multiple users will be having multiple skills. If you look closely, the two entities, the user profile entity and the skill entity, what is the kind of relationship between these two entities, right? So user can have multiple skills. Similarly, a skill can be having multiple users, right? So it's a many to many kind of a relationship. To model a many to many kind of a relationship, what you should do is you should create a mapping table called user skills. This will, again, all our entities have an ID, so it will start with an ID. We'll also have a user ID here and skill ID. And we can remove the user ID that was there in the skills object. If we read the next set of requirements, it states that we need to keep information about educational institutions and employers. And if you look closely, the attributes over here in the educational institutions and the employers are same. So what I can have is I can create an entity called organization. Inside an organization, I can have an ID field and all the other fields that are there, depicting name, start year, end year, and let's say description. And I will need to have one more type. This type will store information of institution or company. So from the looks of it, or for the given set of features, this table works really well. The challenge over here is that what if I want to add other attributes? Let's say I want to add CGPA in the educational institution and I want to add salary details inside employers. The problem here that comes is that I will have to add CGPA as a one column here and salary also as one more column. Now depending upon whether the type is institution or company, either CGPA will be null or salary will be null. Now it is not a very good idea to enforce application logic in your database. Just by looking at the database, you should be able to figure out that what are the what each column means. So to avoid such kind of a problem and to have a design that is extensible, what we can do is we can split this into two tables. One would be a education and the other one would be a company. Both will have ID, both will have name, it will have start year and it will also have end year. Type is not required because we have already split the table. But this alone will not be able to give me any sense of which user went to this particular university, which users went to this particular company. Now, what is the relationship between user and education and user and company? We would realize that a user can go to multiple companies and he can also go to multiple institutions for completing his education. Similarly, an institution might have multiple students who are studying in it. In a company also there can be many employees. So it's again a many to many kind of a relationship, and we have learned in the example above that whenever we have multiple many to many kind of a relationship, we create mapping entities. So there will be one table for user education and one table for user company. The attributes will be ID, user ID and education ID. Education might not be a better word, or the better word can be institution over here. So we'll have ID, we'll have user ID, and we'll have company ID as well. Now if I want to find out all the users who have went to a particular institution, what I'll do is I'll go to user education table and I'll query select star from user education where education ID equal to the institute ID. The next requirement is to have recommendations. Now a particular user can either give recommendations or receive recommendations. Since this is a list, it does not make sense to add this in the attributes of your particular user. It makes sense to have a separate entity. So let's go ahead and create a recommendation entity. We'll have an ID, the person who has given the recommendation, so let's say user ID for that, and it will also have a recipient ID, right? Do I need to create a mapping table in this case? Now a particular recommendation will have just one user ID and it will also have one recipient. That information is actually captured in this particular table, so we don't need a mapping table in case of a recommendation. So if I want to find out all the recommendations that I have, what I'll do is I'll go to recommendation table and I'll select star from recommendations where recipient ID equal to my user ID. So the next requirement is having connections and followers. How connection and follower work is that if A sends a request to B, that means that A will be able to see all the public posts that are made by B. If B accepts that particular connection request, then B will also see all the posts that are made by A. Let's have a design that can model this particular feature set. So we'll have a connection table. Inside this connection table, I'll have an ID, I'll have user 1, user ID 1, and I'll have user ID 2. Whenever a new connection comes in, I'll add that particular row here, and as soon as B accepts the request of A, I'll add one more row. So if I want to find out anybody's followers, all I need to do is select star from connection table where user ID 2 is equal to the given user. So for example, A sent a request to B, so A is a follower of B. So if I want to find out B's follower, I'll need to query the second column, user ID 2. And as soon as it's a bidirectional mapping, I'm adding that particular row as well. So I'll be able to find that out as well. The problem, however, is that I'm taking 2 times the space that I should be taking. So to optimize on space, what I can do is have one Boolean column called is accepted. Now if A and B are a connection, not a follower, that means that A sent a request to B and B accepted that particular request, I can keep the accepted flag as true, otherwise it will be false. Now if I want to find out all the followers of A, if accepted flag is true, then I'll query based on either user ID 1 should be equal to A or user ID 2 should be equal to A. If it is false, then only user ID 2 should be equal to A. The last set of entities that I'm going to talk about is post, comment, and like. Let's go ahead and create entities for all of them. So there will be a post entity. Inside this post entity, we'll have an ID. Now, what is the relationship of a post with a user? One user can have multiple posts, whereas the reverse is not true. One post will be written by just one user. So let's add user ID in the post entity table. Whenever you have one to many kind of a relationship or many to one kind of a relationship, add that attribute of the first entity in the dependent entity. So the first entity over here was user, so we'll have user ID inside post ID, which is the dependent one, and some text to go along with it. Similarly, in comment entity also, we'll have an ID. Comment is made by a user, so comment is dependent on user ID. Comment is also dependent on post because a comment cannot exist independently of a post. So we'll also have a post ID here. Again, this is an example of a many to one kind of a relationship, and it will also have text. Now for likes, we can have 2 tables. One is a post like table. Inside post like, we'll have ID, post ID, again one to many kind of a relationship, and a user ID. On a comment like table, we'll have the same attributes, ID, comment ID, and user ID. If you notice here, the post ID and comment ID are basically the entity IDs that this like is made on. So for example, in post like, the entity was post. In comment like, the entity was comment. We can club these 2 tables together, similar to we saw in educational and company. Combined table will look something like a like. Like will have an ID, it will have entity ID and entity type. Now this entity type can be of 2 types presently, either post or comment. Finally, we'll also have the user who has liked this particular thing. If I want to add one more entity, let's say a user can have vlogs as well. So what I'll do is I'll create a vlog table over here, and in this type, I'll add type equal to vlog as well. So without even adding one more table, my like table will work. We are going to talk about Delicious, which was a site that started off as a college project and then scaled to 5 million users. In this video, we are going to learn about vertical scaling, horizontal scaling, and the challenges that comes with it. But before going forward, please like, comment, and share this video. Also subscribe to our channel to get notified about our new upcoming videos. Now coming to the topic, Delicious. Delicious was a website that offered users to save bookmarks so that they can access it from any computer. The website was started in 2003 by a college student and was later acquired by Yahoo in 2005. This was way back when Chrome was not there and there was no bookmarking service either. By the end of 2008, the website had more than 5 million users and approx 180 million bookmarks saved. This scaled from one laptop to 5 million users. We'll start from the day it went live on the creator's laptop. Let's start by understanding what happens when you type Delicious in the browser. Now, browsers do not understand the names. They only understand IP addresses. Hence, we need a way to convert this URL into an IP address. In case of Delicious, DNS will return the IP address of the computer on which it is hosted. Now, since every machine which is connected to internet gets an IP address, and every time we connect to internet, this IP address may change. Therefore, we need to associate a static IP which does not change when you connect to internet again and again. And we need to assign this IP to the computer. To get the whole system up and running, we first need to purchase a domain name called Delicious and then map it to the static IP of this computer. If you look closely, there are two major kinds of requests involved. One is the get or the read request in form of get user bookmarks, and the second one is post or write request in form of add bookmarks. Using the IP address that is returned from the DNS, both this request will go to the same computer. And within the computer, there will be two things running. One is the application server, which will listen to all the requests that are coming to the HTTP port 80. And the second one will be the MySQL server, which will store all the bookmarks that my users are trying to save. So till now, my life is good. I'm running the website for free and I'm using campus internet. My database is set up on my personal computer, so I'm not paying anything for the resources. And I'm making money out of ads. Soon, the website became an instant hit. The user base kept on growing and the challenges also kept on piling up in the same proportion. Every time a new bookmark was created meant that there is a need for extra storage to store this particular bookmark. Now, the best available hardware at that time was around 50 GB of hard disk, 128 MB of RAM. This was basically a Pentium 4 era. To keep up with the demand, he bought better hardware, meaning he bought a better laptop, a better computer. The bottom line is he bought more RAM or more hard disk or maybe multiple cores. But soon, even the best hardware available was not enough to keep up with the growing demand of the business. In fact, most companies of the era focused on upgrading their hardware to solve the growing needs of the business. This form of scaling is basically called as vertical scaling. However, Delicious founder was different. He knew in the longer run his approach will not work. Not only he will be restrained by his system resources, but he might also lose valuable customer data if his laptop crashes. This website is not reachable when his computer is turned off. Hence, this computer was a single point of failure. To overcome the challenges of vertical scaling, his friends suggested him to utilize their own laptops or computers. The idea was to uniformly distribute the incoming requests to available computers. This mode, where we are overcoming the scalability hurdles using multiple servers and computers, is basically called as horizontal scaling. Now, we know that the client talks to the DNS to get IP address corresponding to a particular website. But the question is, the website is now running on multiple server instances. We have, let's say, 4 servers running the Delicious website. Which of the 4 servers available should be stored in the DNS? If I randomly choose any of the available server, all the requests will go to that particular server and that server will eventually die. To fix this, have one machine whose responsibility is to route the traffic to the available instances. This machine will lie between the DNS wall and the servers that I have. And the DNS configuration in the registry, I'll mention the IP address of this special machine and not of any of the instances that I have. Now the question comes, won't this special machine also die if all the requests pass through it? The reason why this special machine will be able to handle higher traffic is because it is only routing the traffic that it is getting to one of the available instances. It is not doing any compute or memory intensive task. And modern day machines can handle up to 1 million requests per second. So using this, we have solved for high number of queries per second on my system. But there is one more problem that still exists. That is single point of failure. Just like any other computer, what if my special server also dies? To solve this, we can have a standby routing server which will not serve or route any request. When my main server goes down, swap the main server with the standby server. But how do I swap? Should I change the IP address in the DNS registry? Doing this will take minutes. Can we do better? Yes, we can. Remember, we assigned a static IP to a special server. The key here is take the static IP and assign it to the passive one. Passive one meaning the standby server. The special server we just spoke about is called load balancer, and we will study more about it in the upcoming videos. Hi and welcome everyone to my new video on system design. I am Mohit Yadav and I teach at Scalar. I've been fortunate enough to work on systems that saw over 10 million concurrent users, and I've also built data pipelines that can crunch around 1 TB of data per day. Having led teams at Nutanix and Hotstar which have built such massively scalable systems, I'm here today to share the same knowledge with you all. In this video, we are going to learn about a very important system design concept called load balancing. To understand how a load balancer works, we first need to look at how a typical request flows through my entire system. A request will start from a client application. This client can be a browser, a web app, or maybe a mobile app. This client will call DNS to resolve the domain name that I'm trying to access. For example, if I type delicious.com in the browser, the request will go to the DNS server. DNS server will give the IP address corresponding to delicious.com and it will return it back to the client. Subsequent request will then go to the IP address that is returned by the DNS. This IP address can either correspond to the application server which is capable of catering to that particular request, or it might correspond to a proxy server which will act as a gateway to route requests to the application servers. Since this DNS happens to be the first point of contact for almost every request on internet, this system needs to be very scalable and available. The amount of load that this system takes is immensely huge as compared to any other system in the world. Also, the latency, which is nothing but a measure of time it takes for a system to respond to a particular request, needs to be extremely low. What would be the total latency over here? If I have to calculate the total latency of the system, it would be DNS resolution plus the request time. So request time will be application dependent, but the time it takes for DNS resolution is same for every request on the internet. If this time is high, the overall latency of the system increases. So my goal as an engineer should be latency of the DNS resolution should be extremely low. And to achieve this, we try to cache the DNS mapping at various stages. What are the various stages? We try to cache it at the browser, we try to cache it at the OS, ISPs, and then we also replicate it to DNS servers. There's one more important thing. Now assume that if the DNS servers are placed at only one geographical location, let's say US, and the requests are originating from, let's say, India, it will add lot of latency because India and US are geographically apart from each other. And that's the reason this geographical distance will add to extra latency. Typically, it takes around 200 milliseconds for a request to reach from US to India. So every request which is originating from India and is getting resolved in US will have an inherent lag of 200 milliseconds. it is not a very desirable outcome, right? So to avoid that kind of scenarios, DNS is basically replicated across the globe. And because it is replicated across the globe, updating or changing the IP address on these DNS server is not a very easy task. This change will have to be propagated to the entire world, which might take hours or even days in some cases. I have a wonderful resource in the description that you should refer to understand how a typical DNS works. Also, I would like to pause here and request you guys to please like and share this video and support our free content on system design topics and software engineering in general. Now, coming back to the topic, in the example that we considered, the DNS was just returning one IP address. It will work for most of the websites in the world, but consider this DNS resolution to be of Google or Facebook scale, basically a tech giant which have massive amount of queries, massive amount of user base, and they process billions of queries per second. In those cases, if I just return one single IP address, chances are that all the requests of the client will hit that particular instance, and there is no such instance which would be able to handle traffic of the entire world. So that machine will eventually die. To avoid this, what typically these tech giants do is they deploy multiple IPs on which the client request will resolve to, right? So instead of returning, let's say IP1, they return a list of IP. So IP1, IP2, IP3, IP4, and they send this particular list to the client. Now it is the responsibility of the client to figure out which IP to talk to. Typically, in DNS resolution phase, it tries to follow up something called as a waterfall model. What is a waterfall model? It will try to connect with the first IP. If the connection is successful, it will not connect with IP2, IP3 or IP4. If the first connection itself is successful, it will connect with the first IP. Now, if all the clients will start connecting to the first available IP, that also is not solving the problem. Even though I'm returning a list, but essentially each client is connecting to the first IP that is returned. So if I return the same IP list to every client, I will be gated by a limitation that every client will try to connect to the same IP. What DNS do is, instead of returning the list like this, they return the list in a shuffled order, meaning that it is very much possible that user 1 gets a list like IP1, IP2, IP3 and so on. User 2 gets a slightly different order like IP2, IP1 and IP3. User 3 gets a list like IP3, IP2 and so on. This way, I have successfully distributed the load to my available instances, right? Another way to do traffic routing is to use a geo-based routing strategy. That means people who are residing in India will get an IP address corresponding to India data center. People who are residing in US will get an IP address corresponding to US data center. That also bridges the latency gap. Why? Because if user sitting in India gets a IP address of the data center in US, there will be an inherent lag in resolving the subsequent request. So it makes sense to have a geo-based routing strategy as well. Now we have identified the IP address which will be responsible for answering all my client requests. This could either correspond to a single server or a gateway server which will route traffic to my available servers. If we choose to route the entire traffic to a single computational server, the only way to scale is to run our application on a better hardware. However, if we choose to route traffic via gateway server, we can add more instances as and when required, and adding more instances will help us cater to multiple or higher number of incoming requests. Another important advantage of this approach is that this allows application servers to keep evolving without the need to make DNS changes. Now this DNS changes, we have learned that it might take hours or even days in some cases. So if we have to update the code of my application server, all I need to do is add more application server, let's say AS1, AS2 and AS3, register these application server in the load balancer and deregister the older ones. And I have saved myself from updating the DNS record. If this was the one server case, the IP address of that one server would have changed and I would have to update the DNS mapping as well. Lastly, one very, very important benefit that we are getting out of having a gateway machine fronting my application server is that this gateway machine also provides a layer of security. How? All the machines that are below the load balancer can typically be in my private network. Meaning these instances can typically be disconnected from internet, and whenever they want to be using any data from the internet, it will come only via load balancer. So my load balancer is the wall that connects to the internet, and my application servers just talks to the load balancer. The load balancer also takes care of encrypting and decrypting the message and securing the request via HTTPS. So my load balancer layer can typically be HTTPS, and my application server can implement a HTTP protocol. Now there are two major types of load balancer. One is a hardware load balancer and the second one is a software load balancer. A hardware load balancer is a specialized hardware which takes care of routing the requests that are coming to it. Most likely you end up using a software load balancer which can run on a commodity hardware to route traffic. And this software load balancer is again divided into two types. One is a layer 4 load balancer and the second one is a layer 7 load balancer. This layer 4 and layer 7 translates to the OSI network layer, right? Layer 4, if you remember, is the transport layer, and layer 7 is basically the application layer. In the transport layer, the only thing that we get from the incoming request is the IP information. So we only get the source IP, and based on the source IP and the port in the incoming request, we route the traffic to the available servers. Whereas in the application load balancer, we get much more richer information in form of the headers that are passed in the request, the query params, the path params, and also the HTTP method. But what are the pros and cons of using both, right? In what cases should you use layer 4? If you look closely, in the transport, we only have to rely on source IP and port. And based on this, we route the traffic. So the amount of computation that we are doing in the layer 4 load balancer is less as compared to the computation that we are doing in application where we are processing the entire request. So in layer 4, it will be much faster to route the request, whereas in layer 7, it will wait for all network packets to arrive before deciding which server should be able to serve my incoming request. But these days, we are having much better hardware, which are drastically reducing the slowness factor of layer 7. However, there is one more distinction why you should still use layer 4 in some cases, because in layer 4 we are exposing only minimal information to the load balancer. We are only exposing the source IP address and nothing else. Hence, layer 4 load balancers are slightly more secure as compared to layer 7, where we could extract the entire information about an incoming request. The last thing that we want to look at is how do we even route traffic from a load balancer to my available application server. Load balancers keep a registry of all the available application server. So it will keep AS1, AS2 and AS3, and it will also maintain the state in which these systems are. So for example, AS1, 2 and 3 are in available state, so it will mark it with green, and if there are other servers which are not in available state, it will mark it with red, and request will not be routed to those servers. But what should be the routing strategy? Our goal is to try and optimize on the resources that we have, and based on the resources, we should route the request. One of the very trivial or the brute force way to route traffic is to send the first request to first server, second to second, and the third request goes to the third server. The fourth request again goes to the first server, fifth request goes to the second server, and sixth request goes to the third server. And we'll keep on doing this circular distribution of requests to all the available servers in my system. This kind of routing strategy is called as a round robin strategy. But as you can see, this is not a best strategy to go for. Why this is not a best strategy? We can see that the application server 2 has twice the RAM, twice the number of cores, and twice the number of disk available as compared to application server 1 and 2. Therefore, it should ideally process more number of requests as compared to the other servers. So what we can typically do is make the routing strategy in such a way that application server 2 gets approximately twice the number of requests as compared to my other available servers. How I can do that? I'll route first request to the first application server, second request will go to my second application server, third request will also go to the same server, fourth goes to application server 3, fifth goes to 1, 6 and 7 goes to application server 2, and 8 goes to application server 3. That ways, first server gets 2 requests, this gets 4, and the last server will get again 2 requests. Application server 2 is getting 50% load, application server 1 is getting 25% load, and similarly application server 3 is also getting 25% of the load. This kind of routing strategy is called weighted round robin. The other routing strategies worth mentioning over here is a least connection routing strategy. This least connection looks at the number of active connections that are there with the application server, and server with least number of active connection will get the next new incoming request. For example, if there are 5 connections to application server 1, 6 connections to application server 2, and let's say 4 connections to application server 3, the next incoming request will go to application server 3 and this number will increase to 5. As soon as this request is processed, the number will again decrement to 4. Here also, we have the same problem as in round robin strategy, that we are not accounting for the capacity of the instance. To accommodate that, here also we have a weighted least connection routing strategy where you can assign weights to a particular application server and routing will be done based on that. The last strategy that I'm going to talk about is basically a least response time strategy. In least response time strategy, we look at 2 parameters. One is the number of connection it has, and the second is the average time it takes to complete a particular request. Considering these 2 parameters, we decide which server should cater to my next incoming request. Now, all these strategies that we have covered till now work well if every app server is equally well equipped to answer my query. Meaning that if I have a query A, I will get the same response if I send the query A to application server 1, to application server 2, or application server 3. Regardless of where this query is getting processed, I will get the same response. This kind of a system is basically called as a stateless system. The last set of routing strategy that I have not covered in this video is called a hash-based routing strategy. In this hash-based routing strategy, we use the source IP address or the URL and we calculate a hash out of it. We have another video on consistent hashing to explain this routing strategy in depth. So please go ahead and watch the video on consistent hashing to know more about the hash-based routing strategy, right? This typically works on stateful systems. Again, stateful system and stateless systems is something that we are going to cover in the upcoming videos. So please stay tuned for that video as well.
Hi and welcome everyone to my new video on system design. If you are a software engineer, chances are you would have heard about terms like stateless and stateful systems. This video is a beginner's guide to understanding these terms and have practical insights about when and where to use these systems. I'm Mohit Yadav and I teach at Scalar Academy. I've been very fortunate enough to work on systems that saw over 10 billion concurrent users and have built data pipelines that can process terabytes of data per day. Now let's get started. Let's say you're building online calculator and you're asked to add two numbers. Do you appreciate that every server in the system is equally well equipped to answer this query? It doesn't really matter which user is asked to do these operations. Every server in the system will yield the exact same result. The reason each server is able to do so is because the servers are not saving any context or state. This makes every server equally favorable to answer that query. Such systems are called stateless systems because they're not storing any state, context or any data in the application server. Now let's consider another example. Let's say we are trying to build a chatbot this time and one user sends a query asking for restaurants that are nearby his location. The chatbot first saves this message in the memory and then responds with a list of restaurants nearby. It then asks the same user to pick one restaurant out of the list. Now the user, let's say, choose third restaurant, and if this request goes to the same application server, it will be able to return relevant information since it has context about the previous chat history. However, if this request goes to some other server, that server will not be able to comprehend the message properly due to the absence of previous conversation history. Therefore, in such systems, the context of the conversation really matters. This context can be decoupled from the application server by simply adding a storage layer to save the messages. Such systems where the context or the state lies within the application server are called stateful systems. Now that we understand what are stateless and stateful systems, let's take a moment to appreciate the pros and cons of each system. We'll start off with stateless systems, which are very easier to scale. The reason is that each server in the stateless system is equally well equipped to handle the request. Thereby, if the load on my system increases, I can just add or remove servers in the system and my entire infrastructure will work just fine. These systems are also resilient to server failures because there is no state which is maintained at the server, and even if one server goes down, there is no actual loss of data, and the lost server, we can just replace it with a new one and my system as a whole will work as expected. However, most of the systems that you will design will need to store some state in some way or the another. If you want to keep the system stateless, chances are that you will store this data or this state in a storage layer. Now, querying this data will involve a network I/O call. This operation will drastically slow down your system performance because you are involving a network I/O call. Reading the data from your application server will be slower as compared to doing a network call and fetching the data from the storage layer. Now let's compare this with the stateful systems. Since the context or the state of data required to answer client queries reside within the application, the latency of stateful system is much lower as compared to the stateless ones. However, these systems are not resilient to server failures. If one of the system goes down, the data that was residing in the application goes down with it. Hence, it makes sense to store either the derived data or the data which is actually very short-lived. Because of this, it is also harder to scale, right? It is quite difficult to scale such systems because with the increasing number of requests, we will have to transfer some amount of state from one server to newly added server. This might sound trivial, but in reality, it poses many risks associated with distributed systems. You would have heard somewhere that stateless systems are beautiful and software engineers should always try to design their systems to be stateless. This is true in most of the cases, right? Because we can just add or remove machines and the load of the entire system will be uniformly distributed. However, in some cases, it is essential to store the data locally in the application server as well, especially in cases where the state is very short-lived. I'll give you one very good example. Let's say you're designing a multiplayer game like PUBG. If you store the state of a particular match in a separate storage layer, the latency of the entire system would be huge. Imagine somebody shooting someone in the game. That state is stored in a separate DB and it is propagated to multiple users who are also playing the same game and they are reading from the DB. There will be a lot of lag. Hence, the latency of such systems needs to be very low. So what we do is we store the state of such applications in the application server itself. Also, it is important to note that the state of a PUBG match is very transitive. We will not need this information once the match has ended. Hence, in such cases, stateful systems makes more sense. In nutshell, just like any other system design concept, deciding which system to go for depends upon the use case in hand.
Ever wondered how games like PUBG scales horizontally? We learned that designing a game like PUBG would require us to save the state in the application server itself. We also saw that this state is very short-lived. To understand why, let us see what information we are storing about the game. Every game will have players, and each player will have to store their location on the map, their health, weapons, and the team information that they are playing in. We need to store this information only till the match is live. Once the match is ended, we can destroy this particular information because it does not make sense. If we store this information in a database, we'll end up wasting a lot of time. Why? Because we'll have to query the database every time a person requests for the match state. And this is an IO call, network IO call, which will waste a lot of time. Hence, it is critical to store this information in the application server itself. Now, in order for a match to work seamlessly, all players of a particular match must be routed to the same application server. Else, they won't be able to find the relevant data for that particular match. To achieve this, what we can do is, we can assign a match ID and ask our client to send this match ID whenever they are making a request. They can send it as a path param, they can send it as a header, they can also send it as a query param. The thing to note here is that the load balancer must ensure routing the traffic based on this match ID. In simple words, if the first request for, let's say, match ID 2 goes to server 1, all the subsequent requests of same match ID must be routed to server 1 only. Which algorithm can we use to distribute this traffic? Well, in this video, we are going to discuss one such approach. We are also going to look at its pitfall and build intuition for the upcoming video on consistent hashing. I am Mohit Yadav and I teach in Scalar Academy. I have been fortunate enough to work on scale at Hotstar and Nutanix, where I build systems which has massive read and write volumes. One of the reasons behind doing this system design primer series is to impart the knowledge that I have gained over the past 1 decade and help budding software engineers get better at architecting systems. Now coming back to the topic. Remember, our goal was to distribute the load in such a way that all the requests with same match ID must be routed to the same server. Match ID 2, server 1, all subsequent requests of match ID 2 going to server 1. The second point was that the load should be uniformly distributed. Meaning, if I have n servers, load on each server must be equal to or must be nearly equal to 1 by n. And finally, I should be able to add or remove instances from the cluster. Why? Because that is the essence of horizontal scaling. I don't want to build an infra where I have constant number of machines. My load on the system can increase or decrease. Depending upon that, the number of servers in my cluster can increase or decrease. The first strategy, if I have to think about the approach, the first strategy that comes to my mind is that I have a match ID, and if I have to route traffic to each of the servers evenly, the basic strategy that comes to my mind is that I can simply take a mod of match ID with the number of servers, which is n. This number will signify which server will process my request. Let's take a few match IDs to see how exactly this is going to happen if we have 3 servers running. Let's say the match ID is 11, 11 mod 3 is 2, 42 mod 3 is 0, so it will be routed to the 0th server. 34 mod 3 is 1, so it will be routed to first server. Similarly, 53 mod 3 is 1, 63 mod 3 is 0, which will be routed to 1 and 0th server respectively. We see that the above approach will satisfy my first 2 goals. Let's dig a little deeper to find out what will happen if we add one more server. Now my number of servers or n becomes 4. So let's consider all the examples, all the match IDs that I took in the previous case where n was equal to 3. So now since n is equal to 4, 11 mod 4 will become 3, 42 mod 4 will become 2, 34 mod 4 will again be 2, 53 mod 4 is 1 and 63 mod 4 is 3. Now let's consider the other case where we are removing one instance from the cluster. 11 mod 2, 1, 42 mod 2, 0, 34 mod 2, again 0, and 53 mod 2 is 1, 63 mod 2 is again 1. Now what is happening here? Let's consider the first case. If the match ID is equal to 11, which was getting routed to server 2 when we had 3 servers, will now be routed to server 3 when we add a new instance. Unless we transfer the data which is already residing in server 2 to server 3, our users will not be able to get the match information. And as we can clearly see from the examples that we took above, whenever there is a change in the number of servers, a majority portion of the keys will be distributed to the new servers. And this by no means is an ideal behavior. We need a way to minimize the need of data transfer whenever we decide to add or remove instances. Now before winding up, I would like to give you a home assignment. That's a maths puzzle. The puzzle goes like this. Consider initially there are m servers in the cluster and you can add or remove servers from the clusters. Let's say you do some add or remove operation and the final number now becomes n. This n can be greater than m, meaning that I have added new servers in the cluster, or it can be less than m, which means that I have removed few servers from my cluster. What you have to do is you have to write an equation using which you can find out the amount of data that will be moved. Write your answers in the comment section and we will see who gets it right. I hope you all get an idea about basic approach for load balancing in stateful systems. We will look at a better approach which is consistent hashing in the upcoming video.
How do you distribute the load evenly in stateful systems? In the last video, we saw one such approach where we used the modulo hashing. The approach works perfectly fine until we decide to add or remove the instances. Whenever we want to add the instances, a majority portion of the keys needs to be rehashed. In this video, we are going to look at a better approach called consistent hashing. I am Mohit Yadav and I teach in Scalar Academy. Now coming back to the topic, let's have a look at the problem statement again. Our problem statement is that we need a distribution scheme that does not directly depend on the number of servers, so that whenever we want to add or remove servers, the number of keys that needs to be relocated is minimized. To understand the solution, let's visualize a circle with marking 0 to a very large number, let's say 10 to the power 18. And we'll call this particular ring or a circle as a consistent hashing ring. Then we'll take two hash functions which will basically generate keys in the range of 0 to 10 to the power 18. Let's call them HS and HC. The HS hash function will be used to mark servers on the consistent hashing ring. The HC hash function can be used to mark partition key or the client ID on the same consistent hashing ring. Now to find out on which server a given key needs to be routed, we need to locate the key on the circle and then move in the counterclockwise direction to find the server. Now there are two main problems with this approach. First, uneven distribution. The server which is located at the max distance in the counterclockwise direction will get the most number of requests. And the second one is the weighted routing, wherein we might have a scenario where one server has twice the number of resources as the other servers. In that case, we need to ensure that the servers with more resources gets more number of requests. To solve for the other problems, what can we do? We can assign many labels to each server.
So now instead of having labels A, B, C for 3 servers that we had, we'll have server labels between A0 to A9, B0 to B9, C0 to C9, all marked in the same circle. Now if server B is twice as powerful as the rest, it could be assigned twice as many labels. As a result, it would end up holding twice as many objects on an average basis. This way we can be sure that the keys are evenly distributed and server with better resources are holding more amount of data. Now let's see what happens when we remove one server. Imagine that server C is now removed. To account for this, we must remove all the labels between C0 to C9 from the circle that we had, the circle which was basically representing the consistent hashing ring. This results in the object keys reassigned to server A and B. Whatever keys were residing in server C will now be reassigned to server B and C respectively. But what happens with the other object keys, the ones that originally belong to A and B? The answer is nothing, absolutely nothing. And that's the beauty of consistent hashing. The absence of CX label does not affect the keys in any way. So removing a server results in the object keys being randomly assigned to the rest of the server, leaving all the other keys untouched. And if you notice closely, all servers are still holding 1 by n amount of data. Earlier also they were holding 1 by n. When they had 3 servers, they were holding 1/3 of the data, and then when we removed one server, every server is holding 50% of the data. Now consistent hashing is used to uniformly distribute the data in stateless systems like Kafka, Cassandra, etc. It's also a very powerful tool that finds its application in the stateful servers, as well as it is a way of implementing sticky sessions in the load balancer.
My name is Anshuman and I'm one of the co-founders at Scalar Academy. If you are new to tech and you have recently heard the term caching and don't know what it means, then this video is for you. I was fortunate to see scale at Facebook. I was fortunate to be part of teams that build products that scale to millions of queries per second and billions of users. I'm here to share some of those learnings with you.
All right, so I'll try to explain caching as simple examples as possible. By the way, there is a bonus problem at the end of this video, so please do stay till the end of the video to look at the solution of that. All right, so let's imagine that you want to make milk tea. One obvious ingredient of milk tea is milk itself. And milk I find in most grocery stores, department stores that are around me. So one obvious way whenever I'm making milk tea is that I go to the department store, fetch milk from here, and then make my milk tea. This to and fro process, by the way, ends up taking a lot of time. However, one thing which strikes me is, by the way, I can buy a refrigerator. I can buy a fridge which stays in my house only, where I can buy few milk cartons at a time and I can store it here. And when I'm making a milk tea now, then as long as there is some milk present in the fridge, I can use it from here. If there is no milk present in the fridge, then I go to the department store and I buy the next set of cartons of milk. So what have I done in the process? I could still have gotten milk from department store. It's the same milk. However, I created this temporary storage, which is close to me, which is much faster for me to be able to store those milk so that I can make my milk tea faster. Plus then I have more motivation to make milk tea because I have it in my fridge. Very similarly, if you look at the design world, distributed systems world, you always have these systems that are looking for some or the other information, right? So machines talk to each other, they query for information. Imagine you load your Facebook profile page. That profile page would need to show your name, email ID, your friends, etc., etc. So for that, it would need a lot of information. So this machine would then ask for profile information for yours, which would be there in some other machine in the hard disk. And reading from hard disk is slow. If you would have noticed, When you transfer movies, etc., from your friend's laptop, those movies are written to your hard disk, and those hard disk writes are fairly slow. Very similarly, reading from the hard disk is also slow, especially if your data is lying somewhere you don't know where. So you'll have to search through the index to find where this profile information is and then fetch that data from there. However, if the same information was in RAM somehow, which is main memory, then accessing that would be faster. However, I mean, if we're talking about Facebook has so many people, so many profiles, all information cannot reside in RAM. It has to be in the hard disk, which is the same as me going to the department store every single time when I want to make milk tea. However, if I know that there are, let's say, certain profile pages that are fetched very often, that are more likely to be fetched than the other profile pages, then maybe I can create a fridge, a refrigerator, where I can store the information of these pages, so that when somebody asks for these pages, then I don't go to the departmental store, which is the hard disk in this case. Maybe I have that information in RAM or a faster memory access. I mean, let's not say RAM, some place where I can find that information faster than actually having to read from the hard disk of a different machine. That process is called caching. Caching is exactly what I did with my refrigerator to department store. It is exactly doing that to reduce the latency of fetching that information in some cases. A cache will never be as big as your total storage. There will always be cases when I run out of milk in my refrigerator, or when the information is not present in this fast storage. And that process, by the way, this is caching. And when I find data in my cache, it's called a hit. When I do not find the data because it is not present, therefore I'll have to go to the departmental store or go and read from this hard disk. That is called miss. So whenever you find data in the cache, it's a hit. You don't find it, it's a miss. That is caching. And caching is something, by the way, you encounter on a day-to-day basis. For example, you might have noticed that when you load a website for the first time, it's usually slower. But when you refresh, it loads faster. Sometimes when your internet is not working, you keep refreshing after a while, and eventually the website loads. Your internet doesn't get faster. That's not the reason why it loads. It loads because once, let's say there was an image on the website. Once that image has loaded, that means your browser has now gotten that carton of milk. So it caches that in its own memory. On your browser, on Chrome, it gets cached. So next time when you load the same website with the same image, the browser doesn't go and fetch the entire image from the other website. It only checks if it was the same image. If it was the same image, then it fetches it from its local memory, which means I don't have to go over that slow internet to fetch that image. And therefore, by using caching, I have significantly reduced the latency of fetching that data. That is caching with your browser. Systems within also do caching in various forms. One simple question I have. If you haven't seen my cap theorem video, please go and see that, because this question is slightly based off that. Imagine you are building a very consistent system. You would want that if you're doing caching, then this cache data is exactly consistent and exactly the same as the data present in your hard disk for whatever entries it has. If you're building a consistent system and you're doing caching there when I ask you to update, how do you go about updating such a system? In the context of the departmental store and milk tea example, let's say that you want your milk tea to always use the latest milk that is present in the department store, or always use the milk that is present in the department store. How do you validate that the milk that you have in fridge as of now is exactly the same milk that is present in department store? How do you do that? There is something called as Well, actually, if you look at how you would do it, there are only two ways of doing it, right? One is when you tell me that, hey, here is new milk to restock your store with, or here is new data, right? Like, which is, let's say, and on my profile name, for some reason, my name changes. So whenever there is data pertaining to me that is being updated, it does not go directly to the hard disk. Imagine this is my hard disk or hard disk storage, and here is cache. Whenever this update operation comes, it goes through the cache. So first I check, is this entry present in the cache, which is my name, is my profile cached? If it is cached, then I first update the entry in the cache, and then I update the entry in the hard disk. And only then, when both of them have been updated, only then I return success. This is called write through cache, which means whenever new milk comes to the department store, it goes through me. It goes through my house. I do a verification, and only then I let the milk pass. That is write through cache. Or the other way could be that if the database is aware of where my caching system is, whenever there is a profile update, the database tells cache to throw away whatever information I have regarding my profile, because that is now out of date. And only once invalidation has been done, only this write has been done, invalidation has been done, only then you return success. Or in the context of, again, departmental stores as well as milk, let's say whenever my department stores gets a new kind of milk, they call me up and they say, hey, look, please throw away the milk that you have in your refrigerator. It is old now. We have a newer quality of milk. And that way I make sure I'm always cooking my milk tea with the newest quality of milk that I have in the market. That way I stay consistent. That was all for me for today. I hope, again, caching made sense to you. You understood why caching happens in systems.
My name is Anshuman and I'm one of the co-founders at Scalar Academy. If you're a techie, chances are you would have heard about CAP theorem. Today we would talk about what C, A and P in CAP theorem stand for, why it works the way it does, and what does CAP theorem mean in the modern ecosystem. I was fortunate to see tech at scale at Facebook and was able to design products that served millions of queries per second and billions of users. I'm here to share a few of those learnings with you.
All right, so let's first look at why do we even need to learn CAP theorem. CAP theorem is one of the most basic principles of distributed storage. So if at all you think about building or working on distributed systems in the future, CAP theorem is a must-have, must-know. So that's why you need to learn CAP theorem. Now, before I get into explaining CAP theorem, and I would try to do that with using as simple example as possible, I want to give credit to Kaushik, whose blog I have borrowed a few ideas from. So thank you, Kaushik, for coming up with a very, very innovative example. So let's get to it, right? So to elaborate CAP theorem, I'll take example of a real world example of let's say you. Imagine I am an entrepreneur. I'm looking for ideas and I feel, you know what, like people need reminders. Let's build a service that just stores reminders, right? Which is, I get this very premium number. Imagine I name my company as ABCD. And I get this very premium number, which is 1234, 1234. People could just call me on 1234, 1234, and they can tell me what they want to remember. And then when they call me back, I tell them what they wanted to remember, and then things work. It seems to me that this is a great idea. So what I do is I set up this line. I sit in the office. Imagine this is me. Forgive my drawing. Imagine I sit in the office. Every time somebody tells me, let's say I got a call from X, and X says, hey, please remember that I have a flight tomorrow at 9 p.m. I say, great. Next time they call and they ask me, tell me what I wanted you to remember. And then I tell them, you know what, do you have a flight tomorrow at 9 p.m.? And then this seems great. I charge people very nominal amount of money to store this information, and service takes off. Everybody needs this. There's a big market. Everybody starts using it. And then I start to hit the problem. And you'll notice most systems, they start to hit the problem when they hit scale. Then I realize that I'm getting a lot of calls and I'm not enough to address all of those calls myself. So then I start to think, and then I think, sure, let me get my wife also involved. So now this number actually has me and my wife, both of us sit with our diaries where the call gets routed to either one of us, whoever is free. And when I get a call, I just very quickly, if the person is asking me to take a reminder, I just take down that reminder, right? And when the person calls me back, I respond back with the reminder. Great. I have suddenly now doubled my capacity. If I was able to take 1,000 requests in a day before, now I can take 2,000 requests because I have my wife to help me as well. Very soon I got my first unhappy customer. Mr. X calls me one day and says, hey, can you please remind me when is my flight? And I look through my diary and I realize I don't have an entry corresponding to Mr. X. And I tell Mr. X, hey, look, I don't have an entry corresponding to you. Mr. X seems very disappointed, very angry, and then disconnects the call. Now I start to think, what might have happened? Either Mr. X was delusional, or maybe there was a fault at my end. And then I see that there might have been a problem. It is possible when Mr. X wanted to store their reminder, they might have called my wife. And my wife would have stored this entry that, hey, X wants a reminder for a flight at 7 p.m. tomorrow. However, that entry is not with me because that call never came to me. However, when X wanted to understand when their flight was, they ended up calling me instead of my wife because they don't know. They only know this number, 1234, 1234. And I don't have that entry. And this is why X is very unhappy. This is what is called as consistency problem, data consistency problem, which is an end consumer might have stored some data with me, and when they ask me back, there is no guarantee that they will get the data back because it depends on where the request comes to. If the request comes to my wife, they'll get their data back. If the request comes to me, they'll not get the data back if my wife's diary has that entry. This is a big problem. If not solved, my company will die. So I start to think, and I come up with a solution. I say, hey, look, here is what we could do. When X calls me to say that, please note down that I have a flight tomorrow at, imagine 6 p.m. I'll note it down in my diary. I'll also tell my wife to note down this entry, which is also that tomorrow 6 p.m. flight. And only when both of us have written the entry in my diary, in their own diaries, then I return success. Then I tell Mr. X, I have noted down your entry. That way, there is guarantee that both of our diaries, my diary and my wife's diary, they'll have the exact same entries. Consistency of data, they'll have the exact same entries. And great, my consistency problem is solved. Now, when X calls any one of us, we can respond back with the right data points. Things were going great. One day, I again start to face a problem. One day, my wife calls in sick. She's not keeping well, so she's not in the office. What that means is that my wife, for the time being, is gone. For a day is gone. And at that very moment, another gentleman, Y, calls me and tells me to note down an entry. I say, okay, sure, what's your entry? And they tell me, you know what, I have a flight tomorrow at 3 p.m. I say, great, let me note it down. Let me, by the way, also go and tell my wife to note it down. Oh, by the way, my wife is not here. She can't note it down. And therefore, I'll have to tell Y that, hey, I can't note down your request. Your request actually has failed, which means for the entire day, I can't take in any new requests. That is a availability problem, which is my system is not available to take all kind of write requests. In the case of software systems, for example, like Facebook, you could think of Facebook saying that for an entire day or for an hour or for a few minutes, you can't make any new posts or you can't post any new photos on Facebook. That is an availability problem. So again, I'm very stressed. What do? I don't want my business to fail. So I think and I come up with another solution. I say, you know what? When my wife is not here, so I have my diary. And imagine my wife is not here, so I have written a bunch of entries. This new day comes. Whatever entries I get, Mr. X says to note down something, I'll note it down. When Mr. Y says to note down something, I'll note it down. And when my wife returns back, because I want both of our diaries to be identical, I tell her, look, you'll not take up any phone calls till you have noted down all of the additional entries that I made in the previous day. Or if she was gone for last 2 days, then in the previous 2 days. So you first note down all of the additional entries and then you start taking calls. And then my problem is solved. Now, because if X calls me and says that please note down that I have a flight tomorrow at 8 p.m., even if my wife is not in the office, I can still note down the entry and therefore I'm still available. Since my wife will come back and she'll actually catch up with whatever new entries are there in my diaries before answering any phone call. So we're also consistent, which is great. Things are going super good. And then comes another problem. One day, me and my wife, we both have fight and we stop talking to each other. So imagine I get a phone call, X says, hey, look, please note down I have a flight tomorrow at 9 p.m. I can't note it down because I'm not able to talk to my wife. And if I note it down, then and tell X that, hey, look, I've noted down your entry, then my system becomes inconsistent, right? Because my diary has now different entries, my wife has different entries, and she's still taking calls. So when this network partition happens where I'm not able to talk to my wife or other systems, then I have to make a choice. Do I want to stay consistent or do I want to stay available? If I want to stay consistent, then if Mr. X calls me and says, please note down the entry, I will have to say, sorry, I can't. My system is down. It's not accepting any new write requests. If I want to stay available, then I can take down the entry, but then I become inconsistent. So if I choose consistency, then I become unavailable. If I choose availability, then I become inconsistent. And that is exactly the Cap's theorem. Cap's theorem says that if you have consistency, if you have availability, and if you have partition tolerance, then at a time you can only guarantee 2 out of these. You can't promise all 3 at the same time, which means when this network partition happens, I would have to choose between consistency and availability. I can't have both. That's the Cap theorem. Now I have 2 bonuses to add here. Most systems that are available and partition tolerant, which is called AP, A for availability, P for partitioning, C for consistency, right? Most systems that are AP can still make sure that they become eventually consistent. What does that mean? That means eventually my and my wife's diary, they have same entries. How do I make sure of that? Whenever we start talking again, we can exchange notes. Or maybe just imagine that there's a clerk here that I've hired who just takes up all of the new entries in the last 1 hour, tells me what those entries were, so I take those down. Also, by the way, asks me what were the entries that I made in the last 1 hour, goes back to my wife and tells, here are the new entries that were made in the last 1 hour. So there might be periods in between that I was inconsistent, but eventually we become consistent. So that is eventually consistency. There is one more extension to Cap theorem that was done very recently, actually not very recently, about 10 years back, which is called as PACELC theorem. And what this theorem states is that, hey, look, when network partition happens, when my systems can't talk to each other, then sure, you have to choose between availability or consistency. You can't have both. However, there are going to be cases when my systems can talk to each other, which means there is no network partition, which is else. So else, I have to choose between latency or consistency. I can't have both. If you notice, when I made this decision that to stay consistent, I will make sure that on every single call, I will make sure my wife also notes down the entry and only then I return success. Then I'm actually waiting for my wife to note down that entry. My wife could be doing something else at that time. My wife could be answering some other call. And in that case, the entire request might end up taking a lot of time. So the latency could become high because I want consistency. However, if I was willing to let go of consistency, which is I wanted to say that, hey, look, I'll just note it down and maybe my wife could probably catch up later on, then latency could stay really low. So then you would actually have a balance between latency and consistency when there is no network partition. So that's what PACELC theorem is, which is just an extension to the Cap theorem, because Cap theorem does not talk about latency. I hope that made sense to you and I hope that was helpful. This Cap theorem is one of the most basic and one of the most useful theorems you'll come across when designing distributed systems. I'll keep doing more videos like this. If you like this video, please like the current video and subscribe to the channel. Thank you. Thank you so much.
Hello everyone, welcome to this session on system design. Primarily objective of this round is to help you guys tell you about what kind of questions you can expect in system design round, and more importantly, how do you answer in a particular system design round. So we'll take one example, we'll discuss one framework around what should be the ideal framework around discussing such questions. All right then, let's get started. So the agenda, first let me give you a brief about why these system design topics are important. They have importance in two areas, right? One is your ongoing job, and the other one is the interviews. So whenever specifically it makes sense for people who have higher experience, right? People who are coming from, let's say, 2-3 years of experience, they are expected to have some knowledge about system design, right? So system design encompasses two main components. One is the low-level design, wherein you'll be expected to either write the schema or maybe design the APIs or maybe design the class, like what are classes and interfaces, how would you design that particular code. And the other one is having a broader perspective of how different components are going to behave. So typically, to have you'll basically get around 1 hour or maybe some more time to discuss a particular system in detail during your interviews. So it's best to follow this particular framework. I've followed this particular framework for Facebook, and I was able to crack Facebook with this particular framework. And whenever you apply also, your recruiter will also tell you about the same framework that I'm going to be telling you. So without wasting more time, let me just introduce the framework to you guys, and then maybe if you have any questions, you can type it down in the comment section. I'll read the questions from there, right? So the framework has 5 steps. It's a 5-step framework. You always start with gather requirements, right? So your first step should be to gather or ask clarifying questions about the requirements. Most of the time, I'll give you side by side, whenever I'm giving you the framework, I'll also give you one example and correlate how, if for this particular question, what should be the ideal answer or ideal output. So let's suppose I'm asked to design a URL shortener, right? Let's suppose I appear for a Facebook interview, and my interviewer asks me that, hey, you need to design a URL shortener. Now, this by itself will basically give you some hints about how you should typically approach the problem. Even if the problem is 100% clear to you, you must ask some clarifying questions. Most of the time, the problem will be vague enough that you will have to ask clarifying questions. But even if the problem is crisp, clear, just reiterate the problem in the same, in your words, so that you and the interviewer are on the same page, right? So gather requirement step will basically, for example, if I'm asked to build a URL shortener, for me, the requirements can be, do I need to add personalization, or do I need to add support for analytics? Do I need to support things like expiry of a particular long URL? If somebody uses my service and I give a particular short response, for how long should I persist that particular short URL to long URL mapping? That is also a business statement, and that will dictate how my design will look like. So it is important to ask such clarifying questions in the gather requirement phase. Now, I hope the first point is clear to everyone. Let's move to the second point, which is once you've got an idea or got a sense of the requirements that you'll be building out, just write all those requirements down on a piece of paper or Google Doc or anywhere, right? If you're doing it on a whiteboard, you write the requirements, freeze the requirements on the whiteboard. It is important to note here that do not spend a lot of your time on this particular part, gather requirements part, maybe 1 or maximum 2-3 minutes on this particular aspect, right? After that, you need to spend time on estimating the scale. Now, there are multiple subsections to estimating scale. The sense or the idea that I'm trying to get out of estimate scale is, now this is also one more area, just like gather requirements, your interviewer will work with you to basically give you the requirements. You'll give certain assumptions, the interviewer will say yes or no, right? Or maybe you can ask question to the interviewer and he'll give you the answer for that. For estimate scale also, for example, if you don't know what your starting point is, just ask how many daily active users are going to be there. So for example, I was asked to design a URL shortener. I asked my interviewer how many users are going to use it, or how many daily active users are going to use it. So let's suppose my interviewer said that there will be 1 million users, which I can expect to use my service. So in the estimation scale step, what I need to do is I need to convert this 1 million daily active users to find out how much storage is going to be required to convert these 1 million daily active users. Now, my interviewer also tells me, or I tell him that hey, I am assuming that 90% of my users will just read the data and only 10% of the users will write the data, right? Now, this is one assumption that I'm making. I'll express this particular assumption to my interviewer, and based on whether he says it's a fair assumption or not, I'll change these numbers. But for our system, let's suppose these are the numbers. So 10% right means that 1 million into 10%, which means around 100k users are going to write something are going to generate data on a daily basis. Now, what is the data that these guys are generating? These guys will give me the big URL. I'll have to somehow do some transformational magic here and return a small URL in return. This big URL can be, let's say, 100 characters, and this short URL can be 10 characters, right? So this is the kind of transformation that I need to do. Let's suppose to store the entire record, I can store it using 1 KB of space. So what is the daily space that I'm going to need? The bare minimum daily space that I'm going to need for my system, it will be 1 KB of data for one record, because one record is taking 1 KB, multiplied it by the number of users that I'm getting who are generating the data on my website. How many such users are there? There are 100k. So this is 10 to the power 5, which is something around 10 to the power 5, 3 MB, around 100 MB of data, right? This is on a daily basis. So Bhagyarana says that it should be 1 million into 10 to the power, into 1 KB. It won't be 1 million. The reason it will not be 1 million is because only 10% of my users are generating that particular data. Not all of them are generating the data. The people who are generating the data, that means they're using my service to shorten a particular URL. Only those users will be considered. Hence, I've taken 100k users, right? Which basically means that I'll be storing around 100 MB of generating around 100 MB of data. And if I have to calculate for a particular year, one particular year, then it will be 365. I'll have to multiply it by 365, which would be around 3.65 or 36.5 GB of data. Right? On a yearly basis, my service is going to be producing this. Why am I not taking the read into consideration while storage? Because I'm only storing whenever a person is requesting a shorter URL for a long URL that I've got, only then I have to store that particular URL. What happens when a person wants to read that particular URL to a big URL? If a request comes for reading this particular URL, I'll go to the storage, I'll read whatever is the corresponding big URL, and I'll return it back to the user. So in that, I don't need any storage, right? So the second step, which was estimating the scale, the most important thing is to estimate how much storage you are going to require. Because this number, this 35 or 36 GB number that I've got here tells me that only one instance can basically hold this particular data. The entire data for 1 year can fit into one machine itself. If this would have been around 1 TB or more than 1 TB, I would have required multiple machines to store that particular data, and hence I would require more. Since I require more machines, I would require some sort of a sharding, right? But in our case, we've seen that it is just around 36 GB of data. One instance can handle it. There are still problems. We'll come to what are the problems, but I'm just giving you what are the numbers that we need to take care of, right? So coming back to our important parameters for estimating scale. First was with the storage. The other important parameter is to identify the TPS of your system. That means how many requests are you getting per second. That includes of write TPS. Write TPS would be that a person is giving you a long URL and you need to return a short URL for that. A read request in this scenario would be a person is giving a short URL and you have to return a long URL. So you need to find out the TPS of every system. TPS, the full form of TPS is throughput per second. People call it QPS as well. QPS is query per second. Some people call it reads per second, writes per second, and bifurcating it. Basically, the crux is that you need to find out what would be the number of requests for reads, what would be the number of requests for writes. Because if these numbers are also very high, let's suppose you are getting 1 million reads per second. That means that you need to have some sort of a caching enabled. You need to have some replication enabled, because one server will not be able to cater to 1 million IO calls. So there is a network bandwidth limitation as well. This is the reason why you should estimate the TPS as well. I hope that makes sense. Now let's move to the third important part, which is once you have estimated the scale, then you look for what are your design goals. What should you solve for in this particular problem? Design goals, if I have to just give you an idea about what typical design goals are. If you have not heard about CAP theorem, just go to our YouTube. There's a playlist on system design. Go to that playlist and see all the primer content. So there's a theorem called CAP theorem, which states that either in a scenario of a partition tolerance, you can only have either consistency or availability if you're taking the partition tolerance into account. So one of the design goals is to identify whether you're designing for a very consistent heavy system, or are you okay with eventual consistency and you prefer availability on that particular scenario. So identifying that is one part. Let's talk about the case that we are building. Do we need at most consistency? If I just have to explain consistency in 2 lines, consistency states that if there are 2 data nodes, let's say there is data node 1 and data node 2. Now, if the value of x is, let's say initially x is 5 in both the cases, then I get a write request which basically updates the value of x to 15. And let's say that particular value was written in data node 1. Now, if I fire a read request, depending upon whether it is going to data node 1 or data node 2, 15 or 5 would be returned. In a strongly consistent system, we'll get 15 as the response. In a weakly or in an eventually consistent system, I may get 15 or 5 both, depending upon whatever is the output. So do I need at most, do I require my system that every node, every data node in my system should have the exact same data? The answer is no, because there are very less updates. I'm just adding whenever I generate a big URL. Once it is copied, once it is added into the database, I'm not modifying it. So either the date value will not be there, or if the value is there, it will be same for all the cases. Right? So I don't need consistency. I can live with eventual consistency. Do I need availability? I don't want, if I've generated a particular URL and I've sent it to millions of people. Let's say it was a Google I/O event, or maybe Donald Trump, or maybe Modi ji giving some speech, and to that link to that particular speech, I have let's say shortened it using my service and I've sent it to multiple places. If those people are not able to reliably see the output or reliably able to access my service, in that case, it will be a massive hit on my website and the credibility of my website. Hence, I cannot let go of the availability part, right? So design goals, you need to identify this, that whether you need consistency or should you prefer availability. In case of a partition tolerance, we've seen, most of the cases, you would require some sort of a partition, right? So that was my third part. Having the design goals. You first identify what trade-off you will have, consistency versus availability trade-off, and the second trade-off is between latency, right? What is the kind of latency are you looking at? So let me just write it down and then I'll explain what latency means. Now, different systems would have different requirements for having different requirements for latency. For example, the URL shortener one that I've given you, if I give you, if somebody types a shortened URL into the browser and then tries to access the bigger, URL, if that particular takes time, if the lookup itself takes a lot of time, it will not be a very good indicator on the website, because let's suppose it was basically a URL representing one particular event. Now, it's not a very good customer experience if they're just spending on the resolution time, right? I'm further slowing down the service of the end provider. So since I don't want that, I need the system to be very low latency driven, right? But it is not like people might think that we would need such kind of latencies in every scenario, but that is not the case, right? All the batch systems, for example, if you build, that can have higher latency. When you sign up for Netflix, for example, it asks you that, hey, what are your choices? Do you like to select some movies that you like watching, and based on that they give you some recommendation on the once you open the Netflix homepage. Now, the same thing happens with Spotify as well. For those systems, the latency can be high. Like it is still bounded by some seconds, maybe 10 or 15 seconds, but it's higher as compared to just signing up on Netflix. You enter your email, you enter your password, and you're done. So depending upon the system you are building, you might have varying level of latency, and by varying level of latency, you can decide whether you want to build a system which is a batch system, or do you need a real-time processing system. So I'm taking a very simple example, but I hope you are getting at the point that using the same methodology, you can solve really complex problems as well. By the way, if you are interested in a very complex problem also, we take master classes. Those are free, completely free. You can join us at in one of the master classes. It's a slightly longer format, hence we get to pick up slightly difficult topics than designing a URL shortener. So if you are interested in let's say building YouTube ingestion pipeline, that is going to happen tomorrow, right? So you can attend that. I'll be taking a YouTube. How does YouTube delivers its data to millions of customers, which are globally distributed? I'll take a session on that on Sunday, so you can attend such kind of sessions. That will have a little more complexity as compared to what we are doing right now. This is the link for the masterclass. So anyone who's interested can attend the masterclass on Sunday. It happens on Sunday, 5 p.m. Right? There'll be a couple of more masterclasses which are listed. We take masterclasses on data structures as well. We take masterclasses on the system design aspects as well. Cool. So coming back to our original problem, coming back to our original framework. So we have discussed the design goals part of it. The next part of it is so before I tell you about the next part, how do you typically build a system, right? You don't, for example, if you have to run a marathon, you don't directly participate in a marathon. You maybe start to walk for a longer distance, and then maybe you start building up stamina, then you run 5 kilometers, then 10 kilometers, and then maybe you run for a 42-kilometer marathon. Similarly, in a system design concept as well, whenever you're designing a particular system, assume that everything, right from your storage requirements, your TPS requirements that we have identified in the step 2, all those requirements can fit in a single machine. Why do we make this particular assumption? This assumption is made because if you keep everything in a single box, that means you can have any kind of flexibility. The only thing that is reduced now is all the problem is or all the data can fit into single machine, which means you can use RDS. There's no need of optimization or anything like that. We'll identify what are the bottlenecks and we'll iteratively build on top of it. We'll iteratively remove all the bottlenecks. So the last or the fourth point is basically you design for a single server. Whenever you're designing for a single server, you need to take care of DB schema. This is based DB schema. Don't directly jump to any NoSQL system. It's a major red flag, right? So even if you have worked, thoroughly on Cassandra or maybe Redis or maybe any other database, it's a red flag if you directly jump to that particular database. Always start with RDBMS based schema, right? Once you have started with RDBMS based schema, then you move to designing the APIs and writing the business logic as well, right? Now, if I have to do the same thing for design schema and do all those things for our case as well, so let's do that here. So for the let's start with the API, right? What are the APIs that needs to be there? There'll have to be a post API, which would something be like shorten, and in the body I can get the URL and expiry, right? This would be the body. This is one API. The second API is basically a get API. Get is nothing but slash whatever is the short URL, and then there's no body in get, and you give long URL as the response. So these are the two main APIs that needs to be there. I won't spend much time into how we design that. That's a separate topic in itself. How do you design REST APIs? What makes URL RESTful? What does not make a URL RESTful? All those things we'll consider later. Like that's a topic of discussion for a different session. I won't go into that. Then you have to design the schema for this particular problem. The schema for this particular problem is a simplistic one table schema. You can have something like a short URL, you can have a long URL, and you can have validity, which user generated this, and maybe created at, and maybe some other 3-4 other tables. But the main columns are short URL and the long URL and the validity. Right? These three columns are the main columns. Using these three columns, I can answer both the APIs that I have listed out. Right now, I have done just a quick checklist. I've made the DB schema. I've made the APIs. The only thing remaining is using what should be the business logic. Now, if you think about the business logic, this problem can be solved in variety of ways, right? One of the way to solve this particular problem is to have one ID field here, right? This ID can be an integer, and whenever you store something inside a database, that ID will get automatically generated, incremented to be precise. So it started with 1, 2, 3, 4, 5, whatever is the number, that is the shortened URL, and that will not go beyond, we are generating only 100k users per day and some 36 GB of data per day, which means that your shortened URL will not go beyond a certain limit, right? It will not go beyond 6 digits or 7 digits or maybe 8 digits, right? Whatever big URL you're getting, you just return the ID and that will be the shortened URL. But that is not a good approach, right? I hope everyone can realize that it will not be a good approach if you just rely on the database auto-generated ID. Why that won't be a good approach? Because that's easily guessable. So if I have, for example, I used your API and I used your API to generate a small URL, and then what I did was I just you returned me 54. That is telling me that hey, there are 53 other entries already present in the database as well. So I can just query using 52, 53 and find out who all are using your services. So it's easily guessable. So that's out of picture. The second approach. So first approach was basically relying on auto-generated ID, right? The second approach, which I think Rahul has also pointed out, is around using the UUID or maybe using the hash function like MD5 or SHA-256 and things like that. By default, we cannot use UUID. Why? It's a 32-bit character. Essentially, we don't require anything like this. Why? Because it is generating 32 bits of characters. I don't need 32 bits.
MD5 also is 32 bits. SHA-256 is 256 bits. I don't require these many characters. Why? So let's look at how many numbers I can generate with one single character, or how many URLs can I store with one single character. With one single character, I have 26 choices of alphabets plus 10 digits, 0 to 9, 10 digits. So around 36 choices I have only with alphanumeric characters if I use it for shortened URL. If I also include the casing, I'll also introduce another 26 characters, which makes the total tally to 62. So with a single character, I can represent 62 big URLs. So let's suppose my big URL was this. I transformed it and I said that, hey, I will represent this big URL with A, and I'll store this particular mapping to in the database, right? Now, how many URLs can I store using two characters then? The first 62, the first character can represent 62. The other character can also represent 62, right? So it will be 62 into 62, which is equal to 62 raised to the power 2. How many for with 3? 62 raised to the power 3, and so on. How many with n characters? 62 raised to the power n. So even if I have 5, right, 62 raised to the power 5 is, I think, somewhere in millions or billions, which will do my job. In case I need more, I can add one more, 62 raised to the power 6 probably, and I will get my response. I will get my final. So Shivans Dubey says it will be 62 into 61. No, I can use A and capital A again. So for the other character also, I have the same, exact same. Repetitions can be there. Anyways, in either of the cases, 61 or 62, that really doesn't matter. What I was hinting or what I was approaching from this particular discussion was that there'll be exponential number of combinations that I can create with a limited set of characters. So I have solved one part of the problem, right? The part of problem that which all characters or what should be my business strategy to come up with to represent million or a billion long URLs. That I have really solved. I've solved for that. What I've not solved for is the guessability factor, meaning that if I have if I return someone AA or maybe a AB, right? Let's suppose I return AB. This really tells me that there has to be a URL generated with AA. So what can I do to remove this guessability factor? Any thoughts on that? How do I remove the guessability? So what I can do is I can generate multiple messages with, or I can pre-compute all the numbers, right? I can pre-compute everything, and then I pick up the first million and then push it into a set, a hash set. A hash set will just randomize it, and then I can just iterate on the key set. Once I have accessed a particular code, I can save it in the database. That will basically ensure that that will basically ensure that guessability factor is removed and it is scalable as well. So that was my point number 4. How do you design system that can work in a single machine, right? Design for a single system or for a single server. Now, to add scalability factor, we need to, what can be the bottlenecks? That one server is not enough to cater to my high read TPS. In that case, what can I do? I can have multiple servers who are running this piece of logic, and each server is responsible for, each server is basically responsible for generating its own version of code, right? So I can say, let's suppose I have running 26 servers, or let's suppose I'm running only 3 servers, server 1, server 2, and server 3. I give 1 million pre-generated coupons for this one, 1 million to this, and 1 million to this, right? So as and when I'm adding new servers, I'm giving this 1 million set of pre-generated codes that can be used by that particular server. While assigning this 1 million coupon codes, I can ensure that there is no collision. Once these codes are residing in the memory of the server, I'm not introducing any new latency, and I'm ensuring that the data, I have designed a low latency system that can scale to millions of users as well, right? So that was the basic idea.
right? You go for first four steps. You gather the requirements, you estimate the scale, you find out what are the design choices or the design trade-offs that you need to make. Once you've identified that, the next step is to basically design your system that can work on a single system. That will involve writing some DB schema. That will also involve writing APIs and also finding what is the core business logic that we should support, right? Once that is done, then is scale for the numbers that you have identified in this step, estimate scale step. How do you basically scale for whatever you have decided? Once you have discussed all the approaches and all the problems, then you go back to the gather requirements, the MVP stage. In the MVP building stage, you have written some requirements. Just go through each requirements one by one and validate that whatever you've written is working fine, and all the features that you've discussed earlier are taken care of, right? So this was the basic idea. Now let's jump into the question, and I will stop the screen share. Yeah, so he was asking that while I was estimating the scale, won't I consider the read ones as well? Because there were the number of users who are doing the read and the number of users who are doing the write operations are different. Hence, I think the question came that read ones should also be stored. I think that is not required, because whenever you have to write something to a database, only that amounts for your storage. Read ones you'll consider while calculating the TPS or throughput on your system. Then you'll basically have to consider the read request as well. His another question was that expiry of URL, would it be 24 hours, 1 week, availability must? So that's a valid question, which you should definitely ask when you're appearing for interviews. I didn't clarify while I was designing it, but I had taken the expiry from the client itself. Whoever is generating the URL can typically tell me that when is it that he wants this particular URL to expire. By default, I can have some, keep the link open for maybe years, but you should have a fixed expiry to all the, whatever you're adding in the database. And this is a very key concept if you think closely about it. Expiry can save you from adding or having to add multiple, shards as well. Why? Because if you don't have expiry, your data will keep on growing, right? It will go on a linear scale or exponential scale depending upon how people are interacting with your service. But if you truncate older data, that means your same single database instance can serve the request as well. So that is actually very important, that you clarify with your interviewer that what is his expectation out of the expiry. Most likely, if he asks you to design a URL shorter, even expiry will not be a explicit ask, right? This is something that you as an interviewee should have clarity on. You should ask that particular question, right? Cool. Batch versus stream, when to use, right? That's a very interesting question. I think it actually depends on your use case, right? For example, in some cases, batch processing does make sense. I'll give you one example, right? For example, ClickBuzz. Let's suppose we have a website like ClickBuzz. Now, ClickBuzz have started, let's say, one game wherein people can play or people can chat live during or comment on anything while the match is going on. After the match is over, they'll find whatever or whoever has the maximum number of like on a particular comment, they'll reward that particular user. Now, in this case, either you have both options. Either you can stream all the comments that are coming and then have an aggregate on number of likes each comment is getting. Or since it's a one-off activity after, which is supposed to happen just after the match, you can also use a batching system here. I would use a batching system here solely because it's a activity which will happen only after the match, right? If you see IRCTC website, that goes down after 11:30 p.m. every day. That is because they want to reconcile everything. It's a batch process. The salaries, for example, are a batch process. Where I would need a stream, I think a stream processing engine would make sense. For example, if I want to do some cloud deployment and I want to check whether in real time, are there any security anomalies in my cloud deployment, right? Or for example, any kind of an audit that I want to maintain, right? For example, if somebody launches a EC2 instance and he has attached a public IP to that particular instance, that is a opening into my VPC cloud, which is a security threat. And ideally, I would want to catch it in real time. So over there, I would go for the stream processing engine, because I want to have a live action defined for every outcome that is happening, right? Okay, I think that's a very good question. His question was, when I was defining the schema, right? When I was defining the schema for my URL shortener, I didn't add ID. ID I added later only when I was, going to the business aspect of it. But a quick yes or no in your mind, just keep a yes or no in your mind. Do you think a primary key is required in this case? Let's talk about yes and its implication of having a external ID. If I have an ID internally, all the MySQL or RDBMS system, what they do is they sort the data physically based on ID. So ID 1 will be placed closer to 2, will be placed closer to next to 3, will be placed next to 4, and so on. So this helps in fast retrieval of data, because they're able to look up for that particular key in a very fast manner. Now, my primary lookups, I have seen this many people doing this, that they just add ID for the heck of it. There is no real use case of it, right? For me, my ID is the most of the time my requests are going to be short URL. Given a short URL, what is the end long URL? That is going to be the reads. To optimize for that, I'll keep the short ID as my primary key. It is unique, right? And I want the data to be fetched using that. Hence, having an explicit auto incremental or any kind of other ID is not required. Just having a short URL will serve my purpose. So if you want to go deeper into it, just read about locality of reference. It's a very important concept, primarily used in DBMS systems. So you can typically go ahead and look into that. UUID, Hashbase, and all those systems does not work solely because they generate 32-bit numbers. And let's suppose I skim the last 5 or last 6 also, then also there'll be many chances of collisions. So dealing into those areas will just be problematic. Pseudo random number generators. So for anything that you're doing with randomness, right? Either the range has to be a lot, meaning, for example, for 32-bit number MD5, that is basically a good enough hack to generate a 32-bit unique number, or I can go with UID and generate a random number. But if my range is limited, now let's just to give you an example, let's say I have only 2 numbers, 0 and 1, and I ask you to generate a random number between 0 and 1. You generated 0. Let's suppose the first number that you generated was 0. I again ask you to generate a pseudo random number. Let's suppose again you generated 0. And again I ask you, and again 0 was generated. Right now you just have one number remaining, and there are many chances of collisions. There are 50% chance of that you generate the number which was already generated before. Now let's increase the range of your numbers. Now you have 0, 1, 2, 3, 4 numbers, right? Let's suppose 0, 1, 2, these 3 numbers are already generated. The probability of generating a new random number which has not been used earlier is just 0.25. 75% chances are there that you'll generate the number which is already generated. So as you keep on exhausting the available resources, the operation which was already O1 operation is basically tending to ON, right? You can take n chances to generate that particular number. If you have 100 numbers, the probability of one number getting picked up is 1 by n. So if you have out of the first 100 numbers, you've filled up 99, the probability of generating the number which is not used randomly is very, very less, right? So it's 1 by 100. So you have to take 100 tries, then find out that particular number. in a best case, in a probabilistic kind of a case scenario. So that's not a very good, way to find it out randomly. Randomness helps you in some cases, but randomness is not a good enough criteria. So you can search for this particular problem. It's a very famous problem asked in interviews as well, asked in coding interviews as well, that if you have one array, and you want to pick up random indexes in an equal probability. So let's suppose you have numbers from 1, 2, 3, 4, 5, 6. Out of these 6 numbers, you want to give equal probability to each number and find out and generate a random number out in this. How would you do that, right? The standard way of doing that is you always generate a number from, since you had 6 places, you generate a random number from 0 to 5. Whatever is the index, let's say 3 is picked, you swap 3 with the last element and you decrement the range. Earlier, the range of finding out the random number was 0 to 5. For the next iteration, it will be 0 to 4. For the next iteration, it will be 0 to 3, and so on. And you keep on swapping the index of element which is getting picked with the last value. How is the server assigned a set of million records out of all the possible records? I think I have discussed this problem very briefly. You can generate all the sequences, first million sequences, then second million sequences, and third million sequences. Whatever is the sequence that you've generated, put it in the hash set. Hash set will automatically rearrange the keys, right? It is not a list typically keeps everything in order. If you put it in a hash set kind of a data structure, it will automatically jumble up the records that you're getting, and that will basically ensure that you're getting a random ID every time. Batch processing would be Amazon order, salary, stock market. Yes. Stream processing, live sentiment analysis. Sentiment analysis also can be done using batch processing. Might not be it actually makes sense if you want to triage or maybe alert or mark as misinformation on Twitter or Facebook these days. So yes, you can use sentiment analysis, which can be a stream. Let's take this question. He says, if we are pre-assigning the short keys, won't it be time taking for searching available key to assign as if we are trying to create on a particular second? No. So let me explain this process. Let's suppose these are my available slots. Now, what I need to do is, whenever a request comes, I need to pick one number out of it randomly, right? And assign it to the incoming request. This is stored in memory. In memory meaning this is stored on the same server on which my application server are running, right? So let's suppose the first request comes and I generate the random number. The random number which was generated between 0 to 6. I generate a random number between 0 to 6, and that returns me 2. So what I do is I return 2. 2 is now assigned to the big URL, and I move 2 here, right? So 2 comes here. So 2 comes here, and 6 comes here. All right. So the new array now becomes this. Next one number again comes. So what I'll do is, now I'll decrease the size. Size is till this. So I'll generate a random number between 0 to 5. Let's suppose the number that came was 1. What I'll do, I'll move this 1 to this. I'll swap the 2 numbers. What will be the resultant array? The resultant array would be 5 will come here, 1 will go here, and size minus minus. If I have to generate new next random number, what I'll do, I'll take random of 0 to 5. Let's suppose 1 is generated. Now 5 and 4 will be exchanged, right? So the data will become 4 here, 5 here, size minus minus, and so on. I can just continue this. So using this way, I can find out, generating a random number between two numbers is very easy, right? It's an O1 kind of an operation. So using this particular approach, I can find out keys, and I can ensure that the guessability factor is maintained to a certain extent. And how do I distribute if I have multiple? Let's suppose I just have 10 buckets each. So how do I distribute? 10 buckets means that one server, let's suppose, can handle only 10 keys. How do I distribute them? I have a list of 200 URLs that can be generated.
I pick the first 10 and I send it back. I save this 10 in the first server. That is how I can ensure that each server has 10 keys to work with. All right, guys. Thank you so much, guys, for joining in. Bye-bye. All right, we are live. Hello, everyone. I am Mohit Yadav, and today we have with us Lokesh, who will be mock interviewing with us. The topic for today would be a topic around system design, and I let you introduce yourself and tell me something about yourself, Lokesh.
Hi everyone. My name is Lokesh. I'm currently working as senior software engineer at Akamai. So I'm totally having 6 years of experience. So prior to Akamai, I worked at Big Basket. So currently at Akamai, I'm working as full stack developer. So I'm graduated from IIIT Newsweed in 2015. Yeah, so that's it about me.
Sure. Cool. So I'll just quickly tell the format for our viewers as well. I'll be asking questions. Lokesh will be answering me, and wherever I feel that I can, add some valuable feedback, I'll probably give that feedback to you, Lokesh, and to the wider audience as well. Right. So
Sure.
instead of giving the feedback and keeping the feedback for the last, I'll probably keep on giving the feedback as and when we go around. Right. Cool. So I think there are a few users who have joined us. Let's wait for a couple of more minutes before we get started. Meanwhile, I'll also share the screen. So whenever you talk about, if there's a need to draw something on a whiteboard, I'll use my iPad to draw that particular thing for you. For example,
Sure.
if you say the load balancer, I'll draw a load balancer for you. If you say something
Sure.
other things, maybe application servers or databases, I'll draw those databases as well for you. Right.
Sure.
Cool. So let's get started. The question for today is: you need to design a Google search type ahead. How would you go about designing that?
Okay, so basically, so if I look at the requirement, so basically, when users type something on UI, so he needs to get the list of suggestions. So in the drop down, so that's the basic requirement. And coming to the suggestions, so the first thing is the suggestions should be sorted by the popularity in the decreasing order. So the most popular should be at the top, or the most search are most popular.
Okay.
So and also sometimes, I mean, we also need to take care of the muted votes. So I mean, we don't want to show some pirated or some adult, so some kind of votes we don't want to show, so we need to filter them. So that's also one requirement, so we need to filter them.
Okay.
So I'm just thinking, so popularity and so I think for this, so I'm assuming we need to display top 10 popular votes, I mean popular phrases only.
So
um,
let's just say top 5 would do.
yeah, okay, fine, yeah,
Top
top
five.
5, yeah, top 5 votes.
Right.
And so yeah, and also the most important thing is, it should handle the typos. So if we make any typos, the user make any typos, so it should handle that. So that is one vote, I mean one requirement. Yeah, so I'm assuming this is the scope of this system, I mean, as per the functional requirements. So and
Anything
so
else that you see in a typical Google search? For example, if you search for weather and I search for weather, we'll be shown different results.
Okay, you mean the informational results. So should we also
Right.
consider, is it like
Correct.
so? Okay, so that means, like, Prime Minister of India. So in the drop down we'll get the answer for that. So you mean those
Not the
information?
answer. For example, if I type Prime, I watch prime time news a lot. So for me, the suggestion can be prime time. Let's suppose you search prime minister a lot.
Okay.
So for you, prime minister will come.
Okay. 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 Got it. So using the cookies, so user cookies or personalization. So user
Correct.
personalization recommendation. Yeah. So
Right.
personalization. Yeah, that is true. That I missed it. Yeah, that's one of the thing. And so also we should we consider the location based search or
Yes.
not? Yeah.
We
So we
can.
can.
This is basically the first phase, right? Where we just scope
Yeah.
out that just by looking at Google search type ahead, these are the 5 things or 10 things that are coming to my mind.
Yeah.
Now, in order to discuss it in a 45-minute interview, it is not possible to go and design each and every
Yeah.
feature. So we'll just
True.
limit the number of features that we are going to discuss. So I'll
True.
cross out popular. We definitely need to sort the result based on popularity. That's a must-have. We
Yeah.
don't have to filter words. We can assume that filtration is not required. So
Okay. Yeah.
this is something that we can remove.
Okay.
Top 5, again, top 5 is a primary requirement for Google search, so we need to have that. Typo handling also we can ignore. Personalization and location based suggestions are also something that we can ignore for now. Right?
Okay.
We may discuss it if we have time towards the end, the
Exactly. Yeah.
personalization bit, right?
Yeah.
So let's start with these two, popularity and top 5.
Yeah. So so these are the functional requirements, and coming to non-functional requirements. So basically, so the system that I want. So the first of all, I mean, if I go by cap, so the system should anyway have to handle the partition tolerance because of the network failures or any failure. So the partition should be always there.
Okay.
And then if I want to choose, that means, I mean, basically, the scalable. So I'm actually choosing scalability to be my first priority, and also so over availability and consistency. So for this case, I actually go with availability. The reason being, why I do not go with consistency is because so I mean, like eventual consistency is okay. So instead of strong consistency, eventual consistency is okay for this system. I'm thinking, why? Because I mean, sometimes I mean, even though if we are not, so let's say we have some top 5 results, but let's say we are I mean, we are showing let's say the incorrect one. Like in the, let's say there is a term which is top 5, but we are showing top 6, or I mean one, I mean, which is misplaced. So that is fine. Like it can eventually propagate, and we can show. So that's why I'm actually going with availability and the scalability. So and coming to scale estimations. So I'm actually, so first of all, the number of requests. Basically, since it's a scale of Google, so I'm thinking maybe some 5 billion requests per day at the scale of Google. I'm thinking.
So how did you come up with this particular number?
I mean, so basically, I mean, I just came with random because so obviously the request will be billions. I mean, taking Google search. So that's why I came with, like, some 5 or 10 billion. So 5 billion I came up with.
Okay, a good way for scale estimation, right? This is
Okay.
I'm basically giving you feedback. A good way to do scale estimation is to look at the daily active users, and
Yeah,
then
exactly.
deduce what are your TPS and storage requirements would be, right?
Yeah.
So Google has I think close to 2 or 3 billion. Let's for the sake of calculation, let's assume that Google have 1 billion users. And every user maybe queries at least once a day, uses
Yeah.
Google search at least once a day. So there will be 1 billion queries per day. These are the reads. and every read
Exactly.
is contributing to the write as well. So I'll leave
Exactly.
the thought here and let you continue the thought.
Exactly. Yeah. So this system is actually read and write. I mean, so read and writes are equal here. So that means 1:1, and so that means here it is 1. So we are so thinking. I mean, we are having that 1 billion requests per day. I mean, because we are having 1 billion users. So coming to coming to the storage. So I think we can leave this here, and then coming to storage. In our system, so we only need to store the queries. I mean the votes or the queries. So for that, I'm thinking, so maybe so each query so each query at max may not store may not take more than so maybe like since they're strings, so and they actually, I'm thinking maybe like less than a kilobyte. So that means like something like um, some 512 bytes or something. I'm thinking like half a kilobyte. So each word. So that means we are having 1 billion requests. So 1 billion into half. I mean into 0.5 kb. So which will, I think, I need to calculate. So
This will
something.
be something in terabytes. But is that
Yeah.
calculation correct? Because although we are getting 1 billion search queries, do you want to relook at this number? Because all of them are not unique.
Yeah, exactly. So yeah, all of them are not unique. And and in our system we don't write them. I mean, so we don't write all of them, so we already may have other info. So that's why I actually so I mean the maximum threshold. So let's say we got a word or we got a phrase in the worst case that is not in the system. So in that case we have to store the whole word. So that's why I came up with less than a kilobyte, so around maybe some 256 bytes or something.
Okay.
I mean 0. Yeah, so 256 bytes. So at maximum, I'm thinking.
Okay. So we'll leave the storage part here. Let's move ahead. Let's just assume that one box is not enough to handle the entire storage data.
Exactly.
Okay.
Exactly.
Let's just assume that there were some issues with the storage. The issues were that you were reducing the size of the particular record. Instead, then what I'm arguing on is that you won't be having 1 billion records to write. Because let's say
Exactly.
I search for Michael and you also search for Michael, that will end up going in the same direction. I'll just upgrade the frequency. But let's
Exactly.
see the design first, and then we'll come back to the storage part later.
Yeah, sure. So I'll go with so the basic design. So basically when we so we can actually think of the first thing that comes to our mind is try. So I mean, to store them in a try. So it's very very trivial and obvious that I mean, by looking at the question. So that means we have to use try. So basically we'll have one node, and for each node we'll store them. Yeah. um so um so let me first try. I mean, let me first go by the flow. So basically the user sends a HTTP request so with the votes in it. So let's say user searches with Donald.
Okay.
So as you written. So basically I mean, initially I'm assuming that I have only I mean, I don't have large scale, but small system. So basically so the client sends the request, and I actually go and look up the try. So and each lookup I actually try to find uh, so I mean, if it's a successful match, that means if it's a successful vote, so then I actually update the frequency at the terminal node. So basically we know that in a try we actually store a boolean called is word to tell whether that's a word or not. So basically, so that's a word. So whenever it ends there, so in our case we also store the frequency, so which will be updated incrementally every time. So and
So one quick
yeah,
question over here. So you said that let's suppose the search query is Dawn here, right? And there is a null character over here as well. That means Dawn is also a valid word. So you
yeah.
suggested, let's say, two words, Dawn and Donald, and he clicked on Donald. So what all, where all? Now I think each node can have its own frequency.
So
Each terminal node, each node means
yeah,
each terminal
each
node
terminal.
can have its
Yeah.
own frequency. So
Yes.
which all frequency would you modify?
Yeah. So you're saying when user enters DO and Don, so we'll suggest Don and Donald. So if user clicks on Donald, so which we will increment, right?
Correct.
Yeah. So in this case, since user selected Donald, so that means we will increment the frequency of Donald. So that means the D terminal node, because
Right.
that's where that is getting hit. So this frequency we will hit. However, there are still problems with this, but we'll eventually find it out. So this is the basic approach.
So what are the
So
problems with it in terms of,
yeah,
so what I want is top
exactly.
5. How would I like, what is the complexity of your current solution basically?
Yeah, exactly. So here the problem would be, so when I want top 5, so I actually have to traverse the whole tree.
Correct.
So that means, so let's say when I said like DON, so that means from N, so I need to actually traverse through whatever the depth of that a tree, located at N. So I need to look them, and then I need to find the maximum of them, and then again I need to return them. So here the problem would be drilling down the tree. So we need to find, how can we resolve it.
Right. So
uh,
first of all, first question is, how would you find top 5 out of, let's suppose you are doing the iteration also.
yeah.
How would you actually find the top 5 elements?
Okay, so you mean so
We can do iteration. This is as good
yeah
as I have an array and I
yeah,
need to find top 5. So
exactly. So the main thing, and also basically when I so came across this top or uh, kth largest of this, so I actually think of building heap, but again, so I'm thinking, so can we store this information in the in each node, like, so as we build the try, can we actually store, so say at N, can we actually store the information that, okay, so top 5 votes at N are these, can we
okay.
actually store them?
So
Yeah.
which data structure would you use to store that?
So here I'm thinking, it would be enough if we can store the references of the terminal node. So let's say, so N at N, so D is another terminal node having some good frequency.
Correct.
So here we can uh, see here we can use a heap, uh, a max heap.
Okay.
So a max heap.
Max heap.
So we can
Okay.
so the top
Are
will.
you sure that you'll use a max heap for finding top 5?
So because here we need top by the decreasing, by the decreasing order of the popularity, right? So that means every time I actually remove the maximum at the
Mm-hmm. I lost your voice actually. Hello. Yeah,
hello.
now you're audible.
Yeah, am I audible?
Yes, you're audible.
Hello.
Yeah, hi. Hello,
Hello.
hello. I can hear you fine.
Hello.
Hello, hello. Uh, it's a recorded session. How can you say it's live? It's not a recorded session, Sahu. It's actually live. Uh, I can hear you, man. Lokesh, hi. Hello. Can you hear me? Uh, Facing technical challenges, guys. Just bear with us for some time. Can you try reconnecting, Lokesh? I'm able to hear you fine. Meanwhile, I'll just take questions that are there. So, locations-based personalized search, yes. Fast response time, yes. Hey, Lokesh, are
Hey.
you? Am I audible now?
Yes. Yes. Yeah. I think
Yes.
some glitch. I mean, yeah. Fine.
No issues. We are back. So we were discussing about that. You said we'll have a max heap over here,
Yeah.
right? So do you see a problem in that? I'll give you some numbers. Let's say these are the numbers: 4, 5, 3, 0, 6, 3, 6. All right. And let's suppose you want to find top 3 elements. So you
Yeah.
try building a heap. So you added 4 in the heap. Then you add
Yeah.
5. So 5 is added. Then you add 3. 3 is added. Now comes the value of 0. Should 0 be added or not? How do you decide that?
Okay.
Basically, you'll have to check
So,
all the elements in the heap to do that, right?
wait. So, okay, you're saying, so we want top three, right? So, okay. So yeah, in this case, we will check. Uh, yeah. So basically, we need to check the minimum element to find, but the minimum is not at the, yeah, maximum is at there.
Yeah,
Okay. Okay. Yeah. 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 That's true. So if we find three, yeah, that's true.
that's true,
So,
right?
hmm.
Yeah.
So when it came six, so we'll check with three. If it is greater, then yeah, yeah,
Yeah. So instead of this, what we could have is a minimum heap,
yeah,
a min heap basically. So 4 will be there, 5 will be there, then 3 will come. So 3 comes here and 4 comes here. Then
yeah. So
0,
we
0
can,
is not greater than 3, 6 is greater. So we'll remove 3 and we'll add 6. So that's how it will be done.
yeah,
Cool. So every node will have a min heap attached to it. The size of the min heap will be 5.
yeah,
Till that we have solved the problem. So using that we can typically answer our query in an order one time,
yeah,
right?
yeah.
So
Exactly. Hmm.
cool. So till that we are clear. What about what can we do after that?
Yeah. So this is the basic design.
Right.
So I mean, like, I'm thinking about, what else. I mean, what other problems do we have with it? So I mean, when we scale this up, so the main problem would be the storage. So, like, how do we store, try, how do we handle such a huge use scale? So basically, so one thing we can do is we can actually replicate the try. I mean, we can actually use like master slave approach by
Mhm.
having, multiple copies of tries. And then we can propagate, like, just like how in databases. So we can write to master and then schedule to slaves. So that approach we can do. I'm thinking the problem would be, so the latency would be more in this case, like,
Mhm.
uh, so I mean, writing to, so there can be replication lag, so we can add to the latency of the user. I mean the consistency can be little compromised. So this is one approach. So and also one more thing is, so this is okay, like so this is okay when we can store the try in a one machine, but but what about if we have to partition that, so that also we need to consider. So what if it
Let's
exceeds?
break it down. What are the problems with this particular approach? Let's write down all the problems and then we'll discuss
Yeah,
one by one what can be the
yeah,
probable solution. So, what are the problems? Can you identify the problems and tell me what those are?
yeah. The first problem is so I would say the data partitioning.
Uh, okay. So, I'd say storage,
Yeah,
right? What else? That
yeah,
that
storage.
entire data, the entire try that we are building cannot fit into one machine because we are storing the search, like we're storing the try of all the searches, right? So that is one problem. What is the other problem?
Yeah, so that is one problem. And so should I also consider on the client side, like what issues we'll have on client or not?
Not the client side. We are designing the backend, so let's focus our
Oh,
discussion
only
on
on
the.
the back. Okay, so and also caching. So I mean, should we have to cache some queries or something? I mean, should we implement
Okay.
caching here?
So what kind of
Uh,
caching are we doing here? This is a try,
I,
right? So try would be stored in memory, so we don't require a cache.
so I mean, like, so I mean, if there are some popular things, so we can actually return, I mean, we can actually store some entries in cache, and we can write it to try asynchronously, I mean, to increase latency, because I mean, the main requirement of the system is to have low latency to the user,
Mm-hmm.
because if you I mean as the users are typing, it should come in milliseconds. So I mean, what if we store the like popular ones on cache, and then we update them in the asynchronously to the try.
If you say, how would you identify the popular ones in that case? Is basically what you're saying is that maybe for some queries you'll save data somewhere so that those are anyways the top 10 or top 100 or top 200 or maybe top 1000 queries. You'll store it separately, and whenever the term comes, you'll give the response from there. But let's focus on the main problem. The main problem is that we need to give a consistent
Okay.
response for every system, right? We don't have to optimizing for some queries. We can do it later, but let's
Okay.
optimize for the larger set of problems. So, apart
Okay.
from
Okay.
storage, do you see any other issue in this particular approach?
Yeah, I'm thinking. So storage and so we so I mean, so main thing we need to improve is latency. So that's the main important thing so in this system. So for improving latency, I'm just thinking, so what else we can do?
So we identified. Do you think updating these top five when we are updating the
Yeah,
frequency of a Donald,
yeah, that's true.
we
Yeah.
need to update
Hmm.
D, L, all the nodes, right?
Exactly, I'm coming there. So so when we are updating the updating one terminal node, so we need to traverse back I mean, so many levels to find each terminal node and so on to till root, maybe
Mhm.
to our I mean some, and we need to update this top page. So these updations are yeah, I mean, are so here that's one problem.
So you said we need to update terminal nodes. I think we need to update every node that's there in the path till the top node. Why? Because even if a person has typed DO, there should be a heap
Yeah.
corresponding to
Yeah,
O,
that's true.
which can give
That's
you
true.
the node reference, right?
That's true. That's true. Yeah,
So
that
we'll
is true.
end up updating L, A, N, O, and right up to D. So for
Yeah.
one read, I am actually doing multiple write operations.
Hmm. Yeah, that's true. I mean,
And
so these.
while
Yeah.
I'm updating this, do you think a read can succeed?
So 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 you mean like, so we will not so we'll not update them in sync way, but we'll do it in async way. So we'll just return the result, and we'll so use asynchronous way to update those nodes. But that still be a problem, because updating those, I mean, so considering the scale, the number of requests, so the updations will be a lot.
Mhm. So, basic thing, right? Let's suppose I have one database. This is a chunk of database. I have a value of x equal to, let's say, 5,
Yeah.
right? Uh, People can come and read the value of x equal to 5. There can be multiple
Yes.
read threads that can come and read this particular value. Now, let's suppose
Exactly.
there is one thread which is trying to update this value. It wants to set the value of x equal to 10.
Yeah.
Unless this value is written, all the read threads will have to wait. They cannot read this value
Yeah,
of
that's true.
x. That's true. So if I have to
Yeah.
update the value of all the nodes, till the time I will not be able to serve the reads as well.
Yeah, right. Yeah, that's true. That's true. Yeah, I mean, so in that case, yeah, Reese has to wait till these are harm. That is true. Yeah. So.
So
Hmm.
my problem is how to make this a read intensive. It's
Read.
a read equal to
Yeah.
W kind of a system. I want reads should
Yeah.
be greater than W, much greater than W. What is a way to do that?
Okay. So to optimize reads, how can we? Okay. So question is like, to optimize reads. So I mean, how can we optimize reads? So I mean, when we have
Yes,
more reads.
yes.
Um.
Can I mold my system in such a way? Can I have some kind of a design trade-off added here, which will make my system more read friendly, and I will do writes only after. Like I need my writes to be very less as compared to the reads.
So how can, I mean, what if we have, I mean, instead of storing a big try, so what if we have, I mean, because when we are writing in a big try, one made in one try, so what if we,
Mhm.
I mean, if we chunk it and store the chunks, and based on the ranges, if we go to that particular try and only update that try, so that we are reducing the blast radius, right? So we are just reducing it. So
So
I'm. Hmm.
not sure how that would impact the number of writes. So right now, what we are doing, I'll give you a hint. Right, right now, what we are doing is whenever a person clicks on chooses one suggestion, we are updating that particular frequency over here. Do
Exactly.
you think that it makes sense to update the frequency every time a user clicks on a suggestion? By the way, guys, who are
um
looking for what
okay.
the question is we are designing a search type ahead. Yeah.
Okay, yeah. I mean, if we do not update, so then the subsequent reach will not get the top. So I mean, so uh so when we are reading, so you're saying, instead of updating, maybe we will update later, or in I mean, in some intervals we'll update. uh
Mhm.
I mean, we'll just store them and then update in regular intervals, maybe.
Yes. Yes.
Saying.
How? Yes, that you're going in the right direction. Where can we store it? How can we store that?
So basically, so whenever user clicks on that, so we are actually updating. Instead of that, we'll store them in some message queues or something. So then, in some message queues, and then we will actually have consumers that consumes maybe every hour or some regular intervals to update them.
So even that, when you're storing in a queue, that also has a problem, right? Some consumer will read that message and then come to update this particular try that we have, right? Instead of that, why not store it in a hash map? Can you use a hash map to store it somehow, and then after some frequency or after some threshold, you update the complete frequency?
Yeah, but so you're saying with message queues will have some redundancy, is it?
No, so for message queue, let's suppose I store it in a message queue. There is a Donald message here. There is a Donald
Yeah.
message here. There is a Donald message here. So I'll end up, whoever is consuming my message will end up updating the
Yeah.
queue the same number of times you have pushed the message. So
Hmm.
my
Yeah,
rights,
that
I'm
is
not
true.
decreasing the rights.
Yeah, that
Can
is
we
true.
use,
That is true.
make
That is
use
true.
of a hash map and decrease the frequency of writes?
Yeah, so in this case we'll have a map that will have the that will have the frequency of each word
Yes.
in that regular interval, and then we will update in one shot. So
Correct.
one shot we can update. Yeah,
That's true.
that is
So
that is
a criteria could be that we only update once my frequency reaches beyond 1000. And 1000 for a billion, if I consider billion search
yeah
queries, 1000
yeah
is a very, very small number, right?
yeah
So I
true.
can afford to have a error margin of 1000. I don't need to, it need not be a very accurate margin as well,
Yeah.
right? So just keep updating the frequency in a hash map, and once you reach, let's say 1000, you update for that particular keyword. So for Donald, you'll just iterate through the tie and update the frequencies
Yeah,
plus
exactly.
1000 to whatever it was earlier.
Yeah,
Right.
exactly.
Cool. So my one problem is solved about the right part. Now my reads are more, so I can add more parallelization. I can have I'll basically have lesser number of writes. So that inherently gives me an opportunity to cache or do all sorts of optimization.
Yeah.
But we still have this problem of storage. That entire
Storage.
try, I cannot push the entire try in a single box.
Yeah, that is
So
true.
how do
So
I
yeah,
get rid of?
so we can actually partition it in such a way that maybe I'm just iterating some possibilities, and we can actually look at the pros and cons. So one is so range based partition, like all A's or all B's at once, but this will not scale well. Why? Because let's say the votes at with starting with X or W may be less than the votes starting with other alphabet. So again, so that will be a problem. Or we can actually take prefixes and store by prefixes. uh,
Okay.
so maybe like so A to like from like AB to AD or something. So those prefixes, if we store.
A to, let's say, K is something, L to N is something, and X to Z, something like this, right? Maybe
Yeah.
basically bucketing. You're basically creating the buckets.
No, I mean not like that, but still, not with length of one, but maybe three. So let's say, so there can be words like so like starting with cat. So and again, there can be many words. Maybe let's say some millions of words, and if so like taking the prefix and storing by those prefixes like so AB or ABC and so on.
So I think AB is stored in one, and then AC is another one, AD is another one, and so on.
Yeah.
Okay.
So
So let's suppose with this I'll have 26 into 26 characters. These many
Yeah, machines.
combinations
Yeah.
I'll have, and it is not really necessary that I might have more machines, I might have lesser machines,
Yeah. That is
right?
also true.
So how
Yeah.
would you
Huh.
map this number with the number of machines that I have? Let's say I have
So,
n number of machines. So how would you map this? Uh, let's call this x number or x number of prefixes with the n machines that I have.
so we can actually do by hashing. So for a word we can have a hash function. So so that can actually, so when we store, so basically we'll not store all those abs in one machine, but so basically what I'm saying, so let's say we'll determine, so words starting with prefix ab or AC, AD, and so on, some X, some K number of prefixes will store in one machine. So like that will store in multiple machines.
Mhm.
Uh,
So the question over there is, I think what you're hinting at is that there'll be out of these, one machine will hold multiple prefixes as well.
yeah,
But how would you decide? Let's suppose I have prefix AA. On which machine this particular prefix should go? How would you
yeah.
determine that?
So basically, so these machines will be behind a load balancer. So where my load balancer will maintain this mapping. So this, with that mapping, the load balancer can relate to that particular machine.
Okay, so basically there is a load balancer which is sending it to one of the machines that is available,
Yeah,
right?
yeah,
But in the load balancer also, most of the load balancers are primarily stateless. So
stateless. Yeah,
you need to have a stateful kind of a load balancer over here. So do you
yeah.
know how to do a load balancing in stateful system? I'm just looking for one specific term. Anand Kumar R, you are right. You use the right term. So basically, the term that I was looking at is consistent hashing, right?
Yeah, I was coming to that. As I said,
Right.
hashing there. So
Right.
I'll actually eventually come, but this I got it. Got in my mind. Like, yeah. So consistent hashing we can do.
Right. So we will use consistent hashing. You still not answered what would be the shard key. On what particular parameter? I think this is your shard key, right? AB and AA and EC. That is what your shard key. But what will you call that? Again, looking for a specific term. You've answered that in your previously.
Okay. So you're saying these prefixes. What do we call
Yes, prefixes.
them?
Prefixes is what I was looking at. So prefix becomes my shard key.
Yeah.
And once I have these prefixes ready, I can just push it to a consistent hashing ring, and
Yeah.
it will distribute the load evenly, and it will take care of how many number of servers are there, how many number of servers are not there. So we have
Yeah.
correctly stored storage problem as well.
Yeah.
Any other problems that you see?
Mm. So can you go up? So the scope is only top and I forgot the scope. So only top
Top 5 and
and
popularity.
popularity. Okay. So popularity problem is solved, and top is also solved.
Right.
So, and we'll do optimization. So like as of now, I don't think so much problems here. So because the basic design is fine, like we can apply optimizations on these.
So we have introduced sharding. What if, let's suppose this particular application server is holding AA, BA, CA, and some more data. What if this server goes down?
Yeah.
So how would you ensure that if this server also, if a server goes down, then also your system is done?
So I need to copy. I mean, I need to have these keys in another system. So that's
Correct.
one. I mean, right. So um,
How do we do that?
1 minute. So I forgot that. So
This is nothing but replication, right?
yeah. I mean, so
This is replication.
so that means we'll keep the replicas in other machines also, right?
Yes.
Or each one. I mean,
Yes.
each
So
of the prefix. So go.
each of the prefix can be replicated to multiple servers as well,
Multiple servers. Yeah,
right?
that's what.
So
Yeah, I mean,
and that is how we can define how we are basically replicating. So I'll quickly ask you a question on consistent hashing itself, right? So let's suppose these are my server IDs 1, 2, and 3. All right.
yeah.
Now let's suppose I have one object over here.
Hmm.
Okay, this is key 1. I'll use a different color. This is key 1. Okay. Now this K1, on which server will this data will be stored for K1? Either you go in the clockwise direction or you
Clockwise
go
or on anti-clock. Yeah,
or anti-clockwise. So let's choose one convention. Let's go in the clockwise direction and let's store
clockwise.
it
Yeah,
in 2.
2.
So 2 is holding my data.
Yeah.
What is the next server? If let's suppose I set the replication factor equal to 2, that means 2 server needs to hold the data.
Yeah.
What would be the next choice of server? Should I push this data to 1? Should I push this data to 4? Should I push this data to 3? 2 is the ideal candidate. I have added the data, but I need one more server to hold a copy of this particular data. Which server out of the other 3 available is the best candidate for that?
Okay. Okay. So
Your options are 1, 4, and 3. 2 is already holding the data.
okay. So now 2 is holding. So if we assign to 3, so the problem would be. So if we assign to 3, the problem would be, since we are going in clockwise. So if 2 is also went down, for 2, we again have to store them. Store the replica of 2 in some other machine. But storing in the clockwise would be a problem here, because if 2 goes down, so we will we'll have 3 for it. Wait, I'm not able to.
So you're going in the right direction. So where will this K1 be routed if 2 goes down?
So it will be routed to 3. So so in the
Right.
clockwise, it will be routed to 3.
Correct.
So that means if we store at 3, so if 3 also goes down,
Then it's a different problem.
yeah. So that's a different
We'll
problem.
solve
But
one problem at a time.
yeah.
Right
Yeah,
now,
I think
if 2 goes down, there should be, we don't need to
3.
transfer the data from 2 to some other node. My newer queries will be routed to 3, and 3 already has the data.
Yeah.
Right. So
Yeah.
my natural choice becomes 3 in this case, right?
Exactly.
Right. Cool. So yeah, I think that is we've discussed enough on this. There is one more way to decrease the number of write operations.
Mhm.
Can anyone, you or anyone who's joined us, tell me one approach which we can use to make this property hold true? Right now, if I don't do anything, writes and reads are same. I want a system where my reads are much greater than my number of writes. One way that we have discussed is the hashing approach. Can you guys think of one more way to do this?
So as you said, hash map. So similar to that, maybe map reduce kind of thing we can use. Like we'll have a map, and then those reduced jobs will write it down to them.
What is your mapper step here?
I mean, so whatever. Okay, so in this case, so the mappers will be. I mean, so maybe if we can store the votes and map them into, I mean, into an object like I mean, similar to hash map. So how we map them, so we can transform them into the number of occurrences or number of the frequency, and then pass it to reducer.
Okay, and I still don't understand how. Let's suppose this is a Donald, again abusing the Donald name. But let's suppose this is a term.
Yeah.
What would be the mapper step over here? What operation am I doing here?
Yeah, I mean, so I think here this is not possible. Why? Because we'll have multiple objects. So, so the map step is applied only. I mean, the transformation can only be applied on one particular object. Like we cannot combine with other. I mean, I'm assuming. So that's what I. Yeah. No, I think
So,
that's not a good solution.
I'll take options that people are typing in the comments as well. So Jalkrit is saying, Jackrit, sorry, is saying that we can use a NoSQL DB as well. So any time you appear for a system design interview, you should refrain from saying terms like NoSQL. I'll use a NoSQL DB, and that will solve the problem for you. Why? See, Google search type head problem can be solved using Elasticsearch, right? It gives everything that I want out of the box. The aim for a system design interview is to judge whether if I give you a new problem, can you design it on your own? And then if your answer to a particular question is that I'll use a NoSQL DB, my question would be which DB would you use, and then I'll dissect whether you know the architecture, how that particular DB is designed or not. So unless you don't know how the architecture, how the DB is architected, do not use these terms in the interview. These are a red flag when you use a random technology and don't know what is the architectural decisions behind that particular technology. Try to stick to the basics. If you're using caching, don't say Redis. Say I'll use a cache. And when you're saying you use a cache, it should be clear in your mind that hey, this is going to be my key. This is going to be my value, and my this is going to be my retrieval pattern. Right, that is very much essential during an interview. So keep that in mind. Sorry, over to you.
Yeah, I mean, so yeah, I cannot think of it.
Anyone who's done machine learning, they would,
Okay.
I think, be able to get a better hang of it. It's a simple statistical tool, typically used in not just machine learning. Machine learning is one area, but it's a purely statistical way of doing things.
So someone said
Arpit says
Bayesian.
Bayesian. Okay, Bayesian. Not really. But what you can typically do is use sampling.
Okay.
The idea of sampling is that if it is popular, don't use average or anything like that. Just use sampling. If it is popular, right, there most of the chances, if you just skip 99 requests and choose the 100th request, it will be the request of the most popular one. For example, if it's a India versus New Zealand final that is going on right now, if I search for IND and missed out, just randomly choose the 100th request, it will be for India versus New Zealand. And because I have that kind of scale, I can just remove or let go of the 99% of my request and just choose one request that is coming to me. Of course, there will be some error threshold over here. It will not be accurate, but it will be a very much close to accurate guess, I would say. So sampling is one more thing that you can typically do. I'll only consider the 99th or maybe the 100th request. 99 request, I'll just I won't just care about it. And in fact, this sampling way is used in many applications, right? What I was saying is, so I'll just summarize what I just said, right? What I just said was that if something is very popular, like for example, if I type IND, IA will automatically be suggested because India has been searched by many people, right? If it is, if there is something else that is coming out of IND as a prefix, it will be searched by many other people as well. And by the law of averages or by the law of randomness, what I can surely say is that even if I remove the 99 first 99 requests, whatever is the 100th request, that will the probability of getting that particular number which is popular, that is really high for a actually popular request. I'll give you a small example. I'll write as let's suppose I have 4 spaces, 1, 2, 3 and 4. All right, what is the probability of picking 1? It's 1 by 4, 25, and so is the case with every other number that is there in the array. Now let's make some more interesting. Now what I've done is I've added one more 1. Now if I ask you to pick a number randomly, there are 50% chances that I'll end up choosing 1. Now let's remove 1, add one more 1 in the 4 numbers. The percentage now shoots to 75% chances of getting 1, right? And this is the law of popularity. Out of the 4 numbers that I had, 1 is really popular because it is occurring 3 times. If I choose a number randomly out of this particular batch, I have 75% chances that I will get 1. For truly popular systems, the occurrence of this 1 is over 99%, right? And that is what I was hinting at. You just sample your request, create a sample of, let's say, 100 batch. Out of that batch, pick one element randomly, and the chances are that you will end up picking up the most frequent or most frequently searched phrase. So this is a small idea about sampling that you can go back and apply in other systems as well. Yeah, I hope this leaves you with a food for thought. Yeah, cool. Anything else that you want to add, Lokesh, on the problem that we have discussed?
So on backend, yeah, I think that's it. So I mean, just one thing is that maybe on clients we need to add throttling, that so like as we are typing, so like we said, debouncing. So this term called debouncing. So I mean, that means, let's say if I type a and there's an interval like like some 600 milliseconds like that. So if I stop typing, then I should send a request. If I'm not stop typing, so I should not send the request. So that debouncing maybe we'll add on clients. So
Right.
to optimize, yeah, I think that's it from my side.
I think your voice is cracking. I don't know
Oh,
if that's just me, or
oh.
is it
So
cracking
is it
for everyone?
is it fine
It's
now?
better now.
Is it fine?
Yes,
I
yes,
mean, some
yes, that's
maybe.
yes, that's better.
Yeah.
All right. Cool. So we've discussed a problem, a system design problem with everyone, right? I think we are quite done with the 1 hour mark that are typically, added, given for a system design interview as well. I'll give you, before leaving, I'll give you guys a thought about uh, what are the typical challenges that people face during system design interviews, right? Pacing yourself is quite important, right? I think the pace that you showed, Lokesh, was spot on. We were able to cover quite a lot of ground in 45 minutes. We didn't touch upon many factors as well. I didn't go deep into understanding the how would you implement a try and all that, but I think that is not an objective of a uh, objective as well, right? We didn't go into things like rate limiting and things like how would you actually persist a try on DB, right? Everything
Yeah.
was there in memory, so we didn't go into how would you persist a particular try, so that
Yeah.
in case the server restarts, how would you handle that? We've not discussed uh, so we've not discussed the length of a particular prefix that you will add. So would you add a also as a prefix into the consistent hashing ring, or would you require a minimum length? If you're having a
Yeah.
minimum, like what are the pros and cons of all those things? That is something that we've not discussed. But I think within a given the time frame, this is a decent enough discussion. There are multiple other aspects as well that we can look at. For example, personalization. Typically, if you are interviewing for a senior role, you would be asked to go into one peripheral area. I didn't get a time to dig deeper into the other peripheral features that we had missed out. The other peripheral features are primarily there to test whether your approach or the solution that you're giving is extensible or not, right? For example, if on this particular system also you want to add personalization, how would you change or tweak your
Yeah.
system? Do you
Yeah.
require to change the entire logic? If that is the case, then your system is not extensible, and extensibility is a major component when it comes to testing out things, right? So I'll probably jump to questions that are there in the comments, right? If you have other prior engagements, I think I had blocked only 1 hour of your time, Lokesh. If you have any prior other engagements, feel free to drop off. I'll take the questions and then I'll wind up. Do you want to stay, or
Sure.
do
Sure.
you want
So
to?
so I want to drop off because my mom is waiting for dinner. So yeah,
Sure,
I'll
sure.
drop off, guys.
All right. Thank you so
Okay,
much
guys.
for your time,
Thanks.
Lokesh. Have a nice day. Bye bye.
Yeah. Thanks. Yeah. Bye, guys. Thanks.
All right, guys. So I'll take up all the questions that might be there in this particular chat window. Uh, if you've still not typed your question, please do so. If you want me to interview you on do a mock interview for you as well, please mail us your resume at youtube@scalar.com. I'll just type it down so that it's uh, visible for everyone. This is the ID that you should typically be looking at. All right, let's now go to the questions. Bhagya says fast response. Okay, these are the answers. Where are they in question? Should we handle location, current issues, and frequency, at least in count? What's the profile of the interviewee? I think Jay Kirat, we told like in the beginning we started off with the profile of the candidate. He was having 6 years of experience, an SD2 at Akamai, and prior to this he was working with Book My Show. I hope this answers your question. So Jayant has a question. In yesterday's short URL, why we use user ID for the table if you're searching for short code in the whole DB and providing the actual URL won't be time consuming. How about using a key value pair? One that was so the schema that I wrote that was primarily for a system with a very less amount of uh, which is basically designed for very less users, not for a massive scale. A KV, a minimalistic KV is the one that will work the best for a URL shortener kind of a design. So try can be partitioned based on location. That is not a good approach, I would say, Arpit. The reason being because if you break down the try on a location basis, that will be adding personalization. But what we were designing today was basically a search type head that is globally accessed, and the frequencies were also changing globally. The prefix approach that we discussed at the end is basically the correct approach. Arpit says, you should not block reads. How does it matter if the value goes a little here and there? Exactly. I think what he's referring to is that when we are writing a particular system, that is when we should never, whenever we update a particular frequency of a particular record, that is when we have to basically block all the reads because the write will take a lock on the particular record, and hence reads will not happen. So we should avoid it at all cost. We have discussed two approaches to avoid that. One is hashing and the other one is sampling. So we can use either of the two approaches to uh, to basically block down the reads and write value. So I see there are many people who have told that caching is the best way to do this particular thing. However, I would like to differ from them. Caching for a search type ahead is not a very good idea, right? We are actually caching quite a lot of things in the node where we just traverse to the node and we're finding the output. We need to understand that caching by itself is not a solution to reduce the latency. For example, if I maintain a hash map in memory, that is much more faster as compared to storing the data in Redis. So whenever you are appearing for interviews and giving your answers that I'll use caching, have instead of using caching word or instead of using this, tell them where are you going to cache it. Are you going to have a distributed cache? Are you going to cache it on the client side? Or are you going to use maybe or maybe at a load balancer, or maybe at a global cache or a DB cache? Specify what kind of caching you are going to do and what is going to be the key. Here in this case, I am not sure what can be the typical key of key for a particular cache. How many prefixes can you typically cache also, and the frequency also. What if, let's suppose I cache I'm taking the same example, Donald. If I cache Don and save the top 5 words, how would you update the top 5 frequency? That will become a problem, right? So I hope everyone who is actually attending the session understand that caching here is not the best way to go ahead. So Vishnu says NoSQL is a good option. I think I have spent some time describing that. Don't directly jump to a NoSQL database. Identify what are the requirements that you would need to design such kind of a system, and then discuss the trade-offs. Directly jumping to a NoSQL is a red flag, especially if you are interviewing for a higher up profile. For SD2, it will still be okay. But for SD3, it is a definite red flag. Is it's memory already in memory? What will you cache? What does it mean exactly, Arpit? That is what I was hinting at. What would be the criteria for caching? I think, Arpit, I've answered that. We will shard based on the prefixes. Okay. So Vineet is asking what we need to be prepared before giving an interview with you. In this particular mock interview, I had basically told Lokesh that, hey, I'll be asking you to design a Google search type ad. So the question was given to him already before he came for a mock interview. So whenever I take an mock interview with you, I'll probably give you a heads up that I'll be asking this question. The sole purpose of giving the topic beforehand is we want to have a meaningful discussion while on a mock session. In an actual interview, of course, you will not be knowing the topic, so it's important to understand the system design concepts and prepare based on that. So typically, if you want to do a mock interview with me, I can give you a topic and we can have a mock interview on that. Right? Any such stream for low level design? So this system design interview is a superset of the low level design, right? It's based on two important parallels. One is the low level design. For a system design interview, you need to design the schema. Schema designing comes under a part of low level design. I, as an interviewer, might ask you to write some classes and code for that particular business logic that I'm asking you to implement. If you are a more experienced candidate, I might spend more time in discussing about the systems. Right? If you have lesser experience, I might ask you to design the classes. For example, the same question: how would you go about designing chess? I would ask this question differently to a person who has maybe a college fresher, or maybe have 2 years experience, and maybe with a person of 10 years experience. For a person with 10 years of experience, I will drill deep into how would ensure make this particular chess game into a multiplayer game, or maybe not a multiplayer game, basically a two-player game, two-player online game. How would he bake in artificial intelligence? How would he make sure that there is no there's no cheating component that is happening in the chess tournament? So, doing uh, focusing more on the system design aspects of it for a 10 years experience. For a lesser experience, I'll probably spend time in how would you design the queen class, how would you design the pawn class, how would one extend to the other, and how would you abstract out the common functionalities. That is what I'll test probably with a 2-year experience candidate. I've learned from. Thank you so much. I hope I take it as a compliment. In memory, hash map is not scalable, can be used by a distributed server. So you can have a Redis cache as well, in case you want to have, in case you are limited by the number of, or limited by the memory that your application servers are having. You can typically take this component out in a different system itself, right? So that would not be a problem. Is it possible to try implementation at DB level in your upcoming YouTube masterclass? Unfortunately, YouTube masterclass will not use any concept of try. What we can, however, do is there are people like we also take masterclasses on data structures. We can pick this topic up in one of the data structure masterclasses, not at a system design masterclass, right? And DBs, as far as I know, there are no DBs which will allow you to persist or try. Right? You have to store it as an object and retrieve that as an object. For R much greater than W, keep cache on servers and have some hybrid approach for write through and write back policies to update the data back. Yes, Pratik, we can do that, but understand that tries are also stored in memory. So by storing by having a separate cache layer, you are not actually gaining anything out of it. The amount of time you will spend on reading from a trie will be closely similar to what you will to the performance that you will get out of the cache as well, because essentially both of the systems are reading data from memory to find out the top key elements for a particular prefix. The max you have to go for is maybe 3 or 4 characters, or maybe 5 characters max, and you'll get the complete string. So you are actually not going traversing a lot of data when it comes to having the reading it from the trie. Redis is an event-driven system and not necessarily slow need. Okay, he's answering this Anand. What is the question of Anand? Okay, Redis is single-threaded in nature. It can slow down the entire system. So Redis, even though it is a single-threaded, it can serve the kind of latencies that you can get out of Redis server is around 1 to 2 or maybe sub 5 millisecond kind of latencies. So in 1 second, you can typically serve from a single thread itself. You can serve around 500, 200 seconds, and then there will be thread multiplexing can also happen. So sorry, you can have a multi-threaded application interacting with this particular thread. So that also will gain give your system a huge boost. So using context switching and all that, I have had instances where I can, with a single Redis server, I can serve million QPS. So Redis is blazingly fast, even though it is a single threaded application. Redis is an event-driven system and not necessarily slow Node.js, but very fast. CPU intensive. So Arpit says Redis is event-driven system and not necessarily slow. Is drawing parallelism from a Node.js server. CPU intensive application do require multiple threaded system, but not which are just network IO intensive. Agreed on this. Most of the time is spent on IO thread. So exactly. So thread not thread contention. I forgot the term for that. Yeah, context switching. So context switching will there'll be multiple threads which will be reading the data, and using threads will switch the context to give chances to other thread which is waiting for the waiting to be get into running state. Sharding, please. I think Bhavan, what you're asking is, are you asking me to explain what sharding means? I'll be uploading one video on sharding on under the system design series. So please stay tuned.
Hey everyone, this is Anshul Sadaria, Software Engineer 3 at Google. I have a question for all of you. How many of you have used dating applications like Tinder, Bumble, and I don't know what all other names are there? I already feel old. Don't lie to me. I can already see your smirks behind the screens. So, did you know that the initial name of Tinder was Matchbox? Obviously because of the pun. Match, because it was meant to match different people, and Matchbox because it was igniting new sparks. No, this video is not about me sharing some fun facts about dating applications, but a rather interesting system design. Yes, we are going to do a system design for dating applications. So if I use Tinder, Bumble, dating applications or dating sites, don't be confused, we are going to talk about the same thing. So what are the prerequisites that you should keep in mind before you watch this video or continue watching this video? Absolutely nothing, because this video is meant for you to learn new stuff. We'll be discussing new design strategies and so on. But if you want to get the most out of this video, I would really recommend if you understand some of the computer science fundamentals. Okay, when I talk about computer science fundamentals, I mean networking, databases, DBMS, and so on. You should understand what are the pros and cons of a choice of one database over the other. And you will also definitely hear some technical jargon here and there. So if you hear some technical jargon, don't worry, make sure you note it down. And I would really love if you search it over the web. Even if you don't understand, don't feel scared. Ask me in the comment section. I will be very happy to resolve any doubt of yours. This video is going to be like a roller coaster, but make sure you keep your eyes open. You will feel excited, there will be some thrill, and you will feel scared at some moments as well. But don't worry, as long as you have that learning attitude. Now the first step before you jump into the system design is to make sure you don't actually jump into the system design. Make sure you prepare the requirements, like what all things you should add in your system, what all features should be added to the system, and then only post the decision of requirements, jump into the design choices like what databases you want to use, how the data should be modeled, and so on. But this is my preference. There are two schools of thoughts regarding this. One is the bottom-up approach, where they decide the ER model, the entity relationship model, what data will be stored, how it will be stored. Then they decide how the services, what services will consume the data. On top of that, they will decide how the client or the user will interact with these services. Personally, I don't prefer this approach, and this is my personal opinion. I'm repeating again. My personal preference is a top-down approach where we create the feature requirements. Then we decide what all services are required to make sure that these feature requirements are complete. On bottom of that, we will decide what data will be stored, how it will be stored, and then prepare a ER model based upon the services and what they will consume. So we are going to use a top-down approach in this system design video. And the primary reason I love this approach is because once the requirements are logged, the design decisions become a lot simpler. If you want to understand the real power of requirements, do check out my video on Twitter system design. Now, how about you tell me in the comment section what all requirements you would have decided if you were designing Tinder or any other dating application. For the sake of clarity, I am going to categorize the features or the requirements into two categories: functional requirements and non-functional ones. Now, functional requirements are the ones which actually influence the journey of a user, like how the user will interact with what all features. Now, let's go step by step to understand what a customer journey will look like. First of all, a customer would want to create their profile or register onto the dating site. So, let's change the color, create profile. Okay, pardon my handwriting because I know it's really bad. I have not written for a very long time. So we will create a profile. Next, I would really want to update my profile as and when required. For example, if I got promoted, I would want to mention that thing. I would want to update my profile. So the user should be given an option to update. Okay, I'm not going to write entire update profile. So post that, what all things does a user actually do? If I remember my journey when I was like exploring dating sites, so I would want to set my preferences, yes, definitely. Like what age range am I looking for? For example, I'm 24 right now. So I might prefer people who are in the age range of 20 to 24, 25 something, I guess. And what all gender orientation I'm looking for? Male, female, or any other non-binary gender orientation. So my preference would be female. And then I would have some location preferences as well. Like, do I want to connect with females in the radius of 10 miles or 15 miles, or what am I looking for? So we should definitely be able to set preferences. Okay, I'm not going to write this complete again. We should be able to set preferences, and further down in this video, we will understand how these preferences will actually influence the recommendation service. Okay, I'm not going to reveal a lot of details because that will be covered down the lane in the video. Now we have set the preferences, our profile is ready. What's the next part? Swipe left or swipe right. So the user should be able to swipe and post, like swiping left and right. Let's say you swiped right on someone and then someone swiped right on you as well, like the same person swiped right on you. So you both have matched. Okay, now you should be allowed to chat with each other. So we should be given a possibility or a feature to chat with each other once we have matched with different people. This is what I feel should be our functional requirements. Do you think there should be more functional requirements which we should consider? Let me think about it. Oh yeah, definitely. Like we would want to upload some images, right? Because from my experience, we don't usually look at what the person has written in the profile. We usually judge the people based on their appearances, unfortunately, but that's the harsh truth. So I should, this functional requirement should come on the top, but upload pics, yeah. Again, ignore my handwriting. So we should be given a preference to upload pics, and we will decide in this video, like we will make some design discussions, like what data store should we use, whether we should use a data store or not. So I think this functional requirements should be sufficient to get started with designing our system of Tinder or Bumble. Let me know if you think otherwise, because I remember from my experience, there are some other cool features as well, like you should be able to super like a profile, or you should be able to see the likes, like which profiles have liked you, and then you should be allowed to rewind the profile, like in case you left swiped someone and you want to rewind the profile and like them again, or even like if you want to see their profile. So that should be a possible feature. But as far as I remember, these features are available only for premium users, so we can possibly ignore it. These are not really important for us to create our MVP application, like the minimum viable product. These are not very important features. So we can now jump onto the functional requirements and lock them. Now let's jump into the non-functional requirements. First of all, what are non-functional requirements? These requirements don't necessarily influence the user's journey, but rather it affects the user experience. Let's say our system should be highly available. Like it should not happen that I'm not able to use the application for a really long time, right? Then the system should be consistent, because if someone is updating their profile, I should get that information over the time. Okay, now let me know in the comments, what do you think? Should the consistency be eventual consistency or strong consistency? What does eventual consistency mean? Like after some time, the information is propagated to you ultimately. What strong consistency means is that the moment the information is updated, at the same moment, the information should be propagated to all the nodes. I really feel that strong consistency must be very harsh for an application like this. Let's say some person updated their profile info or uploaded new pictures. It's fine for me as a user if I'm not seeing their updated pictures at the same time. Eventually, I will get their updated profile info. So I don't think there is a requirement to push too hard for strong consistency. Let me know if you think otherwise. Then minimal latency is really important for applications like this. Minimum latency. Because it would be a really bad user experience if I'm scrolling at a profile and I'm not able to see their pictures, or if I'm doing a left swipe and I'm not able to see the new profile really quickly. So highly available, consistent, minimum latency. What all other non-functional requirements do you think this application or dating site should support? Let me know in the comments below, because I have deliberately missed out on some of them, which I will talk about in the video further. Having decided our requirements, now it's time to decide what all services will fulfill those requirements. So let's move on to that part. First of all, it should be the profile service. Okay. Now, if you look on our requirements, the profile service should handle the logic for create profile, update profile, set preferences, right? And yeah, obviously, definitely, like upload pics should also be handled by our profile service. Next should be the swipe service, possibly, because the user should be able to swipe. Now, if you look at our requirements, the swipe functionality should be like made available through this service, and also the logic behind, like when two person right swipe onto each other, they should match with each other. So this logic should also be handled by the swipe service. Now, if you notice one thing, we missed upon a crucial functional requirement, which was recommendation. Something happens behind the curtains. Like the user doesn't see the recommendation service working, but the application, the system does work on some recommendations based on the user preferences that you had set while you are creating your profile. So recommendation service is something which works behind the screen, and this should make sure that we get the profiles that we are looking for. Like the purpose of the recommendation system or the recommendation service is to show us the profiles which we are most likely to right swipe on. So that logic will be handled by this service. And lastly, the chat service, because when two people match with each other, they would want to chat with each other. For this particular service, I would really love if you have some background about networking or some communication protocols. Don't worry if you don't know, we will discuss them in detail as well. But I would really love if you do some homework before we jump onto the chat service portion. So now let's jump directly into our profile service designing. We will be having a lot of healthy discussion regarding some of the design choices that we'll make as a part of this profile service. So let's move. Okay, we already designed the services. So profile service, first of all, there will be a client. I think my handwriting is improving over the time. Then we will have a profile service. Okay, so the first thing that the client will want to do is to create a profile. They will pass in the username and the password, and this information will be stored in a database over here. So yeah, we can use a SQL database, we can create cache over it. Those all are the stuff that I'm not going to go deeper into, because I have already explained how you can use cache and all of those stuff in one of my previous videos where I talked about the system design of Twitter. So do take a look at it to understand how we can reduce the query time and all those stuff using the caching services. So we will create the profile. The profile service will be capable of doing that. Now let's say we want to update a user profile. So let's remove this part. Okay. Now let's say we want to update it. Okay. So we will pass in the user ID and the info that we want to update. Now if you take a look at this, there is no way of authenticating. Like how does the system know, or how does the profile service know that the user ID whose information I want to update is my own? So we will need to pass in the password or some sort of thing like that along with this. And here there will be some authentication system which will check if the user ID that I have passed in is actually my user ID. Now I forgot to tell you some things, like if you actually use a dating application, you will see there are a lot of other authentication mechanisms, like you can log in through Google, you can log in through Facebook and so on. So there are some external authentication services which you can use. For two-factor authentication, if you have used, like your OTP goes to your mobile phone and then you pass in that OTP to the application. So there will be an SMS service as well. Okay. But for the sake of clarity, I don't want to add a lot of things to this particular service because it takes away the essence of the stuff that I really want to discuss. Okay. So, okay, we'll reduce the size of the eraser first of all. Yeah. So we'll not dig it much deeper into the external authentication mechanisms or the SMS service. Let's keep it fluffy, let's keep it natural. Now, a healthy practice is not to store the password directly into the databases. So instead of password, what I would prefer is to use something known as tokens. So tokens is very common in the authentication mechanisms. I'm not going to go deep into the cryptography and all of that. So let's take away that portion away. Tokens. So the actual implementation happens through something known as JWT, which is known as JSON Web Token. Again, I'm not going to digress away from this topic by going deep into what JWT actually means. So we are going to use tokens for the authentication purpose. Now let's assume there is some other service. Let's say there is chat service. Chat service wants to know if you are the user ID who wants to communicate with their match. So they will want to interact with the profile service because the authentication module or the authentication mechanism is a part of the profile service. Let's say chat service is fine. Let's say we add a few more services as well. We don't want to repeat the logic. We don't want to interact. We don't want all of these services to interact with the profile service. That takes away the entire essence of microservices, because microservices are meant to handle a particular logic. If all the services are interacting with the profile service, it's not a good design system. So we will modify the architecture a little bit. Let's keep a profile service over here. And in front of the profile service, we will have something known as a routing mechanism, or as some people love to call it, gateway service. Okay. So the gateway service will handle the requests coming from the client and then route it to a particular service. It can be profile service, chat service, swipe service, recommendation service, or anything. Okay. This is a very neat design. You know why? Let me know in the comments. But otherwise, I think it's a very neat design because it abstracts or encapsulates all of the services. The client doesn't need to interact with individual services. The client just needs to interact with the gateway, and no other service will interact with the client. Only the communication will happen between the client and the gateway service. That's the beauty of it. So this gateway will be responsible for communicating with different services. Now, having designed the high-level infrastructure or the system design of profile service, let's take a look at how we are going to model the data. We are going to design the SQL table for the user. For that, we will have user ID as the primary key. We will store age, preference, location, and other details related to the user. Now, the important question which I want to ask all of the viewers is, where should we store the images? Because if you remember, the profile service handles the logic of uploading image or updating image and so on. So how should we store the images? Should we store it in the same table? Like, should we store image 1, image 2, and so on? Or perhaps we can create a more normalized version of the table. Like, we can create a new partition, a new table, which will store images. We will have user ID, we will have image ID, and we will have the image over here. And instead of storing the image in this user table, we can have an image table where we will store the image ID instead of the entire image in the user table. I think the later one is a more flexible opinion. It keeps the user table a bit lighter. But one issue that can come up with this design is that it might require multiple lookups. Like, for example, if a user wants to see the profile image of a particular user, we will need multiple lookups. We will query the user table, then the user table will query the image table and then return the image. It can be a little heavy, it can be very expensive operation. So we will decide how we can work upon this particular question of where to store the images. Should we store in the same data store, or we can store it in the form of a distributed file system and so on. Don't worry if you don't understand the technical jargon. We will discuss the pros and cons of each of these approaches, and then we will make a call what system we are going to use for our dating application. Now, the question that was really important, which I wanted to emphasize on, how are we going to store the images? Now, we considered two approaches in the previous slide, storing it in the same data store. It will be in the form of blobs. Now, to those who don't understand what blob is, it stands for binary large object. It's just zeros and ones, like the image is stored in the form of binary large object, which is zeros and ones. In the same data store, we have two choices. Either we can store the entire image, all the 5 images, in the same user table, or we can store it in the different image table and then create a reference in the user table for that. Another option is file system. Now, before we take a call of a preference between both of them, it's important to understand the pros and cons of each of these choices. Now let's see what does the data store have to offer us. The first thing is transactions. These are the atomicity, like the database provides us the atomic structure, all the transactions happen in one go together. Then it's the mutability. It allows us to update the images, delete the images, update a part of image, and so on. Do we actually require this? We are going to discuss this further. Then it provides us an opportunity to index This is usually used for search operations. We are not going to search over the images. So this particular offering may also not be required for us to store the images. And the last one, which is very important one, which I want to highlight, is security or the access controls. Like the same security offering which is provided to the user data, the same offering is provided to the images as well, which is a pro of storing it in the data store, same data store. Now, as we discussed, we don't need the indexing offering because we are not going to search on a portion of an image, or we are not even going to search on the basis of image. We are going to search possibly based on the age range or any of the user preferences that we have set. So indexes are not actually required to store the images. Mutability is important because we are going to update the images, but we can do one thing, like we can create a new image, we can create a new file and then delete the old one. So in this way, we don't actually use the mutability feature of the data store. We are not going to update some part of the image. So that is also not required. Now transactions, atomicity is also not required because we can update the image or delete the image asynchronously. It doesn't need to happen in a single transaction. So we can get rid of this as well. Security is important, but we will see how we can manage security in our file system as well if such a possibility arises. Here we discuss the pros of using a data store. Now let's talk about some of the cons which might influence our design choice. So the first con is that multiple lookups, which we already discussed before. So this can be actually an expensive operation, like if we are going to query the images from the data store and send it to the client from a SQL database. So this is going to be very expensive, which is a very important con which we need to consider while making our design choice. The second con is disk IOs take a lot of time. Okay, the image, if the image is very large, it's going to be stored into multiple blocks within the disk. Those who don't understand what I just said, take a course on the databases or database management systems, which will help you understand how the image is stored into blocks which are a part of a disk system. So when you query multiple disks, if your image is stored in multiple disks, you need to query different blocks from the disk. And querying different blocks from the disk is a very expensive operation. If you remember, disk IOs are really expensive. We cannot afford multiple disk IOs for the lookup operation. So this is part of multiple lookups only, and this will also influence our design choice. Now the next thing to remember is a data store creates some replicas. When you create a replica, let's say you are storing image. A user has 5 images and let's say each of them cost 2 MB to us. Now let's say there are millions of users. Can you calculate for me and tell me how much space will be utilized to create a replica? And just imagine how much time will it take to create such a big replica. Replicas are also costly. Let me know in the comment section after you perform the calculation. 2 MB image, 5 images, and million users. Okay, here we are talking about the active users. There can be more than million users. So all of these cons really influence our design choice. Now let's take a look at some of the pros which are offered to us by the file system. We can create a CDN. Okay, I will explain what CDN means. But let's say we have a distributed file system. We can create a CDN on top of it. This is known as content delivery network, which helps us to cache the images if a user is going to query them multiple times. So this actually makes the lookups much faster as compared to data stores, where caching the images will also be very costly because we are storing the images in the data store. We are also storing them in the caches. So it's really expensive for us. As a part of DFS, we are going to store them as in the form of file system. We will store the file URLs along with the user info. Let's see how it looks in our data store. We will have user ID. We will have image ID, and then we will store the file URL. Now, this image ID will be stored in our user table, and from that we will reference the images. So if you want to delete an image or update an image, create a new file and then delete the old file. Yes, it may create some issues of dangling images wherein we are not actually referencing a deleted image and we forgot to delete that image. So we really need to make sure that our mechanisms are in place so that all of the advantages of a data store are actually fulfilled by our file system. Yes, it can be a little bit tedious, but it is still manageable. So I think a distributed file system is the right choice for us to store the images, and let's see how our ultimate profile service will look like. Now, I really believe that we can create a new service, we can spawn a new service to handle all the image operations, because if we store all of these operations inside the profile service, it will be very costly. Let's say there is a new possibility where we can use the images in our machine learning model to, let's say, calculate the beauty of a picture or something, some way to recommend a better suggestion, better profile to the user. Then we will require to query the images. So for this, we can create a new service. Again, there is no hard yes or no, it's my personal preference. We can create a new service, which is the image service, and let this handle all the image related operations. So there will be a distributed file system over here, which it will interact with, and then we'll create a database where it will store the file URL, image ID, and the user ID, and this will be referenced. Whenever someone wants to query the images, the gateway service will reference from the image service instead of the profile service. So it may require two calls to the profile service and the image service, but I think decoupling them is a healthier option as compared to merging everything in the profile service. Let me know if you think otherwise. We can have a healthy discussion in the comment section. Now we have completed the design of our profile service. We took some rational calls, we made our own personal decisions. It can be right or wrong, it's very subjective. Now let's move to swipe service. So when a user swipes left or right, this swipe service will handle the logic. If you are going to match with a person or not, this service should handle that logic. Now this is a client. Do you think we should store the swipe information with the client itself rather than storing it in the server? Can you let me know what are the cons of this approach? The first con which I can imagine is if I'm storing all of the likes and dislikes with the client, I have no way to identify on my own as a client if I matched with a person or not. I should be communicating with the server to let the server know that, okay, this is my right swipe. Can you let me know if the opposite person has also right swiped me or not? So ultimately, the server should be the source of truth rather than me making the decisions on the client side. So I think it's a very healthy practice to store that information in the server itself. Let's complete this design. This is our gateway service. This is our swipe service. Now, what will be the ER model? What information are we actually going to store in the data store as a part of the swipe service? There can be multiple options. None of them are right or wrong. It's just some decisions that we take based upon the requirements. So what I have decided, or what I am thinking right now, another issue which I think can come up if we are storing the swipes left and right with the client side is that, let's say I uninstalled my application. I am going to lose all of my swipes. And with that, I also lost all of my matches. For some reason in the future, if I come back on the application again, there is no way for me to connect with my matches. This can be a really very bad experience for me. So I actually want to store the match information in the data store itself. Let's take a look how we will design our data store. We can keep the information of user IDs, user ID 1, user ID 2, and then we can actually check if 1 liked, 2 liked, and so on. Don't actually name your variables in this way. This is just for the purpose of the video. So make sure that you follow the proper nomenclature whenever you are preparing your ER model. What will happen is when 1 likes the profile of 2, here 1 liked shows true. Okay. Now when 2 also likes 1, it means 2 liked also becomes true. This is a way for us to ensure that, okay, 1 and 2 have matched with each other if both of them have the value true. If one of them have the value false, then it means that one of them have liked but the other one has not liked. Now with this ER model, do you think we are actually storing the information of our left swipes? If 2 users, both of them have left swiped onto each other, do you think we are going to store that information in our ER model? I think we are losing the left swipes, and I don't think it's a very crucial information that we are losing on, because if I'm left swiping a profile and I get the same profile again, and let's say I change my mind for some reason, I should be allowed to have another opportunity or even multiple opportunities in that case to match with that person, or at least right swipe the other profile. So this service will be responsible to let us know if a user 1 has matched with a user 2 or not. This service is going to be consumed by a lot of other services. Can you let me know in the comment section which all services will be consuming this service? If you are looking to chat with your match after you have matched with a person, this service, the chat service, will want to know whether you have matched with user 2 or not, in case you are trying to chat with user 2. You are user 1 in this case. So the chat service will interact with the swipe service to get the information about the match. Now let's say you want to look at the profile of the user 2 who you have matched with. So the profile service will want to know if you are actually allowed to see the profile of user 2 or not. So the profile service will also interact with the match service, and the match service will return a true or false in a Boolean way to let the profile service know that, hey, it's okay for user 1 to see the profile information of user 2. You may just want to look at the likes and dislikes of the person, the interest of the person, or just randomly stalk the profile of your match. Now we have already designed 2 of the services out of the 4, profile service and the swipe service. Which service should we design next? My heart really says recommendation system, but I think it's really complicated to explain it at this moment. So we will keep it for the later and go on to the chat service. Now let's say you are user 1, you matched with a user 2, and you want to chat with that user. We also have a user 2. How will both of them communicate with each other? We have gateway over here. User 1 would be like, hey gateway, can you send message to user 2? Gateway would be like, how do I know if you have actually matched with user 2? Remember the swipe service which we just recently designed? Yes, the gateway can directly communicate with the swipe service and then forward the message to user 2. Do you think it actually works in this way? I feel that we should decouple the logic of gateway actually taking the decision whether the message should be sent to user 2 or not. So for that purpose, let us create a new service which will handle all of that logic. So instead of gateway actually communicating with the swipe service, we will let gateway communicate with the chat service and rely on the chat service to ask the swipe service if user 2 and user 1 have actually matched with each other or not. Once the swipe service says that, hey, like user 1 has matched with user 2, allow it to send the message to user 2. But an important thing to remember here, and I really hope you didn't bunk your networking classes, because we are going to talk about some of the communication protocols. Okay, let me ask you a quick question. What is HTTP? I'm not asking you for the full form because you obviously know that, Hypertext Transfer Protocol. But what I mean to say is that it's a client-server communication protocol where the client sends the request to the server, and the server doesn't ask the client that, hey client, do you want to ask me anything? The server just sends the response to the client. So in this case, do you think that the gateway will actually query the user 2 saying that, hey, this is the message that you have got from user 1? That's not what HTTP does. Here we have a different protocol which is known as XMPP. So obviously we are not going to send the message to user 2 directly. We are going to communicate through the XMPP protocol, which is the peer-to-peer communication protocol. Here there are no differences between client and server. All of them are equal. There is no discrimination between the client or the server. So with this peer-to-peer protocol, the gateway can actually send the message to the user 2. Otherwise, imagine what would have happened. Like if we were communicating over HTTP, user 2 would be like, hey, did anyone send me a message? Just like I keep checking my mobile phone every 5 seconds to see if I have got the message from the one or not. So this is not actually, like, this is very expensive. So user 2 is not going to poll the gateway saying, please check if you have got any message for me. Instead, we will use XMPP protocol, which will directly send the message to user 2. But an important piece of information over here is that the user 2 will be listening to the gateway through something known as WebSockets. Okay, user 1 will also be listening through WebSockets. If you don't understand what are WebSockets, let's keep it simple. Let's say there is a TCP connection between the users and the gateway. Okay, all of the users have some way of communicating with the gateway, and it is persistent since we are using a TCP protocol. Or you can create your own protocol as well if you're interested in it. But for the sake of simplicity, let's stick to TCP protocol. All the users will be listening through this TCP protocol, and what the user 1 has to do is to identify what connection the user 2 is listening on. So this is where the real beauty of chat service comes into play. The chat service will hold the information about the connections of each of the user, like what connection the user is listening to. So let's say our user 2 is listening to C2 and our user 1 is listening to C1. So we will hold all of that information in our data store, which will have user ID and connection ID. So what the user 1 has to do is to identify the connection ID of the user 2 to which it wants to send the message. But it definitely can't do that. So that will be the task of the chat service. Chat service will get the user ID of user 2 and it will query swipe service to let them know that whether the user 1 has matched with user 2 or not. Once they get a positive response that okay, user 1 and user 2 have matched, it will query the database to identify the connection ID and then transfer the message to user 2 through the connection ID to which it is listening. So this is the entire flow of the chat service. User 1 will send the message to user 2 using the user ID, which the chat service will query from the swipe service to identify if they matched or not. Once it realizes that okay, they both have matched, it will query the database to get the connection ID to which user 2 is listening and then send the message or queue the message to the connection to which user 2 is listening, and then the user 2 can keep polling from the connection to which it is listening. This is all about the chat service design. Now let's move to the most crucial part, which I want to emphasize from a really long time, which is the beauty of dating applications. It's the recommendation service. Now let's move on to the recommendation service. Recommendation service can also be called search service because in front of the screens when you are doing right swipe and left swipe, what the system actually does is that it searches for the profiles in its data store which you are most likely to right swipe on. So we can also call it search service if we want to. It's also shorter to write. The search logic is actually influenced by the user preferences. If you remember, when you created the profile, you added some user preferences, age, gender orientation, location, and so on. So all of these user preferences are going to influence our search service or the recommendation model in some way. There are two categories in which we can distribute our preferences: hard preferences and soft preferences. What do I mean by hard preferences is that, let's say I have set a constraint of age preference to be 20 to 24. So I really don't want to see any profile outside this age range. Okay, it's going to be really bad user experience if I see a profile of age 26 or 18 or so on, because that's what I'm not looking for. So age is a hard preference. Location is definitely a hard preference, because let's say I have set a location preference to be 10 kilometers because of some reason, because petrol is costlier now, I don't know. But I have set up some preference based on the location. So I really don't want to see any profile outside of my location preference. So location is another hard preference. And lastly, gender orientation. Let's say I have set a gender orientation for female. Just imagine my user experience if I was shown a male profile. It's not healthy, and I would definitely want to uninstall the application at that particular moment. So I think these are the hard preferences: age, location, gender orientation, and so on. I don't think there are any other hard preferences. Talking about the soft preferences, which don't actually influence what profile should be shown, but rather how they should be ranked. For example, what my interests are. Let's say I'm interested in trekking. So I don't mind if someone doesn't have that particular interest, but definitely if someone has an interest in trekking, that profile should be shown on top of the other profiles. What are my hobbies? What are my interests? What is my career path right now? Let's say I'm a software engineer. So I don't really mind looking at the profiles of people who are not software engineers, but if they are a software engineer, then it can really influence our recommendation model. So there are a lot of other soft preferences. We'll not go into detail in each one of them, but the important thing to remember for the recommendation model is that hard preferences filter which profiles should not be shown at all, and the soft preferences are responsible for the ranking of the profiles that are shown to you. So how are we actually going to use this hard preferences to filter the profiles that should definitely not be shown to us? One of the ways is that I can query a SQL database, and there I can put where conditions, where gender orientation equal to female, where age equal to 22 or 23 or 24 and so on. But this will be very expensive. For example, imagine for the location, you will need to compute the distance between your location and the location of the other user and then take a call if that profile should be shown to you or not. So this is not a good practice. Another way in which you can do this is through indexes. You can create index on each of these hard preferences: age, location, gender, and so on. But one thing which people forget is that when you have multiple indexes, the query is optimized only for one of them. Let's say you have created an index on age. So using the hierarchical structure of a tree, you will filter out all the profiles which are out of your age range preference. But what about location and gender? Once you have got those profiles, you really need to perform those calculations on your own to extract the profiles matching your gender orientation and your location preferences. So this is again a costly operation, because your query optimizer, you can tell your query optimizer that, hey, optimize for this particular hard preferences for this particular dimensions, and it is up to your database to decide which index it should actually search for. So that is a little bit out of your control. You cannot, it's not flexible enough for a developer to decide which index the search will actually be performed on. To get rid of this issue, we can use a distributed NoSQL database, something like Cassandra or DynamoDB by AWS or something like that. Now let's say I'm not very comfortable using a distributed file system, a distributed database, or possibly I have a preference orientation, I'm more comfortable towards a SQL database, then we have an alternative for that as well. We can use a SQL approach with a concept known as geo-sharding, sharding based on locations. Now let's take a stop to understand what sharding actually means. So what does sharding mean? Sharding means that we distribute the data based on the values in a column. Let's say we have a column named username. So we will distribute the values from, for example, A to M, then what comes after M? N, okay, N to S, and then T to Z. So let's say we have partitioned our database into these 3 different shards. So all of these 3 different shards will have one node which will respond to it. Let's say this is node 1, this responds to node 2, and this responds to node 3. For example, let's say someone is searching for Anshul. So they only need to identify which shard they should be calling. They will be calling node 1, and hence our data store will be divided in such a way that all the user profiles having their names in the range A to M will respond to node 1. All the names which are in the range of N to S will respond to node 2, and all the names which are in the range T to Z will respond to node 3. So this is one way of sharding where we used username to shard our data. But what happens if node 1 crashes? Will we stop responding the user profiles which are in the range A to M? This will be a horrible user experience because I don't want someone to search me and not return my profile. We can use a concept known as master-slave architecture, wherein along with node 1, which is the master-slave, we can have a slave node which is node 2. So whenever node 1, which is the master node, crashes, we can use the slave node to respond to the queries for the username in A to M. Now you will ask, what if the slave node also crashes? Okay, this is a question for you all. Let me know the probability where both the master node and the slave node crash at the same time. It's really, really low, and there is no anticipation of such an opportunity. So we will use a master-slave architecture and geo-shard our data. Now let me explain what geo-sharding would actually mean. Let's say this is the map of some location, and we will divide the entire map into grids. Now each one of this chunk, okay, all of this chunk correspond to a particular node. Let's say you are located in this particular chunk. So what you actually need to do when you are performing a search operation is that you want to return the profiles within your location preference. So you would be searching within this particular node and all of these adjacent nodes. Now the size of each of these grids will actually vary upon what is the maximum location preference which is given by the dating application or which is given by the system. Let's say you are allowed to add a location preference of 50 kilometers, for example. I think the grid size of 1 kilometer by 1 kilometer is very helpful in that sense. You can perform a breadth first search kind of a search operation where you move from adjacent node to the next adjacent node and identify if they actually fall into the location preference which you have added. Now, when those profiles are returned to you, you can perform a filter based upon the age preference and the gender preference. Location preference is a trickier option to calculate, and that is the reason we are doing geo-sharding and not age sharding or gender sharding or something like that. Now, let us consider some other use case. Let us consider the geo-shards for India and US. What will be the activity of those geo-shards? Let's say this is the graph for India and this is the graph of US. Now this is the time axis and this is the activity axis. So during the daytime or during a particular time, okay, let me mark them as well, India and US. So when the geo-shards of India have very high traffic, the geo-shards of US will have relatively low traffic, and vice versa. When the geo-shards in US will be at their peak, the geo-shards in India will be at their lowest traffic. So now what we can do is that we can create same geo shards. We can use the same geo shards for both India and US so that we have proper resource utilization, and at no point in time does our resources remain unutilized. But now one problem will arise because of the same geo shards. For example, in European Union, you are not allowed to store the data of a user outside European Union or EU. So this will create some sort of issues if we are going to use the same geo shards for different continents, particularly EU. Experimentally, it has been found that if we randomly distribute the geo shards across different geographical locations, it gives a decent enough response rate and the resources are properly utilized. But for some special cases like EU, we cannot perform this random distribution of geo shards. Now, another use case is coming to my mind where we can still optimize. Let's create the grids again. Now let's say all of these grids don't have the same number of users. For example, this grid has 10 users, this grid has similar number of users, but when we come to this chunk, it has less number of users. For example, let me just fill up something. Okay, so what we can do is that we can actually merge all of these chunks into a single chunk and then dynamically geoshard based upon the number of users in that particular grid so that all the grids have similar number of users. Now you will ask me, what if it exceeds our location preference? But remember, irrespective of the size of the grid, they are holding similar number of users. So even if you query a bigger chunk, it is going to have around 10 users, for example, and then among those 10 users, you can perform the location calculation on your own, identify the distance and filter based upon the distance and the location preference that you have set. This concept is actually, in terms of computer science technical jargon, it is actually called quad tree. I am not going to go deep into what quad tree actually means. You can check it out, search it over the web and let me know what quad tree actually means and how you can use that data structure to optimize the dynamic geosharding feature that we discussed about. Now, these are some of the random optimizations which just floated into my mind. Let me know if you have some other optimizations or how you can optimize my optimizations as well. What data structures you can use, what algorithm can be used to tweak and optimize it further. Let's take a look at what the ER model for the recommendation service look like. We will obviously be storing the user ID and we will be storing the grid ID as well. Now, based on this grid ID, we will identify the adjacent grid IDs, perform a search over that, filter based upon the age and gender orientation, and then use some ranking models to integrate it with our interest, our hobbies, my career position, and so on. And then return those profiles to the user. I don't think I really need to draw the diagram of the recommendation service because this is the database that we are going to use with it. Let me just summarize it, how our entire Tinder or let's say dating application system architecture look like. We have a client. We already talked that the client will communicate only with the gateway service. Now, there are different services which our gateway service communicate with: chat, profile, search. I'm not going to write recommendation completely. And the last one being the swipe service. I'm not going to draw all the ER diagrams and all of them. Complete this diagram as an assignment, how each of these services will interact with each other. For example, if you remember, I talked about chat service interacting with the profile service, or the search service interacting with the profile service, and so on. Okay, oops. I revealed one interaction which I didn't mention and I was expecting you to answer that. It's okay. Let me know what the complete system architecture look like. How will each of these services interact with each other? And if you have any doubt, Do let me know in the comment section and I will be happy to assist you. In the hood, behind the hood in Tinder, it actually uses Elasticsearch based upon the leucine indices for each of these hard preferences. I'm not going to go deep into what Elasticsearch is, what leucine indices are, and how actually Tinder performs the recommendation system and the entire system architecture. So we all definitely know that Tinder was not developed in 40-45 minutes. The real motivation for me for this video was to make sure that you are aware about some of the important computer science fundamentals which are really used in system design. We talked about some communication protocols through networking. We talked about how we can store images either as blobs or in file system. We also talked about some concepts like geosharding and so on. I know all of this technical jargon can scare you. Make sure you do some self-study, and if you still have some doubts, put it in the comment section below. I really hope this content was very informational for all of you. If you loved this video, make sure you give it a thumbs up. Also, don't forget to subscribe to Scalar's YouTube channel and make sure you hit the bell icon so that you never miss on such amazing content in the future. In this video as well, I am going to cover the system design of one such large-scale product. Day to day for commute, we use this application on a regular basis. Yes, you guessed it right. We are going to cover the system design for Uber. Now, when I say Uber, I also mean Ola, Lyft, Careem, and all of those applications which are used to provide us cab services. Now, before we start the system design of any application, the first step is to understand the customer user journeys, which is how the customer would interact with that particular product or application. In this case, we have two different types of customers, a normal user or a rider and a driver. Let's try and understand what all different customer user journeys will be there. Now, we will refer to customer user journeys as CUJs. Let's first try to note down how a driver will behave with the application. They will first create their profile. Then they will show their availability on the application that, okay, hey, I am available to take the rides. Please give me rides if they are available in the nearby location. Next, they have an option to accept or reject the ride whenever they get a notification that, okay, some user in the nearby location is asking for a cab service. So, accept or reject a ride. Now, when they reject the ride, they are back to square zero and the same flow repeats over and over again. But now, if they have accepted the location, they will be able to navigate to the location, that is the pickup location of the particular user. So, navigate to pickup location. Now, once they have navigated to the pickup location, they are given an option to start the ride. They have accepted the ride. Now, they will start the ride as soon as the person gives the OTP or any such authentication mechanism. So, start the ride. As soon as they start the ride, the user would have mentioned some pickup location and some drop location. So, the navigation towards the drop location begins after the ride has started. So, navigate to drop location. Once they have navigated to the drop location, the driver can end the ride and accept the payment. Now, optionally, we can also give them the facility to rate the particular rider as well, and the same facility will be provided to the rider as well to rate the driver. Now, this is an optional requirement. We can add it if we want to. Let's try to see what all are the customer user journeys for a rider. Same thing, they will also create their profile. Now, based on the location of the rider, it will show them what all cabs are there in the nearby. Like if you have opened the Uber application, whenever you open the application based on your current location, it will show some cabs which are available in the vicinity. So, show cabs nearby. Now, I will be given an option to put in the start location and the end location for the cab service. So, add start slash end location. Now based on the start and end location that I have put in, I will be shown the estimated time required to reach the location, which is the end location. And I will also be shown the approximate price of whatever the cab service is going to be. You know, it's not the exact price, but it also gives an estimation that, okay, if Uber Moto, it's this particular price, Uber Auto, it's this price, and so on. So it gives an estimation of what the price could be. More likely the price is going to remain the same, but depending upon the traffic condition, or maybe the driver needed to change the route because of any obstruction, the price may increase or decrease. So show ETA and approximate price. Now once it shows the approximate ETA and the price for the cab service, what the application will do is it will start finding the cabs for the particular person. So book cab is one user journey for that. Like right now we have not started to book the cab, we are just seeing what all prices are there, what all timing it's going to take, and so on. So book cab from the start location to the end location is the next user journey, and then the remaining user journeys are on the part of the driver. So once the driver accepts the ride, the driver will navigate to the user, and the user will sit in the cab, the driver will start the trip, the driver himself or herself is going to navigate to the end location and then drop the user. Lastly, the user is going to make the payment and rate the driver. So that is also an optional requirement, but let's add make payment over here. So now these are the customer user journeys on the side of both driver and the rider. Now one important or one customer journey which we have not added in the typical flow is the ability to see the past trips or the payment history. So that is something we can add over here as well. Let's just change the color. So see past trips. Now this can be done on the side of both rider and the driver. And similarly, you can see your current trip as well, because a lot of time it happens that, okay, 10 minutes the driver is going to come in and we keep on looking at the trip status, or we keep on looking at the current trip. So we can either look at the past trips, get a particular trip, like if we want to get information of a particular past trip also, we can get information about a past trip. So get a past trip or get current trip status. Now the benefit of understanding all of these customer user journeys is that each of these customer user journeys get translated into a functional requirement. Like these are the functionalities that the app should provide. Now we have understood some of the functional requirements. Now when I talk about customer user journeys or functional requirements, I mean one and the same thing. All the customer user journeys are going to be mapped to some sort of a functional requirement. Now let's take a look at some non-functional requirements as well. When I say non-functional requirements, which I have covered in detail in Twitter system design as well, what I mean by non-functional requirements. Now this doesn't typically affect the customer user journey, but it affects the user experience. For example, if it takes a lot of time for you to check the current trip status, then it's a bad user experience. So that is a part of non-functional requirements, that the latency should be as minimal as possible and so on. So let's take a note of some of these non-functional requirements as well. Now we talked about the first non-functional requirements, which is minimal latency. Now when I talk about minimal latency, it's not that I want super low latency like that which is required for high frequency trading firms. I am fine with some sort of a delay. Some of the services, for example, if I'm making a payment, it's fine if it takes a bit of time for the payment to get through, or if I want to check some of the past trips, it's okay if it takes some time to show me the list of past trips as well. But some of the customer user journeys should have as less latency as possible. Now the next one would be highly available. Now it is not possible to imagine if Uber is down in a city like Bangalore or Mumbai or Delhi and so on. So it needs to be as available as possible, and I'm just talking about India over here. In US and all the countries around India as well, it is very, very important that services like Uber stay highly available 24/7. So highly available is an important non-functional requirement. Now, the next one would be durable. When I say durable, I mean the data should persist forever. For example, let's say that a driver is taking 10 trips in a day, and at the end of the day, the entire trip record for the day is vanished altogether. Or for example, if I have made a payment to the driver and it still shows that okay, the payment is not done through even after 3 to 4 days, that payment history is gone altogether. So such an experience is not expected from applications like Uber. The data should persist forever, be it trip history, be it location data of the driver, or be it the payment history, or anything at all. The information should be durable in the database. Now the next one will be, it should be highly scalable. Highly scalable because every day there are some peak hours and non-peak hours. So if the system is not able to scale to the peak hours, for example 9 AM in the morning or 5 PM, 5 to 7 PM in the evening, then the user experience will be really bad. And if we want to add the service to new cities, to more tier 2 cities, tier 3 cities and so on, the application should easily be able to scale to such an extent that we are able to cover almost all the cities of the world. So it should be highly scalable as well. And lastly, it should be highly consistent, or let me put it into better technical words, it should be strongly consistent. Now you must be wondering that we want our service to be highly available as well, and we also want it to be strongly consistent. Now CAP theorem says that one service cannot be highly available and strongly consistent both at the same time. Now that is absolutely true, but here's a catch in this. We don't want the same features or same set of microservices to be both highly available and strongly consistent. For example, if there is a cab finder service, we want it to be highly available. We don't want that to go down at all. But for example, if there is a trip service or a payment service where I want to check some of the past payments, or if the payment has gone through or not, we don't want that to be strongly consistent. We are fine with eventual consistency for such microservices. It's all right if I made the payment through and it takes 5 minutes, 10 minutes for the payment to get reflected in my application. But on the other hand, let's say I have booked a cab and some driver has accepted that particular ride. I cannot accept the experience where other drivers are still being shown that okay, this person is still asking for a cab. So in such situations, strong consistency is really required. And also, for example, if I start the trip and it still doesn't show that the trip has started on the driver's application, then that's also a really bad user experience. So all of these things, some of these features need to be strongly consistent, whereas some features we are fine with eventual consistency. So the set of features which are highly available and strongly consistent, they are mutually exclusive and they don't overlap. So this is the set of non-functional requirements which our application must be having. Now from the non-functional requirements, let's try and understand the scale at which an application like Uber works. Okay, let's just crunch some numbers so that we have an understanding of what the read QPS can be, what the write QPS can be, and so on. So first of all, like I am following the data which was published by Uber's blog, Uber's website itself. So it's a public data and I'm not making the numbers up. Now, it was seen that there are almost 100 million monthly active users. 100 million MAU, which is monthly active users, which means that over the duration of 30-31 days, there are almost 100 million active users. So on a daily basis, you can expect to have around 10 million rides. So there are 10 million rides daily. Rides per day. Now we will try and compute the QPS based on the number of rides in a day. Let's just wait for a second for this particular thing. And another number, like all across the globe, we can expect around 1 million drivers to be active on a daily basis. Since there are 10 million rides in a day, we can assume that one driver typically has 5 to 10 rides in a day. So ideally there would be 1 million drivers active on a day-to-day basis. Now when we say 10 million rides in a day, what does it mean? Per second, how many rides are getting booked or how many rides are getting requested? Let's do some computation for the same. Now in a day there are 86,400 seconds. Now I am going to assume this to be 1 lakh seconds just for the sake of computational ease. So now 10 raised to 7 million rides divided by 10 raised to 5. Now this is almost equal to 100 rides getting requested or booked per second. Now this is a huge load, because behind the scenes, whenever a cab is booked, a lot goes behind the scene. A radius is created around the user's location and the application tries to identify what all cars are there or what all cabs are there in that particular location. Pings are sent to all those drivers in that particular radius, and then a ride is booked. So 100 QPS is our load, operational load, and we will cover some of these aspects, like what is the purpose of having 1 million drivers in a day or 100 million monthly active users. We'll try and understand how it is going to influence the system design of Uber when I'm going to talk about some of the important tech concepts. Now let's get started with some of the tech concepts which I feel are really crucial in order to understand the overall system design of Uber, starting with the most basic one, like how is the driver and the rider being able to communicate with the Uber servers. So I'll just create a superficial diagram of this. Now when I say rider or user, I mean one and the same thing, so I might use these terms interchangeably during the course of the video. Now ideally both the driver and rider are going to communicate with each other only via the server. Now there are two ways of communication. The first one is the synchronous way of communication using HTTP request. So what does HTTP request mean? You send a request for some data and you receive a response in return. So the first one is HTTP means of communication, or HTTP protocol as we popularly know it as. So you send a request and you receive some response in return. Now let's say, for example, the rider wants to request a cab from the Uber application. So it sends an HTTP request to the server saying that, hey, I am at this particular latitude and longitude, or I am at this particular location, please send me an Uber. Now when I say book an Uber for me, I mean Uber Go, Auto, Moto, or anything at all. We are not going to differentiate between these different modes of cab services. We are going to treat them as the same thing. If we want to include different types of cab services possible on an application, it's a plug and play thing. It's not a big deal for the purpose of this system design video. So we are not going to treat them as a different thing. When I say Uber or a cab service, I mean one and the same thing. All right. So now the server knows, now the application knows that, hey, I want to book a cab for this particular rider located at a particular location. Now how does it communicate with the drivers? Does it send all the drivers an HTTP request requesting for their particular location? Like the server would ping all the drivers and ask them that, okay, let me know what your locations are, and then based on the locations and the nearby vicinity, it will send the possibility or suggestion for a cab request to those few drivers only. This is one way in which we can perform the communication between the driver and the server, but as we know, this is an inefficient way of communication. The other way of communication is using WebSocket servers. Now what does WebSocket servers mean? When we create a WebSocket server, it creates an open connection between two clients. Now in HTTP there is a concept of client and server. Whereas when we talk about WebSocket connections or socket connections, there is a P2P connection, peer-to-peer. There is no discrimination between client or the server. So this is a P2P connection. Both the peers can send each other messages asynchronously. So HTTP was a synchronous way of communication, and WebSocket connection is a peer-to-peer or a asynchronous way of connection. So this is asynchronous and HTTP is synchronous. Now using the WebSocket servers, what the drivers can do is they can keep on sending the location pings to the server on a regular basis. It can be every 4 seconds, 5 seconds, or 10 seconds. It depends on what ride QPS is sufficient for our particular use case. So now let's try and understand how the WebSocket connection is created. So let's consider a server sitting over here and a user sitting at the other end. Now when I say user here, I mean both the driver and the rider. I don't mind discriminating between them as well. So this is a socket connection created between them. So let's say whenever a driver becomes available, it sends a ping to the server saying, hey, I am available, and then it immediately creates a WebSocket connection between the server and the client. So the server knows that, okay, this is some connection ID. We will also have a connection ID. And this connection ID corresponds to this particular user ID. Now this user can be a driver as well as a rider. So now the server knows the link between a connection ID and a user ID as well. Now for the user only knows what connection ID it needs to put the message on. As soon as the message is put on that particular connection, it travels to the server and it identifies what the request is or what the message is. It can be both a request and a message. A message can be just a location ping for some driver that, hey, I am at this particular location. Whereas a request can be, I am accepting a ride or I am rejecting a ride. So in this way, the WebSocket servers make the communication between two different clients or two different peers efficient. So for the use case of an Uber application, we are going to use WebSocket servers, which is going to establish a connection between the riders and the server as well as the driver and the server, so that the messages keep on transmitting between all the parties. Now we understood how the communication in an Uber-like system behaves. Now let's move on to the next technical concepts and see how we can find cabs nearby a user who is requesting for a cab service. So now let's just create a table for the location data based on which we are going to find the nearby cab drivers. So there is going to be some sort of an ID related to the driver, and we are going to store both the latitudes and longitudes. Now in between, I just might shift from latitude longitude to XY axis. So I really hope you try and understand that by XY also I mean the latitude longitude thing. So now let's assume we have a table in which we are storing the latest location data of the drivers. I'm going to explain in detail how we are going to do that as well. But for the time being, hypothetically, let's assume we have some sort of a database, a fast retrieval database from which we can access the latitudes and longitudes of the drivers. Now we know for a case that there are 1 million active drivers in a day. Okay. So at any moment when we are going to find the nearby drivers, we can assume that estimation to be correct as well. So let's say this is the map of the world. Okay, I'm just going to draw a rectangular diagram, and this is the map of the world, and the user is located at some point over here. So now ideally we want to find the drivers in a nearby radius of a few kilometers, 1 kilometer to 5 kilometers and so on. So what the naive way, the most trivial way in which we can do this is by iterating through all the, like this entire table, location table. We can iterate through the entire location table and try to identify the drivers who are near me. Now another important thing to keep in mind is that we were having a QPS of 100 for cab search. So now if the QPS is 100 and we are going to traverse through the entire table of 1 million drivers, it is not going to be efficient. So one way in which we can get some improvement in the performance is by creating index over latitude or longitude. We obviously cannot create a primary index on both of these dimensions. So let's say we create a primary index on latitude. So for example, now over here we can assume that the latitude and longitude is x and y. Okay, so nearby the x latitude we want x minus 2 to x plus 2. This is the range in which we want to find the drivers. Now even after we have optimized based on one particular index, it is going to be a lot more inefficient, because there could be, in some cases, there could be a lot of drivers in a particular range of latitude or longitude as well. Another way to get more optimization, to try and improve the efficiency even further, is by creating two different databases with a primary index. In one table we can have a primary index on latitudes, and on one table we can have a primary index on longitude. Now based on those primary indices, we can find all the drivers who are in that range of latitude and in that range of longitude. So ideally we will find a pool of drivers which belong to this particular latitude range, and we will find some drivers belonging to this pool of longitude range. Now after finding those drivers, we need to find the intersection between both the sets. Now this 2 with a QPS as high as 100, it's going to be very inefficient. So we need a way in which we can convert this 2-dimensional data into 1-dimensional data. So for this purpose, I covered some of those topics when we discussed the system design video for Tinder. So do go and take a look. I'm going to mention some of the ways in which we can perform this particular thing, wherein we convert the 2-dimensional data to 1D data, 1-dimensional data. Now the first such way is by using geohash. I'm not going to cover in detail what geohash means, but basically the entire world's map is divided into chunks, and each of this chunk corresponds to some particular geohash. Now another way to do this particular thing is using quad trees. Now quad trees is also something which I talked about in Tinder's system design video, and if you want me to cover this in detail, then I can also prepare a system design video on Google Maps system design. Like, you can add it in the comment section if you want me to prepare a system design video for Google Maps as well, where I can cover all of these topics in much more detail. Now what Uber actually uses in its backend for the map service in order to identify where a particular driver is, or in order to find the ETA between 2 different points, and also for the navigation purpose, it's the Google S2 library. Now what Google S2 library does is also similar to, somewhat similar to what geohashing and quad tree does. It divides the entire spherical globe, which is sort of a 3-dimensional data, into chunks. Now over here I have, just for the sake of clarity, for the ease of explanation, I have just created a rectangular map, and I have distributed the entire map into smaller chunks. So now each of these chunks is some form of a 1-dimensional data. We can just name each of these chunks, we can just order each of these chunks. For example, this can be chunk, the ID of the chunk can be 1, this is 2, 3, 4, 5, 6 and so on. So in this way we have categorized the entire spherical data into 1-dimensional data. So we converted the 2-dimensional data which was causing us an issue during the driver fetch by converting into 1-dimensional data. Now whenever a user is pinging from a particular location, okay, we know the latitude and longitude of the user. Now each of the latitude and longitude is going to be part of some particular chunk. Let's say it's part of chunk 5. Okay, so now we ideally want to find the drivers who are in that particular chunk or in the chunks nearby it. So now this is the responsibility of the map service, that hey, given this latitude and longitude, let me know what chunk does the user belong to. Now this user can be both rider and the driver. So when we put in the latitude and longitude to the map service, it tells us that okay, this particular user belongs to chunk 5, and then what the map service does is, based on a user's location, it will create a radius around the user's location. It can be a 2-kilometer radius which will have a 4-kilometer diameter, or any XYZ particular radius. Okay, now based on this radius, it will cover a set of some chunks. We will get what all chunks are part of the subset in which we want to find the drivers from. So over here we can see that chunk IDs 1 to 9 is the search space wherein we want to find the riders, my bad. So ideally we will also have a service which will store that in a particular chunk C what all drivers are there. So we can directly communicate with those drivers and send them a ping that hey, a user is requesting for this service, do you want to accept the ride or not. So in this way we just find what chunk does the user belong to, and based on the nearby chunks we send the ping to the drivers who are in the vicinity of the user. Now what we have done is we have isolated the maps microservice which is responsible for converting the pair of latitude and longitude or the XY dimensions into the chunk ID. So let's keep making a note of what each of the microservices are doing. So map service, it's going to convert a pair of latitude and longitude to chunk ID. Now this map service itself has dissected the entire map into different chunks. So based on the chunk ID of the user, it can identify what all different chunks are there nearby. And we talked about some service. Let's keep it a question mark service over here. We will name it ahead, like I will talk about that service in detail in the coming section. So now what this does is it has a mapping from chunk ID to the set of drivers who belong to that particular chunk. Now ideally, using that map service, what we have done is we have reduced the search space of the drivers to whom we want to send the pings that hey, there is a user, do you want to accept the ride for that particular user or not. So now let's try and understand what all different things the map service can do. First of all, the ETA computation. Let me also create the map of a city to explain it in a better way. Now this is just a map of some city. I am going to divide the map into smaller chunks, which is what the map service or the Google S2 service is going to do. Now these are the chunks. Let's say the user belongs to this location and Google S2 service, Google S2 library is going to create a radius around it to find what all chunks the other drivers are in. Now let's say we found some drivers in the nearby chunks. There is a driver located over here, 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 here and here. Okay, we found out 4 drivers in the nearby chunks based on the radius that we set and the user's location. Now we want to find the ETA, that okay, given a start point and an end point, what is the ETA for, first of all, what is the ETA for the driver to reach to the pickup location, and ultimately what is going to be the ETA to reach the destination. So now based on the chunk IDs, if you remember, we also had a location table which contained the latest locations of each of the drivers. So now if we have isolated 4 driver IDs or 4 user IDs who are in the probability radius, then it is easy to get the exact locations, exact latest locations of each of these 4 drivers. Now based on those locations, we have 2 choices with us. First of all is just to compute the distance, which is the Euclidean distance based on a set of 2 different points, but that might not be the ideal distance because we know that for any in a city between point A and point B, we follow a road-like structure. So the distance is, if the aerial distance is 1 kilometer, then the actual distance might be something else altogether. So this can be a 3 kilometer road distance. So we cannot rely on the radial distance, we cannot rely on the aerial distance as well. What we'll do is we will use the map service, which is the Google Map service or any map service which is feasible for the particular application, and then based on that map service we will just let it know that okay, this is the driver location and this is the user location. We have isolated some drivers around and we have their locations. Let us know what the ETA is for the driver to reach the user. Now based on that, we will just compute what the distance might be for each of the drivers and what the ETA will be for the driver to pick the user up. Now that is added to the ETA for the pickup location to the drop location. So in this way, we can compute the ETA. Now this ETA, or ultimately what we are doing is we are finding the distance, probabilistic distance, and the time taken to cover that distance. Now both of these things can be passed on to the payment service, which will then calculate what can be the estimated price for that particular ride. So in this way, in collaboration with the map service, we will get the locations using the location service. We will use the payment service as well to compute the ETA and also to compute the estimated or approximate price. Now let's see, for example, if a driver is moving, the driver will keep on sending the location pings to the server. So how is it going to affect the flow? For example, the driver is situated in chunk 1, for example. All right. Now let's say the driver is moving in the right direction. So at some point the driver is going to change the chunk ID, or he or she is going to change the chunk in the map. Okay. So let's say this chunk is chunk 2. Now on a regular basis, the updated location pings of the driver are sent to the server, and what the server will do is that it will use the map service, and inside the map service the Google S2 library will let us know that okay, this is the latest location, and as per the latest location either the chunk ID has changed or it has not changed. And if the chunk ID has changed, let's say for example it was 1 earlier and it changed to 2. If you remember, we had a question mark service, right? So that question mark service, it will have that okay, earlier the chunk ID had driver D1, but now since the chunk has changed, we will get rid of the driver 1 from chunk ID 1 and then we will move the driver to chunk ID. Now let's say the chunk ID earlier was 1 and then based on the location change we got to know from the map service that okay, now based on the latest latitude and longitude pair, the chunk ID is 2. So ideally, if you remember, there was a question mark service. Okay, let me name it right now. It can be the dispatch service or the cab finder service. Let's call it the cab finder service because it keeps the note of what all drivers are belonging to a particular chunk ID. So earlier, driver D1 belonged to chunk ID 1, and as soon as the location changed based on the information we retrieved from the map service, we will remove D1 from chunk ID 1 and then it will add it to chunk ID 2. Now we will understand the cab finder service in a lot more detail, but this is what I wanted to explain, that okay, this is how the user or the driver keeps on sending the location pings to the server. Based on the location pings that we are getting from the driver, the map service will identify that okay, this is the chunk ID which it belongs to. So now let's start categorizing what all different services we have discussed till now. First one is the map service. The map service is responsible for converting the lat long to the chunks it belongs to. It also performs the calculations from point A to point B, that okay, this can be the potential route, this can be the approximate time taken to reach the destination, this is the approximate price which will be required for the cab service. So these all things are done by the map service. Now we kept on talking about receiving the location pings, so let's try and cover the location service in detail as well. So the location service is responsible for all the location data related to the user as well as the driver. Like user, I mean the rider. So let's say there is a driver, and let's continue this discussion only for the driver because the driver is continuously going to send the location pings to the server. And what the server will do, what the location service will do is that it will store the latest data into the table. Now we will have a table as we discussed earlier, which will contain the driver ID or the user ID, and it will also contain the lat and long of the particular driver. Along with this, we also want the entire history of the location pings that the driver or the user has been sending to us. Why do we need it? We potentially might be needing it because we want to perform some machine learning thing, or we want to perform some analysis on top of it. Let's say a trip has ended and the rider has challenged that okay, the driver took a bad route and that is the reason why the price has increased and I don't accept this particular price or this particular fare. So what the application will do in the backend is that it will check the entire location history and identify if this was the optimal route suggested by the map service or not, and then based on it, it will retrace the entire trip and identify if there was any mishappening which happened during the particular trip. So there are a lot of use cases, and for the safety we are going to store the entire location data for both the users and the driver. Now naturally, if we are going to store the latitude, longitude and the user ID, let's do some calculations to see how much data is it going to store. So for the user ID, it is going to be 8 bytes, 64-bit. Now for latitude and longitude also, let us assume it's going to be 3 bytes itself. So one row for one driver, it's going to consume 24 bytes, or for the ease, let's consider it 25 bytes for the computational ease. Now there are 1 million drivers who are active every day. So the entire capacity of the table is going to be 25 times 1 million bytes. Now this is going to be 25,000 kilobytes, and which is equivalent to 25 megabytes. Now 25 MB is quite small as compared to what all resource capacities we have nowadays. So this entire table can be stored in a Redis cluster in the form of a cache so that the retrieval is fast. Whereas when we talk about the entire location history of any user, it's going to consume a lot more data, and this data is going to grow along with time. So it doesn't make sense to store it in the form of a SQL database. So that data is going to be stored in a NoSQL cluster or a Cassandra database. So we have two things. The location service is going to hold the latest location data, and we are also going to store the historical location data. Now this is going to be stored in a Redis cluster for quicker access whenever we require it, like the map service can require quicker access to the latest location of XYZ drivers. So location service will transmit that data to the map service or any other service which requires the location data. So location service is the source of truth. Whatever location we require for any user, they are going to ask the location service that, hey, this is the user ID, can you share me the latest location, or can you share me the historical location for this user? Now this is going to be stored in Cassandra. Now I hope it made sense why the table size motivated us to use a Redis cluster, and it also helped us to get faster access to the location data. Now let us just beautify this entire system design diagram for the ease of understanding, and then we'll talk in detail about the cab finder service. We started from the map service, we went down to how we are receiving the locations in the location service. Now we'll take one step back once again and try and understand when a user requests for a cab, what the entire flow looks like. So first of all, let me just make a better diagram. Now we know that the user communicates with the server through a WebSocket. So this is a WebSocket server, and in front of the WebSocket server we will have a layer of load balancing. Now why do we need load balancers? Because as we notice, there are 100 million monthly active users, and since these users are a lot, we are receiving 100 QPS of traffic from each of these users. So ideally we would want to balance the traffic amongst the WebSocket servers. So it's not just one WebSocket server. There is going to be a WebSocket manager who is going to handle all the traffic. The WebSocket manager will know that, okay, this particular connection ID belongs to this user ID, and this connection ID is catered by a particular WebSocket server. So we will have a layer of WebSocket servers. It's a distributed layer, and then behind this layer we will have a routing service. Now what this routing service will do is, based on the request, it will distribute the traffic between different services. We talked about map service. If there are constant pings of location data coming in, then it will go to the location service. If a user is requesting for a cab, it will go to the cab finder service, and so on. So right now we talked about map service, we talked about the location service, and now let's discuss in detail about the cab finder service. Now ideally what the cab finder service does is that it matches the demand created by the user and considers the supply of the drivers in that particular radius or among different chunks. So it tries to match the supply with the demand. So some people might also call it a dispatch optimizer or the dispatch service or the supply demand service. So I'm going to use more simpler terms and put it as cab finder service. Now let's go in detail and understand what the cab finder service is and how does it cater a request of a user requesting for a cab. Cab finder service. So whenever a request will come, it will look something like this. I have this user ID. This is my latitude. This is my longitude. Go and perform the magic, right? So now this cab finder service calls the map service to identify what chunk it belongs to. Now the cab finder service looks something like a hash ring. I will explain in detail what the hash ring means as well. But to put it into simpler words, there is a distributed service where there are multiple servers. Each of this server is responsible for a set of chunk IDs. Okay, it doesn't matter what chunk ID is. For example, this is server 1, server 2, server 3, 4 and 5. Ideally, the number of chunks across the globe is going to be in the range of millions, if not billions. And I'm not sure, like it's going to be in the nearby order itself. But for the sake of clarity, let's just assume that the number of chunks is just 10, so that I can explain in detail what the cab finder service looks like. So each of these servers are associated with a set of chunk IDs. Now server 1 might be responsible for 1 and 2, 3, 4, 5, 6, 7, 8 and 9, 10. Okay, we have assigned the responsibility to each of these servers, and there is also a server optimizer or a manager of a sorts who is going to take control over what request is going to be sent to the server. Now this particular service leverages the benefits from consistent hashing. Consistent hashing. Now what consistent hashing means is, for example, we want to scale this service up because the number of chunk IDs increased. For example, let's say this is a chunk ID 5, and all of a sudden, you can say around 5 PM to 7 PM, the traffic inside this chunk increased. So ideally what the Google S2 service will do is, it will break the chunk into multiple other chunks, so as the traffic inside each of the chunks is almost in the similar range. We don't want bias to be there in any of the chunk IDs. So ideally, chunk ID 5 will get converted to something like 11, 12, 13 and 14. I'm just giving it random numbers. But what happened is, chunk ID 5 went off, and instead of it, 11, 12, 13 and 14 came in. Okay, probably we will leave the chunk ID 5 where it is, and we will just replace it with 14. So the number of chunks increased, and the responsibility for a particular server will also increase. For example, earlier it was the responsibility of server 3 to cater to the traffic belonging to the chunk ID 5. Now with the increase in the servers, it might be allocated to any of these servers. For example, we might assign the responsibility of 11, 12 and 13 in any random particular order. So what consistent hashing does is, whenever the scale increases, it is easier to add servers. Whenever the scale decreases, we can just get rid of some servers, because a bunch of chunk IDs might be merged into one. Okay. So hash ring has a structure of a ring, like that is the reason why we call it a hash ring. And it has some nodes on top of it. 1, 2, 11, 3, 4, 12, 5, 6, 13, 7, 8, 9 and 10. Now the entire concept of hash ring is in such a way that whatever chunks or whatever items are there before a particular server, it will cater traffic for that particular chunks. For example, between S5 and S1, there are 3 chunk IDs. So ideally, it will be the responsibility for S1 to cater the traffic in those particular chunks. And the same, like 3, 4 and 12 are there between S1 and S2. So S2 will be responsible for that. Now, for example, let's say we want to get rid of some chunks, and ideally we will remove one of the servers. Okay. For example, we just removed S5. Okay. So what will happen? The hash ring will remain as it is. Now ideally, S1, which earlier had only 1, 2 and 11, it will now also cater traffic for 9 and 10. So just by the removal of a particular server, it doesn't require a lot of changes. It obviously doesn't affect what happens to S4, S3 and S2. They can remain as they were. And the server manager, which we talked about earlier, they are notified that, okay, now S1 is also catering the traffic for 9 and 10. Now there is another protocol which is used for this particular matching algorithm or cab finder service, which is known as gossip protocol. So whenever the responsibilities of any of the server changes, it will just gossip to the other servers that, okay, now I have got more responsibility for chunk ID 9 and 10 as well. So if there are any requests for the particular chunk ID, do assign it to me. For example, in the earlier, let me just get rid of some of the clutter over here. So for example, if we receive a request from a user belonging to chunk ID 6, okay, So what the cab finder service do is, first of all, it will identify which server is catering to that particular chunk ID. So over here, it will identify that, okay, S3 is catering to chunk ID 6. Now it will communicate with the map service and identify what all chunks are nearby the chunk 6. Now, in our case, I'm not sure what all different chunks are there, but let's just take an example and let's just call them random numbers 3, 7 and 12. So what S3 will do is that through the gossip protocol, it will know that, okay, 3 belongs to S2, 3 belongs to S2, now 7 belongs to S4 and 12 also belongs to S2. So it will send requests to both S2 and S4 that, okay, I am server 3 and I want the data that what all drivers belong to 3 and 12. So S2 will get a ping that give me the list of driver who belong to 3 and 12. S4 will get a ping that give me the list of drivers belonging to chunk 7. And then based on all the drivers, we will send the pings to each one of these drivers that there is a request for a cab service. Do you want to accept it or not? So in this way, the cab finder service finds the drivers who are in the vicinity and sends them the pings through WebSocket Manager. So let's move on to the next concepts. I hope it is clear what the Google Maps or the map service does, what the location service does, and now we have also covered what the cab finder service does. Now we have covered 3 major services which are going to be part of our Uber application: the map service, the location service and the cab finder service. Now let's have a check at the functional requirements to see what all functional requirements we are yet to implement. I think one important chunk which is missing is the trip service. We haven't yet stored the information related to a trip, when the trip is accepted, when the trip is started and when the trip ends. We also haven't checked at the payment service. So let's just make a note of what all services are remaining. Create profile is remaining for both the drivers. I think that is very self-explanatory. Like we will have a profile service which will expose some of the CRUD APIs like create a profile, update profile, get profile and delete profile. So I'm not going to explain that in detail. The profile service will take care of that. Now show availability for the driver. It is exposed to the WebSocket server that whenever the availability is live, it will start sending pings to the location service. Now show cabs nearby is done. Start and end location, show ETA, book cab. So we have almost covered 2 to 4. Book a cab is also done. Payment service is remaining. Rating the driver can also be done through the profile service itself. So for that, we are not going to expose a different API. Like for rating, we will expose a different API, but we are not going to have a rating service just to rate the driver or the user. So this rate the driver is also done. One thing we are remaining is the trip service and possibly a payment service as well. All the navigation portion related to the driver is going to be handled by the map service, and start ride and end ride, that is going to be handled by the trip service. So let's just go and understand what the trip service and the payment service will look like. I think this is empty. We can take use of this particular page. So whenever a trip is accepted, we can just have a trip service first of all. We will have the entire chunk of WebSocket servers and we will have a load balancer, routing service and so on. And ultimately we will have some trips location, trip service, my bad. So whenever a ride is accepted by the driver, a new trip will be created and added to the trips database or trips table. We are not sure, we will discuss that, how we want to go ahead with it. But let's just look back at the numbers. We were having 10 million rides in a day and there are 24 hours. So ideally we had 100 QPS or 100 rides were getting created almost every second. So we can divide the trip service, the database of the trip service into 2 parts. One which is going to store all the inactive trips or the completed trips. They can be rejected trips as well. They can be completed trips as well. Now that database is going to keep on increasing with time. That is never going to stay the same or saturate down the lane in future. So ideally, as we discussed related to the location service as well, we would want that data to be stored in a Cassandra cluster or NoSQL cluster, because it's going to grow on and on as the time increases. So we'll have a Cassandra cluster which will store the data for all the inactive trips. For the active trips, let's make a calculation how many active trips can be during any time. So 100 QPS is there. In 1 hour, we can assume that one trip lasts for 1 hour approximately, or 100 minutes, just to make the calculations a bit quicker. So approximately 100 QPS is converted into 100 minutes, and in each minute there are 60 seconds. So ideally this is going to be in the range of 6 into 10 raised to 5. So this data can be stored in a SQL cluster because it has a higher probability of getting retrieved by the user on an active basis. So we would ideally want the read latency for that particular information as less as possible. Most likely the Cassandra service is going to get retrieved whenever we ask for some past trips or some payment information that will be covered by the payment service. But we will have a live corpus of a SQL database, and we'll store the information for all the live trips in SQL. And what we can do is we can also have a trip archiver or a cron job. This is an archiver. What this archiver will do is every 6 hours or every some X hours, it will run a cron job which will transfer the inactive trips from the SQL database or the Redis cluster to the Cassandra cluster. So in this way, the entire trip service can be configured. Now going to the payment service also, it is quite self-explanatory. It's not as complicated as the location service or the map service or the cab finder service. Whenever a trip ends, which is also notified by the trip service, whenever a trip ends, it will send a notification to the payment service to make the calculations of what amount is going to be there for that particular ride based on the distance covered. Now this trip service will have the entire ping of location data both from the user as well as the driver. Why do we need both of them when they are sitting in the same cab? In some cases, there can be fraudulent charges raised by the user to the driver, that the driver dropped the user in between. So we can configure or we can manage all of those challenges or all of those complaints by having the entire history of location pings during the course of a trip for both the user and the driver. So the trip service data is going to be quite heavy because we are going to send location pings every few seconds from both the users. So the trip service will have the location data, it will have the start location, end location, start time, end time, and all the information which is necessary for a particular trip. Whenever the trip ends, we will also have a trip status: accepted, started, and ended. These three can be the trip status. Whenever the trip ends, it will send a ping to the payment service saying that, hey, this trip ID has ended. Based on the location data, calculate the kilometers traveled. Based on the start time and end time, calculate the time taken. And based on all of these information, find out what will be the price of the cab. So payment service is also almost a trivial one. I mean, not as trivial as the profile service, but this is also a trivial one. And we'll configure the payments based on this particular service. Now, if we look at the entire diagram, so over here we have added 3 more services if I'm not wrong. One is the trip service, one is the payment service. Now this payment service will also be configured with a payment gateway. It can be Stripe, it can be Razorpay or any other payment gateway feasible for the application. And lastly, the profile service. Now let us try and cover some of the ad hoc technical concepts. Let us try and cover some other ad hoc technical concepts. For example, whenever you are in a mall, you must have seen this a lot of times. Instead of a particular pickup location, there is a preferred access point. Let's say this is a campus. Okay, let me cover the example of my hostel itself. Like I was in IIIT Hyderabad, and let's say this is the map. Now there were multiple access points for the cab drivers. There was boys hostel over here. There was girls hostel somewhere here. This was the main entry gate. And this was the academics block. Now at each of these 4 locations, there were preferred access points given. Now how does Uber compute them? Now if you notice, whenever you start a ride or end a ride, we have a location ping associated with it. Now based on the aggregations of this location point over a historical time period, now it can be over a few days, it can be over a few months, we will realize that okay, these are few of the preferred access point inside the campus boundary, and then the proper nomenclature will be done for all of them, that this is the entry gate, this is the academic block pickup, this is the boys hostel, and this is the girls hostel, and so on. So based on the aggregated data, if you remember, we stored all the location data along with us, and we were confused what all different things we could do with that location data. So we can perform some sort of machine learning aggregation on top of it. We will store all the data which is present in the Cassandra clusters. It can be the trip service, it can be the location data, and so on. We will pass it to the Kafka queues, and that will be consumed by different services. It can be consumed by the machine learning fraud services. I will talk about that also. It can be consumed by the Spark Storm service as well, which will perform some analytics on top of the data that we have given. For example, the preferred access point is one such service. And then it can be consumed by map service as well. For example, if the traffic is increasing or decreasing, it can lead to price surging as well. So all of these different niche concepts related to a cab service application, this can be done on top of the data that we are storing inside our different services. So in this way, preferred access point can also be covered. Now, for example, when we're finding the potential drivers who we are going to send the pings for in order to book a cab, it is also a possibility. Let me first show you what I mean. So here's the user denoted by the red cross, and we have some drivers who are waiting for the cab service. Now there can be one such driver who is going to end their trip at a particular location near the user. So ideally we would want this particular driver who is about to complete his or her trip in a nearby location to also be considered in the potential candidates for the drivers who we can send the pings. So all of this data is done on top of machine learning, and all the data that we are storing with the trip service. The trip service knows that, okay, the trip is about to end, the trip with this particular trip ID and the driver ID is about to end. So we can also send the ping to this particular driver that, hey, your trip is about to end, do you want to accept a new ride or not? So there is a lot of things going on behind the scene when we are searching for the drivers to book cab, when we are routing through a particular city, and so on. A lot of things are done in batch mode as well after the trip has ended. For example, the preferred access point was one such thing. Now I also talked about a machine learning fraud mechanism. For example, a lot of drivers do this thing. There is some sort of an incentive. Let's say if a driver completes 10 trips, he or she is going to get 1000 rupees extra. So if the driver has just completed 9 trips, they can just book a ride with another mobile phone of theirs, and they can then complete the ride just to get that additional incentive. So all of that payments data, all the location pings that we are having, all of these data is aggregated and then used to detect any fraud if possible. So now we covered a lot of topics, lot of technical concepts which are important for the overall understanding of Uber's system design. So let's just go through them once again. So these are the 6 services that we talked about: map service, location service, cab finder service, profile service, payment service, and trip service. We know the responsibilities of each of these services. Let's once go through the APIs which each of these services will cater to as well. Now these APIs, I didn't cover them in detail because it felt a bit trivial after I explained all of those technical concepts and what are the responsibilities of each of these services. So I think you can just pause the video at this moment just to have a look at the different APIs. Now one important thing which I want to highlight for this particular APIs part is that, let's say I want to delete a profile. Okay, over here I am just sending the user ID of the profile which I want to delete. I cannot delete the profile of some other user ID. That is quite an intuitive thing. So how does the service know that, okay, the user ID which I have mentioned and my user ID, both of them belong to the same person or belong to the same profile? So ideally for each of these services, all of these services, there is some additional context that we are going to pass along with it, and that can be in the form of user token or some sort of an API key on top of this. So we can have a user token. Now both the drivers and the users can have this user token in order to authenticate themselves, that if you want to get a trip with this particular user ID and trip ID, the user ID should belong to you. So we can use a user token or some sort of an API key. So I deliberately missed this particular part out from this API slide. so that you get an idea of authentication mechanism as well along with this. So whenever a user is logged into an application, there will be some token or API key created against them. And this is going to persist over a longer time as well. If it's an API key, the user token will get generated every time the application is opened. Now this is the entity relationship diagram. What all tables can we store in our database? We already talked about the location table, which is going to persist all the information. We have the trips table. As we talked about the start location, end location, we have the status as well. We have the location ID, which is associated with the locations table, and it's a repeated entity, you know. Every 4 seconds or every 5 seconds, some location ping will come and will keep adding that location data to the trips table. Now, we covered all the different services. We covered fraud detection as well. We covered maps machine learning as well and driver profiling as well. Like based on the fraud detection results and based on the ratings that people have given, the users have given to the driver profiling can be changed. Now, all of the data can be transmitted live through the Kafka queues, or they can be asynchronously passed in batch mode. Along with this, just for the sake of completeness, all of these services are emitting some logs. Okay, this can be error logs, this can be just debugging logs as well. Now all of these logs are consumed by Kafka queue, and then on top of the Elasticsearch logstash Kibana ELK, on top of this particular service, ELK service, Elasticsearch logstash Kibana, we can perform log analysis and create some visualizations as well. That okay, what was the availability, what went wrong at particular time, and lots of important graphs related to monitoring and alerting can be created on top of it. So I think this is a good part to end the particular video. Like we have covered a lot of services, we have talked about a lot of technical concepts as well. We have talked about some machine learning concepts also, which can applied on top of the information that is transmitted from the different services. I really hope you enjoyed watching through this video where we talked about some of the most important technical concepts related to an Uber-like large-scale application. If you found this content insightful, make sure you give it a thumbs up, add your opinions and query in the comment section below, and lastly, don't forget to subscribe to Scaler's YouTube channel and don't forget to hit the bell icon so that you never miss out on insightful content.
Hey, hi, this is Arnav, and in this video, we are going to be covering a low-level design problem, which is actually a very popular problem to solve both in terms of interviews and also just as a LLD practice case study, very common, which is designing a tic-tac-toe as a game. Something probably as simple as this might not come in a real interview, might be a little more complex, what actual interview low-level design problem statements might be. But this is a good place to start off from to get an understanding of how game kind of things are designed. And there are a lot of game system design questions that come in interviews, for example, snake and ladder or a Wordle game, things like that. So quickly, let's start by understanding the problem statement first, and then we will go on to actually write the code for this. So the problem statement is that we have to design a command line based 3x3 grid tic-tac-toe game that can be played by 2 players. So it depends on how the problem statement is given to you. In this particular problem statement that I am showing here, the problem statement itself specifies that the board, the numbers of the boxes should be A1, A2, A3, B1, B2, B3, and C1, C2, C3. Sometimes this might not be specified, and it's up to you to decide whether you want to number the boxes as 1, 2, 3, 4, 5, 6, 7, 8, 9, or by 1, 1, 1, 2, 1, 3, like that. It's a 2x2 matrix kind of a setup. But in this case, we have been said that we should number the board like this. The game should have 2 players. Every player by default has the character X and O, which is crosses and O's for tic-tac-toe, but player should be able to pick their own character if they want to as well. So if somebody wants to go with, say, an emoji instead of X, right, they should be able to do that. and both players must not have the same character. That's something that you have to add into the logic of the game, and every player has a name as well. Then there's the game. So the logic of the game is that the game starts with player one inserting the character on one of the boxes, and players get alternative turns. Some additional complexity that is possible here is maybe, if you're facing this in an interview, somebody can say that, okay, add a toss facility in the beginning which randomly decides whether one or two player will get it. In this case, player one will always start. Players will get alternative turns. On every turn, you ask on the command line which input box that the player wants to insert their character into, and after every turn, we show the state of the game, basically show the state of the board at this stage, and along with that, we are supposed to do one of these things. So we need to do, like, if player specifies the wrong box, then the player gets to try again. If the player selects the correct box, in that case, this move itself might end up winning the game. So either do that, or the player does not win the game yet, the game will continue, or maybe it is that this is the ninth move. So if it is the ninth move, then the game ends and it's a draw. So handle all these cases. Winning condition, as happens in a tic-tac-toe, is that the same symbol in one row, same symbol in a column, or same symbol in a diagonal. Okay. The data format for the game is also given in this case. Sometimes it's given, sometimes it's not. Here it's saying that to initialize the game, we have to do something like this: enter player one name and then enter player two character. By default is X. Enter player two name, enter player two character. By default is 0. I think this should be player one here. A little bit of a mistake there in the problem statement. Then the gameplay is, it will always show the board first. This is the state of the board. Then enter player one's move. Player one adds a move to A1, so player one's character gets added to here. Player two enter box. Player two goes for A2, and so on. That's how it will go. Some expectations are given to us. So make sure you have a working and demonstrable code. Make sure the code is functionally correct. Code should be modular readable. Separation of concern should be addressed. General stuff in mostly all things that are given. Do not write everything in a single file. Separate out your code base. Code should easily accommodate new requirements with minimal changes. Write unit tests wherever applicable. That's an important thing. We will have to write unit tests, and optionally some requirements are that if we have time left, keep the code extensible to change the size of the grid. Keep the code extensible to allow different types of pieces. Keep the code extensible to allow more than 2 players or pieces or types. Okay. So apparently these things, if possible, we have to do that as well. So let's first try and see how to code the minimum requirements, and then we will see how we can maybe add the optional requirements to the game as well. Okay. Okay, so before we start coding the solution for our tic-tac-toe problem, just a quick note on the setup. So I'm doing it using TypeScript for this video. So just a simple idea about, I have the TypeScript compiler and Jest installed for running the tests, TS node, so that I can execute my TypeScript files. And we've got a src folder where we have the main file where we will write our code, the test folder where we will write our tests, the package.json file which has the start script which runs TS node. That's all. Most of these setup is usually not going to be important in a interview kind of a setup, because generally you have a hacker rank or some online ID inside which you will write the code, where the setup is sort of done for whatever language you're going to be picking. But this is just to set up a base line from where we will start with. Okay. Usually you are not allowed to install any libraries as such. So the only libraries that I actually have installed here is Jest for testing and TypeScript for compiling the code, the TypeScript code. That's all. You should usually not have anything other than that. Anyway, so to get started with, I would actually make a new directory for the entities. We would need basically 3 entities here. We would need a board file, we would need game, and a player. Okay. Okay. So essentially a board should need, all of these would be classes. Okay. So class game, this would be class player, and this would be class board. Okay. So essentially we would have like the game would need a board and a player inside it. And then we will run the game from main. So we'll start a new game, something in the sort of game g equal to new game, and then game dot start. That's all we will have on our main file. Okay, so that's sort of how we will set up our project. Tests is to be able to run tests for our board, our game, a player, and then so on and so forth. Okay, so let's get started with the basic stuff that we will need. So for the player, we need, obviously we have found out that we need a name and and we need a character. Okay, what we can do is we can pass all of these two things inside a constructor. That when we construct a player, we pass a name and a character. We can also do a builder pattern kind of a thing as well. So what we can do is player dot builder, right? We can do a builder pattern so that we build a player, set name, set character, right, like that. Okay, for now we can construct the player using a name and a character. Default character, as we have seen, is going to be X and O, that we will handle inside the game class. For example, we can do that. Okay, board needs to have a sort of the grid itself, so we can actually have grid, which will be an array of an array of we can actually do an array of a string here, equal to, and we can actually write this itself. So we can do something like this. Okay, so 3 of these. So technically the board looks like this. Okay, so that's the grid. We will have to specify a way to print the board. So let's, and then inside the game, we will need to start the game, initialize the game. Okay, so that's sort of how our entities would look like. Let's get down into actually detailing out, obviously, the entities, right? So character, by default, we will create one. So game, what we will have is we will have P1 of type player. We'll have P2 also of type player. Okay, we will have to export these, by the way, and we have to export the board as well, and we'll have to export the game as well. Yeah, so player has to be imported. Yeah, and we will have the board. Okay, got it. Now if we have to create a builder kind of class, how do we handle that? So we can create a builder pattern for the player, and we can create a builder pattern for the game. The board did not have a builder pattern because we can straight up create a board and it has the grid at its initial situation already. Okay, so if we do here, basically, I think we don't need a export here. Actually, so we don't actually have a inner class kind of a pattern that exists in Java. So what we can do is we can basically have a player builder itself. So you can do like a player builder, okay, which should have a name and a character. It should have a constructor which has neither of these things. Okay, sorry, it should not have anything here. So we will do is create a setter for these two. Okay, and return this from both. Okay, got it. Then we will have a build function. So we'll have a build function that returns a player type, basically. Okay, and return new player, where we pass this dot name and this dot character. Okay, in fact, yeah, we can make the constructor sort of private if you want to, like module private or something like that, which we do in Java. Here TypeScript does not really matter. We do it like this. So we have a player builder. Okay. So in game, when we sort of initialize the game, we will have to build the players basically, right? So that's one of the first things that we'll do. So game should also have a game builder essentially. Okay. So we will have a okay. As the game builder, we will set the player 1, set the player 2, and initialize the board. That's all that we need to do in the game builder. Okay. One of the main things about the player builder still is that we should not allow, if we have a builder pattern, then we should not allow somebody else to be able to build the player automatically. So one thing what we can do is we can do something like this. We can write static builder equal to, and maybe we can use the class player builder actually directly there. Okay. If we do this, then we can make the constructor as private, which would mean that in main.ts we can't write const p equal to new player. This is gonna be invalid because this is gonna be private. But what we can do is we can do pb equal to new player dot builder, and then we can do pb dot set name, and then dot set character, and then dot build. So this is gonna be possible. In fact, we can actually try this out. So set name, let's say my name, and then set character. Maybe my character is, let's say this, and build. So console.log pb dot, not pb, const p equal to. So now we can do p dot name and p dot character, right? So this, if I just sort of want to run, I think the start script should do it, is yeah, Arnav and emoji that has sort of been built. Okay. If we want to, so that becomes my player builder pattern. Okay. Then sort of we can do something similar with our game as well, right? So what we can do is we can do static builder is class game builder. Okay. Now we will obviously have finally the build class. So we will have a build function that returns a game object, and we will do, so we can do a private construct. So we can do like basically a private constructor of all the 3 props, and this can create this. Okay. In terms of board, we can allow directly board creation because directly grid is there. So what we can do is here in sort of the build function, return new game, but to return a new game we need a p1 player, a p2 player. Okay, so what we need here is p1 character. Okay, or we can just do this thing. We can have p1 and p2 as players inside here as well. So we're going to create player 1, right? Inside create player 1, we have to read the value of the basically name of the player and character of the player, which we can default to X. Okay, so create player 1 p1 equal to new player dot builder dot set name, sorry, set name would be this, dot set character would be character, and build. Okay, this dot p1 equal to this. So I will do something similar with creating the player 2. This dot p2 would be in similar fashion. Okay, and then we will create a new game where we will pass p1, this dot p1, then this dot p2, and new board. Okay, that's how we will build a game. But we will have to have some process here, is that if p1, if this dot p1, sorry, if not this dot p1. Okay, throw new. We have to create a new error here. Create player one before creating game, or you need to create player one first. And similarly, if p2 does not exist, then you need to create player 2 before building game. Okay, so now we have a good situation here is that when we want to create sort of the game itself. So if I do, let's say const game builder equal to new game dot builder, right? When I do that, then if I do gb dot build, okay, straight away, what will happen? I will get an exception. Get an exception that you need to create player one before building game. So I will have to do gb dot create player one, give a name, right? And sorry, that's player two. I have to return this from within here in each of these. Okay, so then dot create player one. Let's say num1 is player one, Arnav is player two, like this. Now if I run, it sort of works. Okay, this will not work if I don't have any of these lines here. If I don't have player two, it will also fail, again with the exception that we need. Okay, so we have a mechanism to build the game, build the player. Now we have to start adding all of the logic inside our board layer and the game layer. So the game needs to have the logic of moving to the next turn and asking for inputs and all of that. So essentially, in our main thing, what we will really do is we will create a game using the game builder and start the game. Okay, so game.start, something like that, which will do every turn one by one. So the game will have the driver code, which is called the game driver, and the board would have sort of the logic for selecting each kind of variable. Okay, so let's go and try to build that. Okay, next what we'll do is let's start adding some of the methods on the board logic. So with the board logic, what we need to do is we will do a few things like we'll have a print board function that can print the board, and we will do like marking different spots in the board by a player. So let's start doing that. Okay, so of course we can have just print board. Okay, print board should be pretty simple. We just go ahead and print sort of console.log, and we print the board. What do we print here is we can do this dot grid 0 0, and we can have basically this. Okay, if you want to be extensible, we should do a row wise printing thing here. Actually, we should do print row 1, print row 2, print row 3, like that. We should so I'll just this is sort of hard coded. It's not extensible code actually here, printing it like this. Okay, so probably like actually iterating through the grids is kind of better. I will write you can actually write some code here that this grid can be made extensible, like board size. Okay, so we can have actually something like const board size equal to maybe 3, something like this, if you have like at the here. Now we can do like make it board size based. So that extensibility I'm not building actually right now. If we do that, that's sort of better. So we will cover that towards the end and see how it can turn extensible. But anyway, so 0, this will be sorry, yeah. So this would be 1. This and this would be 2. This and this would be 2, and this and this would be 1. Okay, so that's sort of print board. Mark board, and inside mark board, if I do basically Okay, so the box would be box A1 or B2, like that, and character would be the character that the player is marking. Okay, so to mark the board, we will have to obviously check a few things. So first of all, if box dot length not equal to 2, throw an error. Invalid box identifier. Okay, then what happens is const row equal to, or something like box dot caret 0, right? And or we can do something like this, const row equal to a b c dot index of box caret 0, and const call equal to box dot caret 1. Okay, so then what we will do is, if grid this dot grid row call, not if this equal to already underscore, in that case we can write throw error, or we can return a boolean here. Okay, and what we can do is in this case return false. We could not mark the board because that grid is already taken up. Okay, so this is the mark board function. Else what we do, this dot call equal to whatever character we are marking the board with. Okay, return true. Okay, so just to sort of try this part of the board out, we can try it on the main actually. So what we can do is const board equal to new board, sorry, right, I call print board, board dot print board. Okay, then I do board dot mark let's say a1 with this character x. Okay, and then do board dot print board. Let's see how this looks like. Okay, this did not work. So print board worked, but marking a1 at x and still print board did not work. So let's see why that did not happen. We can do is, oh sorry, so if it is not marked as underscore actually, so then we return as false. Okay, so yeah, this marking happens. One important thing is, now we realize that in our game we cannot allow people to have underscore as a character, so we can add that error here in player. So this dot character, if value, we can do throw new error, okay, so we can't allow underscore as a valid player character. So mark board this. Okay, cool. So that's how mark board looks like. Then if we want to sort of see get row as string, okay, which returns a string. So if you want to do that, okay, so what we want to do is if we pass row a, b or c as a string, right, so row, we can do this same thing, const row equal to okay, and then we can return this dot grid of that particular row, and we can join it with an empty string. Okay, so this gives us certain things like board dot get row as string of row A. It will show this row itself. This is useful to find out who has won or not. Okay, so let's see, get row as string. We can do a get call as string as well. Okay, so we can take this one as a number actually. Okay, so we will basically do return, and we'll create an array of this dot grid row 0 of this particular column. Okay, we will through our inspection kind of things. So if call less than 0 or call greater than 2, we can have a throw new error here, 0 and 2, right? We can do something like this here as well. So if row name not equal to A, B, C, we can do A, or we can do something like this. If ABC dot index of this thing, basically if ABC dot index of row name -1, then row has to be A, B, or C, like this. Okay, so get row as a string, get call as a string, that returns our column as a string. We can print column number 1 here. Console.log board dot get column as a string. Which column? I want column number 1 actually. That should print x __. Sorry. Yeah, so this works. Okay. So we have got the row as a string, column as a string, and we can obviously we can have two diagonals, diagonal 1 and 2. So if diag number equal to 1, we can do this. Else if diag number equal to 2, we can do another thing, and else we can do error. Okay, so diagonal number 1 is gonna be technically 0 0 1 1 and 2 2, and diagonal number 2 would be 0 2 1 1 and 2 0. Okay, so if diagonal number 1 is this, then return. If diagonal number 2 is this, then return. Else throw new error, invalid diagonal. Okay, so get row as string, get column as string, get diagonal as string. We can print those values, which is useful to check if somebody has won in the board already or not. Okay, so the board, we don't really need anything else. We need to be able to print the board. We need to be able to mark the board. We need to be able to get rows, columns, and diagonals as strings. Okay. In the game code now, we will have to write the sort of driver code, which is basically play each turn, who has the current turn, check whether victory is there or not. Okay, so that's what we will do next. Okay, let's see now how our game code might look like. Okay, so we build a player, create player 1. I think we should do is add player 1 and add player 2. I think that should be better sort of names. Add player 1, add player 2. Anyway, so we do this. Okay, so this is to build a game. This is sort of done. This is the constructor. We need to also have this value called turn. Okay, so let's say we have turn equal to 0 initially. Okay, turn equal to 1 initially maybe, or we can do 0 as well. Okay, so let's say we have a function called play. So while turn less than 9. Okay, so we will do certain things, of course. When we reach, like, turn becomes 9 basically, right? So this is a draw condition. Okay, or we actually have, sorry, so if turn equal to 9, so with play, what we will do is we will take the box as string. Okay, so play box as string, whose turn it is. So player would be basically turn this dot turn modulo 2 equal to 0. In that case, p1, or in the other case, p2. Okay. Sorry, yeah. So this dot p1 or this dot p2. Okay. So this will be our player. Okay. Now what we have to do is we check board dot mark board the given box. Okay. With the character of player dot character. Okay, so we do is const success equal to this dot board dot mark board. Okay, now sorry, so if not success, okay, or rather I would say if success, then we do is we do turn plus plus, and turn should then not be a const, of course. So we do this dot turn plus plus, so turn increases, and if this dot turn becomes 9, then game should end. So basically here what we would have is game ended in a draw. Okay, now if success, then we do turn plus plus, else we don't need to do anything, we will just have to play again. Okay, so to play, what we will do, so if it has been successful, then we also have to check that whether so we will also have a game state. So what we can do is type game state equal to started, won, draw. Okay, end winner, and we have end draw. Okay, so initially we will have game state, okay, like this. So initially we have game state is started. Okay, we will change it to winner or draw. So if turn is 9, then state equal to end with draw. this dot and a straw. Okay, now we have success. Then we need to check whether no this was a winning move or not. Okay, so we can have a function private check winner. Okay, now this winner would usually only be basically the current player who has turned, that is the player who can win. Obviously no other player, like the other player can't win in current turn. So if I am playing this turn, then after I have put something, then I can only be possibly the player. Okay, so check winner whether it's player is of type player and with the board. So what we have to do is player dot character. Okay, const winning line equal to, basically winning line would be right. So this would be the winning line basically being the character 3 times. Okay, so we will check basically A, B, C dot for each. We can do so rows dot for each. What we can do is board dot get row as string r if this is same as winning line, or we can do is for let row in A, B, C if this dot board dot get row as string equal to winning line, then return true. Then for let call in 0, 1, 2, similar thing. If board dot get call as string in the call, then return true. Get call as string, are we taking call as number? We are taking call as number, right? So okay, okay, we have to use off here, I'm sorry. So with the let call of 0, 1, 2, we do this, and then finally we do something similar for the diagonals as well. Okay, else we return false. Okay, so do the check winner thing. So if check winner with this current player, then this dot state equal to winner console dot log game over, and we will write the player who has won. So the player who has won would be game over, player has won. Okay, then we can directly, I mean, we don't need to do the turn plus plus technically anymore. We can just return from here. Otherwise we do turn plus plus. If turn becomes 9, then we can say we have ended in a draw, game has ended. Okay, and we check for the success. Okay, we can create a function for the prompt as well. So we can do is the next turn prompt. So we can do is next turn prompt can be a string which says that this dot turn, I think we can do +1 actually, turn number, or we can start from 0. That's, I don't know, it depends on the user use case. We want to show it from 0 or something like that. This dot turn +1, and we can do so we can do the same thing here. Player dot name, and then we can do inside brackets maybe player dot character. Okay, so this prints the next turn prompt, and then we return as play, and then we keep continuing like this. So what we can do in the main section now is we can do something like this. I'll remove all of these things. What we need to do is we need to build the game, of course. So const game builder equal to new game dot builder. Okay, player one name equal to and this is where we will need to read data from the console a little bit actually. Okay, so what we will do is we'll use this import star as RL from. So we'll use this module called readline sync. What it does is we can do things like RL dot question, sorry, RL dot question, and we can pass a question here, enter player one name like this. Okay, so what we do, player one name, player one character, player two name, and player two character. So enter player one name, player one, we will say by default it's gonna be X. Okay, and player two name would be player one name. So in question, I think we can pass some options. Options, maybe I think we can have a default input. So we can do like this question, this default input is actually X for this, and here default input is actually for this. Okay, so then what we will do, game builder dot add player one with player one name and player one character. Okay, we'll do the same thing here. Okay, then we will do const game equal to game builder dot build. Now once game is built, we will run the game while game dot state equal to started. Till then, what we will do, const box equal to rl dot question, and inside question I will pass game dot next turn prompt, and then whatever we get in the box we do game dot play that box. Okay, most likely this should work. Let's see how does it look like. So enter player one name, let's say I do Joe. Player one character, let's say I put I don't know, I put some J here. Okay, player two name, and I put player two name as Paul, and player two character P. So turn one player one, what do we enter here actually, right? So A1, we have a problem. So here, so apparently when we're doing get diagonal as string, we are passing diagonal 1 and 2. Okay, sorry. So we are supposed to check for diagonal 1 and 2 rather than 0 and 1. Or rather I can do this and check for diagonal 0 and diagonal 1. Okay. So what we have to do here is after every turn, we have to print the board as well. So I forgot doing that. So here inside game, if board is success, this dot board dot print board. Okay. Or inside main, I think I will do a little bit of difference. So I will do game dot next turn prompt. Like this. Okay. So now we have enter player one name Joe. Let's say we go with J. Paul. We go with P. So turn one player Joe, enter box. So I go with A2. So J here. Paul will go for B1. Okay. So like this. And then we pass A1 maybe. Like this. And then we will have, oh, actually, we need to index it up actually. So according to our problem statement, which we had A1, A2, A3. So our row numbers should move one more. So here when we add mark board box, so box dot length, so row is this, call is going to be this plus 1 actually, minus 1 technically. Okay, so number is going to be box dot character at 1 minus 1. So we will mark it accordingly. Let's play it again. So player 1, let's say we go with Joe, we give default X, we go with Paul, maybe default Y. So enter box A1, Paul would go for, let's say, B1, then A2, B2, let's say, then A3 if we go. So game over, Joe has won. I think we should print the board state for all the cases, so we can do that. Maybe what we can do is this dot print board. We can do it for all the cases, whether or not success. Okay. So we print the board, then we ask for the turn like that. For everybody we will do. Small typo here. This is by default supposed to be O. So that's pretty much it. Our basic game sort of is working at this stage. We don't need to import board. We don't need to import player. Yep. So let's start again. So player one name, let's say Arnav. Player one character, we can go with an emoji maybe. Then player two name, Naman, maybe another emoji. So enter box A1, enter box A3, let's say B3, B1, right? C2, C3, A2, A. If I do A1 again, if I keep doing A1, it'll have to, same player has to keep on with that turn. We need to show the error as well that, box already taken. We should do something about that. But anyway, we can go with B2 and then finally with C1. So game finish in a draw. So basic game logic sort of is working. We haven't added the tests yet. We should add the tests and all of these error conditions to be shown. We should do that as well. Okay. Okay, so let's see how to add a little bit of testing code. So to test, let's say we add one TypeScript file which will test for testboard.spec.ts add. So we write tests like this. Test name of the test board initialization works. Okay. Don't really need the assert done callback, I think. So this is basically to check some errors inside the done callback anyway. So what we do is we will do stuff like this. So to check for the board initialization, const b equal to new board. Okay. We have expect b dot get call as string 0 dot to equal. So we do for 0 1 2. Get row as string also. A B C same thing, and get the diagonal also. Get diagonal as string, diagonal 0 and diagonal 1 to be the same. Run the test. We need to call assert at the end. I think assert should be called with anything, I think. Yeah. As long as it is not with an error. Awesome. So board initialization works. So test board marking works. So for that, what we will do, const b equal to new board, something like this only. Then b dot mark board a1 as, let's say, k. So expect b dot get row as string a dot to equal k underscore underscore, and b should be fine. Expect b dot get call as string also 0 column to also be equal to this thing only, and finally assert. Okay, so board marking works. This works. Okay, technically we can run all tests also. So board initialization board marking works. Okay. We should be able to run all tests with coverage as well. So when we run all tests with coverage, we will see that inside my entities and board file, there are still some lines not covered, which is we are not checking whether the marking identifier is wrong. If that's the case, we are checking that or not. If we are trying to mark a board which is already marked, we are checking for that or not. Okay, so we will have to check those as well. Mark board should be false. For that case, we should check that. Get row as string wrong value we have not tested. Okay, so when we test for coverage, we will see that there are certain lines we have not tested, which means we only tested the successful cases, not the unsuccessful cases. So we should test for the unsuccessful cases too. So to do that, what we need to do is test. Okay, how to do this? So repeat marking returns false. So b dot mark board a1 character k const attempt 1 const attempt 2. equal to b dot markboard, again a1 with any value, let's say 0. Okay, so we have to see expect attempt 1 dot to be truthy and expect attempt 2 to actually just to be true and false. Okay, so let's try this. Works fine. Okay, so we have to check that if we mark the board again with the same parameter, we get false. If we run this with coverage, we will see our coverage. Of course, if we run all tests, some coverage increases. Mark board with the false condition, this gets covered. Still don't check for whether the box name is invalid. How do we test for that? So that also has to be tested for. Okay, so we have to do const b equal to new board. Now if we do expect, actually here we will do b dot mark board on say a3. A3 is there, a4 mark with any letter, let's say G or 1. Okay, dot to throw, and we have to throw which error actually. It should throw invalid box identifier. So level 1, expect this dot to throw, since it didn't throw. Why? Because we are not checking for number 4 here. Okay, so we have to check that if row less than 0 or row greater than 2, or call less than 0 or call greater than 2, we have to throw the same error here. Okay, if we are doing twice error like this, we can do is we can do inner class here, extends error. We can override the message equal to invalid box identifier error, and then we can do this invalid box name error. Okay, so then we can check with this, tests. Okay, apparently that didn't work. Expect this invalid box identifier at board.markboard. Okay. Okay, we have to actually create a function here instead. I think this should test correctly. Yeah, so we expect a callback function inside which we can do certain functions and expect this to throw. Okay, we can try out with a few more as well. So if I try out with a0, it should also throw. If I do a, b, c, if I do d1, this should also throw. If I do with a single letter a, that should also throw. If I do it with 3 letters, A, 0, 1, they should also throw. So that's sort of correct, where it checks all the possible cases. Does this test actually cover everything? Let's try all tests with coverage. We see that board.ts is still 84% covered. There are still places which are not covered. For example, the get functions are still not covered. Get row as string, get call as string, get diag as string. All of these are not covered. Okay, so we should write tests for these as well. Okay. So in fact, in the board, what happens is if I do get row as string and I pass something that's not ABC, then we should get this error. Okay. If call is wrong, I should get this error. And if diag is wrong, then I should get this error. Okay. So we need to handle that as well. So let's go for the tests. Okay, so here what we will do is expect, so we'll simply write const b equal to new board, and then we will do expect to throw. What do we need to throw? So for the row 1, b dot get row as string, and if I pass d, similarly now if I do get call as string and I pass 5, then my error has to be call has to be between 0 and 2, and then finally the diag one, if my diagonal is 4, then I need to get invalid diagonal. Okay, let's see, this test should also pass. Oh, I have forgotten calling assert at the end, signify the tests I went. The thing is that if I run all tests now with coverage, my board would almost be covered, 96%. The only thing is we have not tested the print board function. So while this is not a functional thing, it's just a printing, we can add a test for that if we need to, if print board was returning something. Console.log functions can't really be tested. So that's test for the board. So we should then similarly have tests for our game as well, for our player as well. Okay, player, we should just need a builder test that player can be built. Game, we need to do the entire test of the logic, can check winner, check the prompt, check play, all of that stuff we need to check for, and we need to write tests for the same. Okay, so I'm updating all of these things. I would just add a commit for this. Tests for the board logic is done. So actually on the same repository where we had the problem statement, there we have the solutions in TypeScript as well. Okay, and here there are the test files written that I've just added the tests. The code for the board is also there, the code for the board, the game, and the players and everything. So the entire solution is also there, the same repository. So you can go there and check the code. I would actually update the code with the tests for the game and the player as well. Okay. So the next question that comes, of course, is like, what are the things which are actually not extensible, which not designed well yet in this game, and we can make them extensible. We can make them better designed than what they currently are. So for that, I'll just remove the coverage side of everything. Yeah. So for example, the board hard coded to 3. We read that one of the things that it wanted was the problem said that you need to make it extensible to change the size of the grid, allow different types of pieces. Different types of pieces actually we have already allowed. More than 2 is something that we have sort of not allowed yet. Okay, So how do we do those kind of things as well? So to do those kind of things, first of all, let's say for example the board, this grid, this format, not good. We change this to what we will do. We will have a const here, const board default size equal to 3. Okay, what we will do here is we will create a constructor for the board, and the constructor, we instead of taking the grid, actually we will not take, we will take here size number equal to board default size. So if no size is given, we will take the default size. What we will do, we will do this dot grid equal to an empty array. Then for let I equal to 0, I less than size, I plus plus. What do I do? Grid, this dot grid, and inside that we push new array of size, whatever the size is, grid size, and we fill it with underscore. Okay, that's it. So that way, and then we have to change the print board part as well. So the print board part, actually I will change it a little bit. So instead of doing a console log, we will actually return a string actually rather than print board. So there are a couple of places. There's only one place where print board is called. So we'll call it get board for display. Okay, and what we will do here is we'll do like this, return this dot grid. So actually we will do like this, const display rows equal to an array. Okay, we will do for row, for let row of grid, display rows dot push this dot grid dot join with tab, actually this dot, sorry, this row dot join with a tab. Awesome. And then we will do return display rows dot join with a new line. Okay, so then wherever we had this in the game function print board, we will do, instead of this, in the next turn prompt, what do we do? This dot board dot get board for display, get board for display, and then we have this turn message. Okay, or we do this and plus slash n plus, and we have this string. Okay, so we do this plus slash n plus this. Okay, get board for display like this. So let's see how our board looks like now. Player one name Kate, let's say Roman, something like this. Okay, so board looks like this. Enter box A2, A3. Awesome, works, right? So that's how our board looks like now. We can add, let's say, maybe initially some this as well, so that way. So now we have some space after each as well. Okay. One part not covered is, so my board can be constructed with any size now, though we don't know what's going to be the row numbers and all, etc. Okay. So what we can do is, okay. So what we will do is we can maybe use all the letters. We can put the upper limit at, let's say, 26 or something like that. So up to 10, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now what we will do is, we will do this. Rows dot index of. So if it is greater than 0 or greater than, so we need to actually store the size of the board as well. So our board of size would be size. So this dot size equal to size. Okay. So now we will write if row is greater than this dot size, call 0 or call is greater than this dot size. Okay. Similarly, get row as string. So this would be rows dot index of this row has to be 1 off, and we can do here rows dot substring. We can do 0 comma this dot size. Okay. And again here we can rows dot index of row name, get call as string. So get call as string would be this dot size from here to size. We can't print it this way anymore. We will have to handle this using a for loop now. So what we will have to do is, we'll have to do call vals dot push, this dot grid, I, and call. Okay. And then we will return call vals dot join. Okay. Have to do the same thing with diagonals. So if diagonal is 0, we will have to return again for loop. We will have to do basically. So right. So if this, then for let I equal to 0, I less than this dot size I plus plus, and we have to do diagvals dot push this dot grid I comma I, right. We have to do I and this dot size minus I for the other one. So for this one we will have to do I and this dot size minus 1 minus I. Okay. So if it is 3, then it will be 3 minus 1, 2, 1, 0, like that, right? So then we will have to do return diagvals dot join. here also return dag files dot join. Okay, so we have made these changes. We haven't made any changes in the test board. Let's see if all the tests work or not. So we have to update some tests. So the tests that need to be updated is, so here what happens is that A4 invalid box identifier should have not coming, which means we will have to go to mark board and check why is it not coming. So if row is greater than or equal to, we will have to do, and call greater than or equal to, we will have to do, to run again and see. So get row as string, here also we will have to check this. So if row equal to, we'll have to do like this. Okay, so if row num, so if row num is -1 or row num greater than equal to this dot size, this dot size is supposed to be a number, right? Let me see. Sorry, row num. Yeah. Got it. Now let's see. So here there is a little bit of an issue. So because the error is not constant anymore, right? So we can't expect exactly same issue here. So what's happening here is when we are checking, this row has to be one of, this is the expected error here. So inside tooth row, of course, we will have to we can't have exactly the same string actually. So what we can do is rather than this, we can pass here something that do row number is invalid, and maybe we can, that's the same error that we can do there. Okay, this way at least we will get the errors to match. We can mark with regular expression the initial part of the error as well, but nevertheless. Now you see we have done this exercise which makes our board actually, on the error side. So there are a couple of things. Having these tests help us in one very important thing. As you can see, I did not change anything in the tests. But as soon as I updated my board, some of my tests started failing, which means that there were certain parts of my board's checks which were not correctly done after the extension. So that's why having tests help. And in most cases, like for example, in the test, the only thing I needed to actually change in test was this error name actually, because we are having a little bit of difficulty matching the error name. We can actually make that work correctly using error types rather than error names like this. But nevertheless, as you can see, these errors I did not change. Like these are the lines which are changed actually. These gray identifiers here, as you can see. So as you can see, there's nothing inside board that has changed. The board test that has changed. Just by updating board, we were able to run the tests and see that whether the tests are passing or not, because the test should continue to pass, because although I made my board class more extensible, the previous functionality for the hard-coded board class of 3 rows and calls should continue to work nevertheless. I mean, I have expanded the functionality, but it does not mean old functionality should stop working. So that's one of the, test, that's a validation that the test we had written was correctly written, because these tests continue to work even after I have refactored my board class logic. So my board class is now pretty extendable. I can create a board of any size that I want to. We can, in the main player, we can get any type of size of the board that we want to, but our logic in the game will not match if the size of the board is not correct actually. So we have these hard-coded logics here which will not match, and the reason they will not match is also because game, we don't have tests yet for the game. So because our board is now extendable, but the game is hard-coded to 3 size boards. So we need to fix these. Okay. So let's see how we can fix that as well. Or maybe you can try and fix that, send a pull request to this repository which where our code is. But for now, the board has become extendable. The game we still have to fix. Okay.
What's the first advice that I give to any candidate before they begin with their technical interview? Don't jump onto coding directly. Make sure that you explain your approach, the choice of data structures and algorithms with logical reasoning, and then only move to coding. Similarly, whenever you are starting with a project or any product development, make sure you don't jump onto it without proper planning. Now, what do I mean by proper planning? I think this video is going to be an interesting journey for you all. We are going to talk about software architecture design. What things you should be cautious about while planning your software. What things are important from a technical perspective as well as a customer's perspective, and so on. But which product should I talk about for this demonstration? I think we should choose a social media platform. And at this point, I know you have guessed it right. It's going to be Twitter, my most favorite social media platform. So we are going to go through a broad overview of designing Twitter's software architecture from scratch. Let's begin. The first part of any software architecture plan is to gather the requirements. What features should your product support? We need to understand this from different perspectives. Like, what are the pain points of the customer? What is the customer looking for? What are the wants and needs? How feasible are these features from a technical point of view? We should gather all of these requirements before jumping on to the architecture design. Understanding technical feasibility will not always be as straightforward in the beginning. You might be required to travel further down the road of designing the product. You may require to break your software architecture down into multiple layers and understand how each of the technical components in this layer interact with each other within and across the layers. Whenever you think about the requirements, consider both functional and non-functional requirements. Functional requirements are the ones which are critical for the product to be called a successful one. For example, in case of Twitter, it's going to be user should be able to create a profile, follow other profiles, tweet about something, scroll through the home or user timeline, and like a tweet, and so on. Whereas in case of non-functional requirements, it affects the user experience but not necessarily the features that are exposed to the user. For example, performance of the system, reliability or uptime of the system, and so on. I know complex products like Twitter will have a lot more features and requirements, but for the purpose of this video, let's stick to the ones that I mentioned above. Why is setting requirements so important before starting a design plan? Because most of your design will be influenced by your requirements. And once you have noted down your requirements properly, a lot of your technical options will be decided for you. That's how powerful the influence of functional requirements is. Now we'll move towards breaking the entire system into smaller components so that it's better for us to visualize them as individual systems and design them better. Earlier, when we were talking about the requirements, we were looking at an eagle's point of view. Now we'll move from a high-level design to a low-level design of Twitter's software architecture. When you move from requirements phase to planning phase, think of the system as individual layers. It can be very helpful. Think of your product as a cake, where each piece of a cake is a different feature that your product is supporting, and each layer of the cake is a different component interacting with each other in the backend. Most usually, each piece, which is a feature, will have all the layers, which are the components which are interacting in the backend with each other. I hope this horizontal and vertical slicing of features and components help you understand how a product can be designed both vertically, feature by feature, or horizontally, component by component, or usually hybrid, which is the case with most of our development. There are two major components when it comes to the design of any software architecture. Number one, database design. Number two, backend interactions, how the information flows between the servers in the backend. Now, from the requirements, it's pretty clear to us that we need to leverage the functionalities of a relational SQL database because there is a relation between our users and the tweets. Whenever a new user is created, we will store that information in a new table, users table. We won't be storing the tweets in the users table. We will have a separate table
to store the tweets which will be related to the users table, where the user ID is going to be our foreign key. Now, when we talk about the follower interaction, we can easily add a list of all the followers in the users table column, but that is an inefficient design. For this purpose, we will create a new table where each column belongs to a unidirectional relationship between a profile getting followed and the profile following the other profile. At this point, we can summarize two things. There is a one-to-many relationship between the users and tweets table. A user can do multiple tweets, and there is a many-to-many relationship between the users for the followers relationship. One user can follow many users, and many users can be followed by one user. At this point, I think our database design looks fine, but we might need to revisit this design when we are discussing the serving flows. Now, let me talk about an issue so that I can highlight you what issues can come up in the future. Let's say a user is requesting for home timeline. For this purpose, we need to find out all the profiles that the user is following. Then we need to query all the tweets done by those profiles, sort them in chronological order, and then return them. Can you visualize an issue creeping up with this thing? Don't worry if you don't. I will talk about some of the important characteristics of Twitter as a product, which will help you realize what issues can come up for this serving flow. Twitter has 300 million daily active users and 6,000 tweets done every second. Also, 600,000 queries are made to fetch different timelines. This brings to light an important discovery which shows that Twitter is a read-heavy system. We are fine with eventual consistency. It's completely normal if a user is not able to see a tweet of one of the profiles eventually. Space is also not a huge constraint because all of our tweets are character limited. As we discussed in our characteristics, Twitter is a read-heavy system. So the brute force fetch operations that we are performing might not be efficient on our databases. We need something which allows us to read faster and can also scale horizontally on the fly. The first thing that comes to my mind is Redis cluster. Yes, that's how powerful the requirements are. We can't solely rely on Redis cluster, so we will be storing both the user and tweet info in the Redis cache as well as in our database for backup. With this design in mind, we can check off some of our feature requests like creating a user profile, following a user, publishing a tweet. Now, let's dig a little deeper into two of our query flows where we fetch user timeline and home timeline. Let us begin with designing our user timeline flow since that's more simpler and lesser in scope as compared to our home timeline. If you remember my previous discussion, we talked about different pieces of cake and different layers inside a cake. So currently what we are trying to do is to design a piece of cake where we'll try to leverage different pieces or layers of the cake which we have already discussed. So in order to fetch a user timeline, the first thing we need is the user ID of the timeline we want to fetch, which we can query from the users table. After we get that user ID, we will query the tweets table to get all the tweets for that particular user ID and then return it to the requesting user by sorting them in chronological order. Now, Twitter is a read-heavy system and hence querying the database for this purpose can be very cost-heavy. So, we will introduce a caching layer in our Redis cluster which will store all the information about the tweets that the user has made and query the information from this cache instead of querying the database, since querying from cache is faster as compared to querying from the database. Now this solution might serve sufficient for our user timeline flow. Let's move on to the home timeline. Let's say I am requesting for the home timeline. For this purpose, we would require all the profiles that I follow, which we can fetch from the followers table. After getting all those user IDs, we need to fetch all the tweets made by those users from the tweet table, merge those tweets and sort them in reverse chronological order and return to the requesting user, which is me. Now we can see an obvious drawback in this solution. This solution will be very inefficient once the size of the tweets database grows to millions of data rows. For this purpose, we need to revise our serving flows and update our design. In order to overcome this issue, we will follow a fan-out approach where we will move from a single data source to multiple data sources, one for each of our users. For this purpose, we will have an in-memory home timeline for each of the users, where the home timeline will contain the tweets by all the profiles that the user is following. Now let's say I have 10 followers. So whenever I will tweet something, this tweet will flow through the load balancer into the server and stored inside the backend, both database and the cache. Now the server will query all of my 10 followers from the followers table stored in the cache, and through the fan-out approach, we will inject this tweet into the home timeline of all of my 10 followers we fetched from the cache. Now, one issue that might come up with this approach is, let's say I have millions of followers. Now, it's practically not possible to inject my tweet into millions of followers' home timeline at runtime. For this approach, we have a special solution where we will use synchronized calls along with fan-out approach. What this approach means is that for profiles who have immense amount of followers, like thousands and millions of followers, we will not inject their tweets into the home timeline of their followers. Instead, now my home timeline will only contain the tweets by the profiles that I follow and don't contain large amount of followers. So now what will happen is that my home timeline will only contain the tweets by the profiles that I follow and don't have large number of followers. Also, my followers table in the cache will store a list of profiles that I follow and have large number of followers. So during runtime, what we'll do is that we will try to send synchronous calls to all of these profiles having large number of followers and fetch their tweets, and merge them with the pre-computed home timeline of the followers that I follow but don't have large number of followers. In this way, we will try to leverage both the parts, where we will use the pre-computed home timeline as well as compute the tweets of the profiles that have amazing number of followers on the fly and mitigate the issue in this way. Now, there are so many other optimizations that we could deploy. Let's say, for example, there are some profiles who haven't been very active lately. So for such profiles, we don't need to pre-compute the home timelines. There are so many other optimizations we could deploy, but for the sake of this software architecture design demonstration, we will restrict ourselves to only these ones and move ahead with other feature developments. Now, among the major requirements which we discussed earlier, the only piece of cake left to be designed is the search engine. For searching, Twitter uses Earlybird, which is a real-time inverted index based on Lucene. Whenever a tweet is posted, Earlybird will do an inverted full-text indexing operation. The tweet will be broken down into bits, words, and tags, and each of these words is stored or indexed into the distributed table, which will contain reference to all the tweets which contain that particular word. Now let's say I search for a word, for example DSA. Okay, so now we will find that word in the distributed table and return the reference to all the tweets which contain the word DSA. From this reference, we will return all the tweets belonging to that reference from the tweet table. As we recollect the earlier characteristics, we know that Twitter is read heavy. It receives tremendous amount of search queries. In order to enable fast searching capability for all the users across the globe, Twitter deploys a scattering and gathering tool. What this means is that the search query is distributed across different data centers globally, and each Earlybird shard is queried for that search operation. Now all the tweets returned from these individual shards are merged, re-ranked, sorted, and then returned to the user based on the popularity of that tweet. Now I feel that we have established a very solid base for our Twitter's architecture design. We have discussed about the functional requirements as well as design for some non-functional requirements, which included performance issues, scalability, and by further optimizations, we resolved all of those issues. Let me share a few good tips for software architecture design. Use diagrams to visualize your concepts, different technical options you have considered, and any serving flow involved in your design. Now, when you are designing for the first time, don't try to fit your design to some pattern. Instead, focus on the high-level design, covering all the components, how they interact with each other to avoid over-engineering. Remember, your first design is just an iteration. You will move through some innumerable iterations to finally something that can be implemented. When you are designing, it's very natural to allow scope creeping by adding a lot of other requirements. Make sure that you discuss the functional and non-functional requirements with the stakeholders and are aligned with them. Software architecture design is more effective when there is stakeholder input and a proper mapping of requirements to design. Don't skip on this early planning and you will surely be rewarded with smoother project experience. I really hope this video was very insightful for you to start your first software architecture design from scratch. If you find this content interesting and insightful, do like this video, share your thoughts in the comment section below, make sure you subscribe Scalar's YouTube channel and don't forget to hit the bell icon so that you never miss notifications for amazing content.